Yeah, there's something subjective also about that, right? I've been thinking a lot about that, especially in the human robot interaction context. I mentioned Spot, the Boston Dynamics robot. There is something about human robot communication. Let's put it in another context. Something about human and dog context, like a living dog, where there's a dance of communication. First of all, the eyes, you both look at the same thing, and dogs communicate with their eyes as well. Like if you and a dog want to like deal with a particular object, you will look at the person, the dog will look at you and then look at the object and look back at you, all those kinds of things. But there's also just the elegance of movement. I mean, there's of course, the tail and all those kinds of mechanisms of communication. And it all seems natural and often joyful. And for robots to communicate that is really difficult how to figure that out, because it's almost seems impossible to hard code in. You can hard code it for a demo purpose, something like that, but it's essentially choreographed. Like if you watch some of the Boston Dynamics videos where they're dancing, all of that is choreographed by human beings. But to learn how to, with your movement, demonstrate a naturalness and elegance, that's fascinating. Of course, in the physical space, that's very difficult to do, to learn the kind of at scale that you're referring to. But the hope is that you could do that in simulation and then transfer it into the physical space if you're able to model the robots efficiently, naturally.
Yeah. And sometimes I think that requires a theory of mind on the on the side of the robot, that they understand what you're doing because they themselves are doing something similar. And that's a big question too. We talked about intelligence in general and the social aspect of intelligence, and I think that's what is required, that we humans understand other humans because we assume that they are similar to us. We have one simulation we did a while ago. Ken Stanley did that. Two robots that were competing, simulation, like you said. They were foraging for food to gain energy. And then when they were really strong, they would bounce into the other robot and win if they were stronger. And we watched evolution discover more and more complex behaviors. They first went to the nearest food, and then they started to plot a trajectory so they get more. But then they started to pay attention what the other robot was doing. And in the end, there was a behavior where one of the robots, the more sophisticated one, sensed where the food pieces were and identified that the other robot was close to two of a very far distance, and there was one more food nearby. So it faked. Now I'm using anthropomorphized terms, but it made a move towards those other pieces in order for the other robot to actually go and get them, because it knew that the last remaining piece of food was close, and the other robot would have to travel a long way, lose its energy, and then lose the whole competition. So there was like emergence of something like a theory of mind, knowing what the other robot would do, to guide it towards bad behavior in order to win. So we can get things like that happen in simulation as well.
But that's a complete natural emergence of a theory of mind. But I feel like if you add a little bit of a place for a theory of mind to emerge like easier, then you can go really far. I mean, some of these things with evolution, you add a little bit of design in there, it'll really help. And I tend to think that a very simple theory of mind will go a really long way for cooperation between agents, and certainly for a human-robot interaction. Like, it doesn't have to be super complicated. I've gotten a chance to, in the autonomous vehicle space, to watch vehicles interact with pedestrians, or pedestrians interacting with vehicles in general. I mean, you would think that there's a very complicated theory of mind thing going on, but I have a sense it's not well understood yet, but I have a sense it's pretty dumb. Like, it's pretty simple. There's a social contract there where between humans, a human driver and a human crossing the road, where the human crossing the road trusts that the human in the car is not going to murder them. And there's something about, again, back to that mortality thing, there's some dance of ethics and morality that's built in, that you're mapping your own morality onto the person in the car. And even if they're driving at a speed where you think if they don't stop, they're going to kill you, you trust that if you step in front of them, they're going to hit the brakes. And there's that weird dance that we do that I think is a pretty simple model, but of course it's very difficult to introspect what it is. And autonomous robots in the human-robot interaction context have to build that. Current robots are much less than what you're describing. They're currently just afraid of everything. They're not the kind that fall and discover how to run. They're more like, please don't touch anything, don't hurt anything, stay as far away from humans as possible, treat humans as ballistic objects that you can't, that you do with a large spatial envelope, make sure you do not collide with. That's how, like we mentioned, Elon Musk thinks about autonomous vehicles. I tend to think autonomous vehicles need to have a beautiful dance between human and machine, where it's not just a collision avoidance problem, but a weird dance.
Yeah, I think these systems need to be able to predict what will happen, what the other agent is going to do, and then have a structure of what the goals are and whether those predictions actually meet the goals. And you can go probably pretty far with that relatively simple setup already. But to call it a theory of mind, I don't think you need to. I mean, it doesn't matter whether a pedestrian has a mind. It's an object, and we can predict what it will do. And then we can predict what the states will be in the future and whether they are desirable states. Stay away from those that are undesirable and go towards those that are desirable. So it's a relatively simple, functional approach to that. Where do we really need the theory of mind? Maybe when you start interacting and you're trying to get the other agent to do something and jointly, so that you can jointly, collaboratively achieve something, then it becomes more complex.
Well, I mean, even with the pedestrians, you have to have a sense of where their actual attention in terms of their gaze is, but also like attention. I mean, there's this vision science, people talk about this all the time. Just because I'm looking at it doesn't mean I'm paying attention to it. So figuring out what is the person looking at, what is the sensory information they're taking in, and the theory of mind piece comes in is what are they actually attending to cognitively, and also what are they thinking about? Like what is the computation they're performing? And you have probably maybe a few options. For the pedestrian crossing, it doesn't have to be, it's like a variable with a few discrete states, but you have to have a good estimation which of the states that brain is in for the pedestrian case. And the same is for attending with a robot. If you're collaborating to pick up an object, you have to figure out, is the human like there's a few discrete states that the human could be in, and you have to predict that by observing the human. And that seems like a machine learning problem to figure out what's the human up to. It's not as simple as sort of planning. Just because they move their arm means the arm will continue moving in this direction. You have to really have a model of what they're thinking about and what's the motivation behind the movement of the arm.
And here we are talking about relatively simple physical actions. But you can take that to higher levels also, like to predict what the people are going to do. You need to know what their goals are. What are they trying to? Are they exercising? Are they just trying to get somewhere? But even higher level, I mean, you are predicting what people will do in their career, what their life themes are. Do they want to be famous, rich, or do good? And that takes a lot more information, but it allows you to then predict their actions, what choices they might make.
I mean, this is exactly what OpenAI and DeepMind at Google are. I don't know if you've seen, but there's something called reinforcement learning in artificial intelligence, where you have like they've done it for like sumo wrestling. You have these two stick figures that don't even know how to get up at first, and they figure out how to stand on their 2 feet, and then they figure out how to push the other person off of the pedestal.
Wait, but what about like when you look at the Boston Dynamics? Sometimes they have trouble with like jumping and balancing and the other stuff. So are they doing that same program or no?
No. This is different. Everything Boston Dynamics is doing is hard coded. So it's not learning all the sophisticated movements and strategies, like high-level strategies of movement, that's all something that Boston Dynamics does not do. And if it does it, like the parkour stuff, that's all hard-coded in.
Oh, interesting.
People like project and think like these robots have like discovered like how to move in sophisticated ways they haven't.
That's what, when you and John were talking about the grappling robot.
Yeah.
I mean, the one thing I was obsessing about in my head is that with the chess, right? If a chess piece moves, right, the horse can move like an L, right? It can only move like an L. It doesn't matter if it moves at 2 meters per second or 7 meters per second. It can only move there, right? Mm-hmm. Whereas like a single leg, I can shoot a single leg with many different velocities. Mm-hmm. I can shoot at different angles. I can shoot with different amounts of force. Right, I can shoot with my head up versus my head. I mean, right, all these things are going to matter. If we're talking about a human being defending the single leg, all of those things are going to matter, and that's where human beings are who wrestle are calculating those things subconsciously. They're obviously not consciously calculating in their head. Oh, the force is coming at me at this, so I need to do that. Right, they're just doing it because.
But see, the thing is, so you would absolutely, if you're doing a robot that you're wrestling, you're going to have to constrain the speed at which it moves and the power that it's able to deliver. So that presumably there'll be the limitation. So then it'll be just the same exactly as a human.
But even so, if we go human max force, right? Jordan Bros double max force, mm-hmm. right? That's the highest we get, and then we go down from there. Even within that. It's like sometimes I can shoot a single leg with a maximum force of we'll say 20. This is a number, right? Mm-hmm. I don't always shoot it at 20 because I feel sometimes I shoot at 15, sometimes I shoot at 12, right? Because you feel something in your opponent that makes you do it differently. Yeah. So they would have to learn how, and then all of these different things, and sometimes maybe I clamp a little harder. So the robot would have to learn all of these different incoming inputs to the system and then create this reaction.
Oh, no, 100%. So this would be all continuous. Like, so unlike chess, it would not be. It's just chess is discrete. It's
one and
you move. It's a very specific set of moves. No, here those are all variables you control, and they're continuous variables. So the speed, the force, there's actuators. So there's all these joints, right?
Yeah.
You can move. I mean, it's just an optimization problem.
It's kind of it was fascinating. So I've been fascinated thinking about it since you guys talked about it. It was a long time ago. I listened to it probably 3 to 4 weeks ago, and I've kind of been like obsessing about it ever since.
It just changes when. So unlike boxing, for example, or striking, once you grab a hold of somebody, it changes. You're now one body, right? So it's very complicated. It's not just shooting a double leg without, like, maybe doing like faking a double leg and then shooting the double leg. That's very doable with robotics. But then like doing a clinch and from there doing like a Russian tie, like that. Yeah. That's I think that's way harder than people realize in terms of how many things are involved, like the force of the grip, the leverage you're providing with all the different parts of the shoulder and the arm and the torso, the twist, how much of your weight are you allocating, like leaning on the other person, like taking weight off of one of your legs and the other leg, all of that. I think that's the really interesting thing about humans is we're able to do all of this calculation
subconsciously.
Yeah, subconsciously.
Yeah, and that's what I've been thinking about since it's like how many things even these high school athletes who are like getting medium good are subconsciously thinking about all the time, or not even thinking about, reacting to. But then even like for me, I'm a few orders of magnitude better than some of these kids that play. And so when I go like super hard, it's like I can feel their weight moving the wrong direction. And so for me to off balance them or trip them or whatever is kind of easy sometimes, because they're not feeling it the right way, right? Or their timing's just a little bit off, or the way they're grabbing the hip, maybe they should be up a little higher, right? These really small things.
I think that's all easy to take advantage of for a robot. It's just there's so many things. The big problem is ethically, I don't know how many people are willing to train with a robot because you're going to get hurt.
Well, couldn't you make a robot train with a robot or no?
Yes, but then it's expensive. So because they're going to
put the padding on that thing.
I know, but then it's not, it's then you're not capturing the full.
Why can't you put like some rubber coating on them, or something to that effect?
You could. I mean, you could.
Yeah.
You could. I mean, you're talking about robots these are humanoid robots. So we're talking about $500,000 million robots. Mm-hmm. So you would have to be motivated
spend a lot of money.
To spend a lot of money because you have to have them wrestle for like a lot
to get better.
Yeah, to get better.
Yeah. And
then the open question is, how long does it take to get good enough to beat a human? I don't think we understand. I don't think you understand how hard wrestling is.
Yeah.
Like, is it a really hard problem? Like, what's harder, chess or wrestling?
Wrestling, by far. Not even close.
That's the sense.
So, because there's an infinite amount of moves, right? And possibilities. So once I shoot the single leg, now you have X amount of choices. Once you make your choice, now I have a choice, X amount of choices. Now you have X amount of choices on the defense. And we can just keep going back and forth, right? And this number becomes...
Yeah, but the same happens with chess.
Correct. But then in wrestling, you have to make these movements very instantaneously, right? Because if I shoot a single leg, I'm not going to wait and say, what's your defense?
Yeah.
Right? You have to make it instantaneously. And then also, again, based on the force and the vectors and the angles, you have to calculate that and adjust. So really, if you're saying, well, I can shoot a single leg, it's not like moving the chess. It's not one move, right? It's, if you want to talk about different forces and stuff, it could be hundreds or thousands of different moves based on how hard I shoot it, the angle, the direction, all of those things.
Yeah, but wait a minute. So robots can do this kind of stuff really fast. People probably know the physiology of this, but it's the reaction speed for a human is maybe 100 milliseconds, something like that. I don't know, from sensation to like from the signal traveling up to your brain and down. I don't know what that number is, but robots certainly could do it way faster. You would actually have to like constrain the speed.
Well, so the robots are already killing the chess people, right?
Yes.
So yeah, theoretically they could eventually beat wrestlers. But you asked what was harder, wrestling or chess? Yeah, and I think wrestling is, because of the time component in it, and then and the physicality of, is it this force or that force? Because if I'm going to say we're in a seatbelt side by side, right? A wrestling seatbelt, not jiu-jitsu. Based on the pressure you're giving me, I might do a bunch of different things, right? And so, like, to an untrained eye, they might both look like the same thing from you. To a trained feel, it's like, well, in one case, it's really evident I should go this way. In another case, it's really evident I should go that way.
So the other thing to consider, just like with chess, the AI systems, so human versus human play a certain way together. They actually haven't considered a really large number of strategies that AI systems discover. So one possibility with a robot, they'll discover certain ties and certain takedowns.
That's what I'm saying.
That like will dominate no matter what the human does.
You think that? So you think there's that? So this is what I'm talking about. The wrestling's so fun is there's, even after 80, 90 years, there's this continuous evolution.
Yeah.
So
there'll be some like low single type thing, like John Smith type of situation.
Well, like a down block go behind is something that has really, I would say, really in the last 5-ish years has really been evolved.
What's a go behind?
Down block go behind. So when you they just head inside or head outside matters, but there's one for both. You shoot at me essentially. I take my leg, like boom, and then so that was kind of in existence when I was in college, right? You down block them and you stop, but usually you hit on this side of their head, right? And now immediately as you shoot, I attack that shoulder, and then I start hitting a go behind on you, right? And so like that in its current incarnation, it absolutely wasn't around when I was in college. I would say it probably became popular, I don't know, 5 to 7 years ago. So yeah, there's these big things that are happening. Now I really want a robot because I want to be ahead of the game. I want to know what I'm missing.
I mean, one interesting thing you have with AlphaZero that plays chess is it sacrifices pieces much more than humans do. So it'll give you a piece, and not only does it give you a piece, it will wait a bunch of moves before it makes you pay. So
because it knows that that's better for the long term.
Long term. So like humans rarely sacrifice without getting the piece back like 2 or 3 moves after. AlphaZero can wait like 5 moves. So basically you potentially with wrestling, you might have a robot that like puts itself in bad positions, but in a certain kind of way that will actually
lures the opponent in to trap.
Exactly.
That's what my style's based on.
You basically narrow one thing to do is you narrow the set of choices. You put yourself in a bad position, but it narrows the set of choices
for them because they're not used to it.
Yeah, they're not used to it, and then you drag them into your So, but there's also the problem is there's mechanical issues. Like it's actually just difficult to build robots that are able to sense because we have sensation throughout our body. Yeah. It's just difficult to build that kind of robot. It's expensive. You start talking about multi-million dollars, and then people start asking you questions. Why did you invest all of this money?
I want to see what moves they do. Duh. Hello.
It could be a better investment. Okay. So I mentioned John Smith. He is, if people don't know, one of the great wrestling coaches ever. He's also creative like you. He spoke really highly of you. What do you think about that guy? Did you guys ever work together?
Not really. So you know what? When I was a senior and I had the people wrestling in my head, I was lucky enough to be doing. I was pretty much graduated, so I did an independent study with the sports psychology. I was potentially going to go to grad school for sports psych. Well, I actually did 9 credits, and then I just decided I didn't want to do it anymore. I continued learning on my own. But I had an independent study with the guy who was the head of USA Track and Field Sports Psych. So the class was I got to go sit down and talk with him for an hour. And he was like fascinated by me. So he didn't really make me do homework. It was like the greatest 3 credits ever. We just talked. I learned so much. It was so awesome. But so one time it came up that I had these people wrestling in my head, and he said, well, who else do you think? I said, I bet John Smith happened. So I went and got John Smith's number and called him and said, hey, you ever had these people wrestling in your head? And he said, yeah, but as soon as I stopped coaching, they went away. Same thing happened to me. As soon as I started coaching, they went away. So if I really force myself now and I'm like, I see something in practice, and it's really higher level because high school wrestling, I don't want to make you guys feel bad, but it's a little bit lower level, right? So if like Keegan, for example, who won the journey, if he's struggling with a problem or asks me a question, and I can force myself to like see the bodies moving and think about it again, kind of like I was in the early age, but it won't just flow there anymore. So he said it went away, and for me, it went away also.
By the way, if you can pause on the on the bodies in your head.
Yeah.
How are they generating new ideas? Are they just kind of?
I don't know. You tell me.
So they're just like scrambling in your head.
It would be specifically based on a problem I was struggling with, or a specific position.
Okay, so kind of it goes in for a single, and then go from there.
Yeah. So like I'm sitting in geography class, and I don't have to work that hard because it's easy, right? And I'm just sitting there like kind of acting like I'm looking at the board, and these guys are wrestling, and I'm watching them wrestle, and sometimes they come up with a really good solution.
Is there somebody you looked up to style wise? Like Gable, John Smith, all these like legend status people.
Probably John Smith, but after the fact. So the problem with wrestling in my era was you couldn't watch it. There was no access, right? It wasn't really available. Even if you want to say, go find a bunch of John Smith matches, they're kind of hard to find, right? There's a couple of them on YouTube, but I've obviously seen all of those. But in my era, there really wasn't any of it. So it was hard to be a fan of something, and that's why wrestling has. The fans are going like this because now, you flip on the Flow app and you can watch, something that's happening in Europe, right? We can do this easily. So we can be a fan of people. So now I'm more a fan of wrestling than I was then because there just was no access. So now I can watch someone I like and say, oh shit, like that guy's wrestling. Oh, boom, I flip my phone on, I watch them wrestle, that type of thing.
You co-taught robot ethics at Harvard. What are some ethical issues that arise in the world with robots?
Yeah, that was a reading group that I did when I, at the very beginning, first became interested in this topic. Right. So I think if I taught that class today, it would look very, very different. Robot ethics, it sounds very science fiction-y, especially did back then, but I think that some of the issues that people in robot ethics are concerned with are just around the ethical use of robotic technology in general. So, for example, responsibility for harm, automated weapon systems, things like privacy and data security, things like, automation and labor markets. And then personally, I'm really interested in some of the social issues that come out of our social relationships with robots.
One-on-one relationship with robots.
Yeah.
I think most of the stuff we have to talk about is like one-on-one social stuff. That's what I love. I think that's what your
you love as well and are expert in. But at societal level, there's like, so maybe drifting into the land of more personal relationships with robots and interaction and so on. I got to warn you, I may ask some silly philosophical questions. I apologize.
Oh, please do.
Okay. Do you think humans will abuse robots in their interaction? So you've had a lot of, and we'll talk about it, sort of anthropomorphization and work, this intricate dance, emotional dance between human and robot. But there seems to be also a darker side where people, when they treat the other as servants, especially, they can be a little bit abusive or a lot abusive. Do you think about that? Do you worry about that?
Yeah, I do think about that. So, I mean, one of my main interests is the fact that people subconsciously treat robots like living things. And even though they know that they're interacting with a machine, and what it means in that context to behave, violently. I don't know if you could say abuse, because you're not actually, abusing the inner mind of the robot. The robot doesn't have any feelings.
As far as you know.
Well, yeah. It also depends on how we define feelings and consciousness, but I think that's another area where people kind of overestimate where we currently are with the technology. Like, the robots are not even as smart as insects right now. And so I'm not worried about abuse in that sense, but it is interesting to think about, what does people's behavior towards these things mean for our own behavior? Is it desensitizing to people to, be verbally abusive to a robot or even physically abusive? And we don't know.
Right. It's a similar connection from, like, if you play violent video games, what connection does that have to desensitization to violence? That's actually, I haven't read literature on that. I wonder about that. Because everything I've heard, people don't seem to any longer be so worried about violent video games.
Correct. We've seemed, the research on it it's a difficult thing to research, so it's sort of inconclusive, but we seem to have gotten the sense, at least as a society, that people can compartmentalize. When it's something on a screen and you're like, shooting a bunch of characters or running over people with your car, that doesn't necessarily translate to you doing that in real life. We do, however, have some concerns about children playing violent video games, and so we do restrict it there. I'm not sure that's based on any real evidence either, but it's just the way that we've kind of decided, we want to be a little more cautious there. And the reason I think robots are a little bit different is because there is a lot of research showing that we respond differently to something in our physical space than something on a screen. We will treat it much more viscerally, much more like a physical actor. And so it's totally possible that this is not a problem. And it's the same thing as violence in video games, maybe, restrict it with kids to be safe, but adults can do what they want. But we just need to ask the question again, because we don't have any evidence at all yet.
Maybe there's an intermediate place too. I did my research on Twitter. By research, I mean scrolling through your Twitter feed. You mentioned that you were going at some point to an animal law conference. So I have to ask, do you think there's something that we can learn from animal rights that guides our thinking about robots?
Oh, I think there is so much to learn from that. I'm actually writing a book on it right now. That's why I'm going to this conference. So I'm writing a book that looks at the history of animal domestication and how we've used animals for work, for weaponry, for companionship. And, one of the things the book tries to do is move away from this fallacy that I talked about of comparing robots and humans, because I don't think that's the right analogy. But I do think that on a social level, even on a social level, there's so much that we can learn from looking at that history, because throughout history, we've treated most animals like tools, like products. And then some of them we've treated differently. And we're starting to see people treat robots in really similar ways. So I think it's a really helpful predictor to how we're going to interact with the robots.
Do you think we'll look back at this time, like 100 years from now, and see what we do to animals as, like, similar to the way we view, like, the Holocaust with World War II?
That's a great question. I mean, I hope so. I am not convinced that we will. But I often wonder, what are my grandkids going to view as, abhorrent that my generation did that they would never do. And I'm like, well, what's the big deal? Right. You know, it's a fun question to ask yourself.
It always seems that there's atrocities that we discover later. So the things that at the time people didn't see as, you look at everything from slavery to any kinds of abuse throughout history, to the kind of insane wars that were happening, to the way war was carried out, and rape and the kind of violence that was happening during war, that we now, we see as atrocities, but at the time perhaps didn't as much. And so now I have this intuition that I have this worry. Maybe you're going to probably criticize me, but I do anthropomorphize robots. I don't see a fundamental philosophical difference between a robot and a human being in terms of once the capabilities are matched. So the fact that we're really far away doesn't, in terms of capabilities, and then that from natural language processing, understanding, and generation to just reasoning and all that stuff, I think once you solve it, I see there's a very gray area, and I don't feel comfortable with the kind of abuse that people throw at robots. Subtle, but I can see it becoming, I can see basically a civil rights movement for robots in the future. Do you think, let me put it in the form of a question, do you think robots should have some kinds of rights?
Well, it's interesting because I came at this originally from your perspective. I was like, you know what? There's no fundamental difference between technology and like human consciousness. Like we can probably recreate anything. We just don't know how yet. And so there's no reason not to give machines the same rights that we have once, like you say, they're kind of on an equivalent level. But I realized that is kind of a far future question. I still think we should talk about it because I think it's really interesting. But I realized that it's actually, we might need to ask the robot rights question even sooner than that, while the machines are still, quote unquote, really, dumb and not on our level, because of the way that we perceive them. And I think one of the lessons we learn from looking at the history of animal rights, and one of the reasons we may not get to a place in 100 years where we view it as wrong to, eat or otherwise, use animals for our own purposes, is because historically we've always protected those things that we relate to the most. So one example is whales. No one gave a shit about the whales. Am I allowed to swear?
Yeah, you can swear as much as you want.
Woo.
Freedom.
Yeah, no one gave a shit about the whales until someone recorded them singing. And suddenly people were like, oh, this is a beautiful creature, and now we need to save the whales. And that started the whole Save the Whales movement in the 70s. So I'm, as much as I think a lot of people want to believe that we care about consistent biological criteria, that's not historically how we've formed our alliances.
Yeah. So why do we believe that all humans are created equal? Killing of a human being, no matter who the human being is, that's what I meant by equality, is bad. And then, because I'm connecting that to robots, and I'm wondering whether mortality, so the killing act, is what makes something, that's the fundamental first right. So I am currently allowed to take a shotgun and shoot a Roomba, I think. I'm not sure, but I'm pretty sure it's not considered murder, right? Or even shutting them off. So that's where the line appears to be, right? Is mortality a critical thing here?
I think here again, like the animal analogy is really useful because you're also allowed to shoot your dog, but people won't be happy about it. So we do give animals certain protections from, like, you're not allowed to torture your dog and set it on fire, at least in most states and countries, but you're still allowed to treat it like a piece of property in a lot of other ways. And so we draw these, arbitrary lines all the time. And, there's a lot of philosophical thought on why viewing humans as something unique is just speciesism and not based on any criteria that would actually justify making a difference between us and other species.
Do you think in general, most people are good? or do you think there's evil and good in all of us? That's revealed through our circumstances and through our interactions.
I like to view myself as a person who believes that there's no absolute evil and good and that everything is, gray. But I do think it's an interesting question. Like when I see people being violent towards robotic objects, you said that bothers you because the robots might someday, be smart and
Anki and Jibo, the two amazing companies, social robotics companies that have recently been closed down.
Yes.
Why do you think it's so hard to create a personal robotics company? So making a business out of essentially something that people would anthropomorphize, have a deep connection with. Why is it so hard to make it work? Is the business case not there, or what is it?
I think it's a number of different things. I don't think it's going to be this way forever. I think at this current point in time, it takes so much work to build something that only barely meets people's minimal expectations because of science fiction and pop culture giving people this idea that we should be further than we already are. Like when people think about a robot assistant in the home, they think about Rosie from the Jetsons or something like that. And Anki and Jibo did such a beautiful job with the design and getting that interaction just right. But I think people just wanted more. They wanted more functionality. I think you're also right that, the business case isn't really there because there hasn't been a killer application that's useful enough to get people to adopt the technology in great numbers. I think what we did see from the people who did, get Jibo is a lot of them became very emotionally attached to it. But that's not, it's kind of like the Palm Pilot back in the day. Most people are like, why do I need this? Why would I? They don't see how they would benefit from it until they, have it or some other company comes in and makes it a little better.
Yeah, like how far away are we, do you think? How hard is this problem?
It's a good question. And I think it has a lot to do with people's expectations and those keep shifting depending on what science fiction that is popular.
But also it's two things. It's people's expectation and people's need for an emotional connection.
Yeah.
And I believe the need is pretty high.
Yes. But I don't think we're aware of it.
That's right. There's I really think this is like the life as we know it. So we've just kind of gotten used to it. I hate to be dark because I have close friends, but we've gotten used to really never being close to anyone, right? And we're deeply, I believe, okay, this is hypothesis. I think we're deeply lonely, all of us, even those in deep, fulfilling relationships. In fact, what makes those relationships fulfilling, I think, is that they at least tap into that deep loneliness a little bit. But I feel like there's more opportunity to explore that doesn't interfere with the human relationships you have. It expands more on the rich, deep, unexplored complexity that's all of us. Weird apes. Okay.
I think
so what's your favorite robots in movies and fiction?
WALL-E.
WALL-E. What do you like about WALL-E? The humor, the cuteness, the perception control systems operating on WALL-E that makes it all work, which just in general?
The design of WALL-E the robot, I think that animators figured out, starting in the 1940s, how to create characters that don't look real, but look like something that's even better than real, that we really respond to and think is really cute. They figured out how to make them move and look in the right way. And WALL-E is just such a great example of that.
You think big eyes, or big something that's kind of eye-ish? So it's always playing on some aspect of the human face, right?
Often, yeah. So big eyes. Well, I think one of the first animations to really play with this was Bambi, And they weren't originally going to do that. They were originally trying to make the deer look as lifelike as possible. Like they brought deer into the studio and had a little zoo there so that the animators could work with them. And then at some point they were like, if we make really big eyes and like a small nose and like big cheeks, kind of more like a baby face, then people like it even better than if it looks real.
Do you think the future of things like Alexa in the home has possibility to take advantage of that, to build on that, to create these systems that are better than real, that create a close human connection?
I can pretty much guarantee you, without having any knowledge, that those companies are working on that design behind the scenes. Like, I'm pretty sure.
I totally disagree with you.
Really?
So that's what I'm interested in. I'd like to build such a company. I know a lot of those folks, and they're afraid of that because how do you make money off of it?
Well, but even just like making Alexa look a little bit more interesting than just like a cylinder would do so much.
It's an interesting thought, but I don't think people are, from Amazon perspective, are looking for that kind of connection. They want you to be addicted to the services provided by Alexa, not to the device. So the device itself, it's felt that you can lose a lot because if you create a connection and then it creates more opportunity for frustration, for negative stuff than it does for positive stuff, is I think the way they think about it.
That's interesting. Like, I agree that it's very difficult to get right and you have to get it exactly right. Otherwise you wind up with Microsoft's Clippy.
Okay, easy now. What's your problem with Clippy?
You like Clippy? Is Clippy your friend?
Clippy. Yeah, I miss Clippy. I just talked to we just had this argument. And so Microsoft CTO, and he said he's not bringing Clippy back. They're not bringing Clippy back, and that's very disappointing. I think Clippy was the greatest assistant we've ever built. It was a horrible attempt, of course, but it's the best we've ever done because it was a real attempt to have like a actual personality. I mean, it was obviously technology was way not there at the time of being able to be a recommender system for assisting you in anything and typing in Word or any kind of other application, but still it was an attempt of personality that was legitimate.
That's true.
I thought was brave.
Yes, yes. Okay. You've convinced me I'll be slightly less hard on Clippy.
And I know I have like an army of people behind me who also miss Clippy. So
really? I want to meet these people. Who are these people?
It's the people who like to hate stuff when it's there and miss it when it's gone.
So everyone.
It's everyone, exactly. All right. So
you're right.
Do you think it's possible to fall in love with a robot?
Oh, yeah. Totally.
Do you think it's possible to have a long-term committed monogamous relationship with a robot?
Well, yeah, there are lots of different types of long-term committed monogamous relationships.
I think monogamous implies like you're not going to see other humans sexually, or like you basically on Facebook have to say, I'm in a relationship with this person. This robot.
I just don't again, I think this is comparing robots to humans when I would rather compare them to pets. Like you get a robot, it fulfills, this loneliness that you have in maybe not the same way as a pet, maybe in a different way that is even, supplemental in a different way. But, I'm not saying that people won't do this, be like, oh, I want to marry my robot, or I want to have like a, monogamous relationship with my robot. But I don't think that that's the main use case for them.
But you think that there's still a gap between human and pet. So between husband and pet, there's
it's a different relationship.
It's engineering. So that's a gap that can't be closed through.
I think it could be closed someday, but why would we close that? I think it's so boring to think about recreating things that we already have when we could create something that's different. I know you're thinking about the people who don't have a husband and what could we give them?
Yeah, but I guess what I'm getting at is maybe not. So like the movie Her.
Yeah.
Right. So a better husband.
Well, maybe better in some ways. Like I do think that robots are going to continue to be a different type of relationship, even if we get them like very human looking, or when, the voice interactions we have with them feel very like natural and human like. I think there's still going to be differences. And there were in that movie too, like towards the end, it kind of goes off the rails.
But it's just a movie. So your intuition is that because you kind of said two things, right? So one is, why would you want to basically replicate the husband?
Yeah.
Right. And the other is kind of implying that it's kind of hard to do. So like anytime you try, you might build something very impressive, but it'll be different. I guess my question is about human nature. It's like, how hard is it to satisfy that role of the husband? So removing any of the sexual stuff aside is more like the mystery, the tension, the dance of relationships. You think with robots that's difficult to build? What's your intuition?
I think that, well, it also depends on, are we talking about robots now in 50 years, in like indefinite amount of time, where like
I'm thinking like 5 to 10 years.
5 or 10 years. I think that robots at best will be like it's more similar to the relationship we have with our pets than relationship that we have with other people.
I got it. So what do you think it takes to build a system that exhibits greater and greater levels of intelligence? Like it impresses us with its intelligence. A Roomba, so you talk about anthropomorphization, that doesn't, I think intelligence is not required. In fact, intelligence probably gets in the way sometimes, like you mentioned. But what do you think it takes to create a system where we sense that it has a human level intelligence? So something that probably something conversational, human level intelligence. How hard do you think that problem is? It'd be interesting to sort of hear your perspective, not just purely. So I talked to a lot of people. How hard is it, the conversational agents?
Yeah.
How hard is it to pass a Turing test? But my sense is it's easier than just solving. It's easier than solving the pure natural language processing problem, because I feel like you can cheat.
Yeah.
So yeah. So how hard is it to pass the Turing test in your view?
I think again, it's all about expectation management. If you set up people's expectations to think that they're communicating with, what was it, a 13-year-old boy from the Ukraine?
Yeah, that's right. Yeah.
Then they're not going to expect perfect English. They're not going to expect perfect, understanding of concepts, or even like being on the same wavelength in terms of like conversation flow. So it's much easier to pass in that case.
Do you think, you kind of alluded this too with audio, do you think it needs to have a body?
I think that we definitely have, so we treat physical things with more social agency because we're very physical creatures. I think a body can be useful.
Does it get in the way? Is there negative aspects like
Yeah, there can be. So if you're trying to create a body that's too similar to something that people are familiar with, like I have this robot cat at home that Hasbro makes, and it's very disturbing to watch because I'm constantly assuming that it's going to move like a real cat, and it doesn't, because it's like a $100 piece of technology. So it's very like disappointing, and it's very hard to treat it like it's alive. So you can get a lot wrong with the body too, but you can also use tricks, same as, the expectation management of the 13-year-old boy from the Ukraine. If you pick an animal that people aren't intimately familiar with, like the baby dinosaur, like the baby seal that people have never actually held in their arms, you can get away with much more because they don't have these preformed expectations.
Yeah, I remember I'm thinking at a TED Talk or something that clicked for me, that nobody actually knows what a dinosaur looks like. So you can actually get away with a lot more. That was great. Do you think he needs Twitch? I'm going to start gaming and streaming my my gameplay. So what do you see as the future of personal robotics, social robotics, interaction with other robots? Like, what are you excited about if you were to sort of philosophize about what might happen in the next 5-10 years? That would be cool to see.
Oh, I really hope that we get kind of a home robot that makes it, that's a social robot and not just Alexa. Like, it's, I really love the Anki products. I thought Jibo had some really great aspects. So I'm hoping that a company cracks that.
Me too. So, Kate, it was wonderful talking to you today.
Likewise. Thank you so much.
It's fun. Thanks for listening to this conversation with Kate Darling. And thank you to our sponsors, ExpressVPN and Masterclass. Please consider supporting the podcast by signing up to Masterclass at masterclass.com/Lex and getting ExpressVPN at expressvpn.com/LexPod. If you enjoy this podcast, subscribe on YouTube, review it with 5 stars on Apple Podcasts, support it on Patreon, or simply connect with me on Twitter at Lex Fridman. And now, let me leave you with some tweets from Kate Darling. First tweet is, "The pandemic has fundamentally changed who I am. I now drink the leftover milk in the bottom of the cereal bowl." Second tweet is, "I came on here to complain that I had a really bad day and saw that a bunch of you are hurting too. Love to everyone." Thank you for listening and hope to see you next time. What's your favorite robot? Like
fictional or real?
No, real. Real robot which you have felt a connection with, or not like not a anthropomorphic connection, but I mean like you sit back and said, "Damn, this is an impressive system."
Wow. So 2 different robots. So the Pleo baby dinosaur robot that is no longer sold, that came out in 2007. That one I was very impressed with. It was, but from an anthropomorphic perspective, right. I was impressed with how much I bonded with it, how much I wanted to believe that it had this inner life.
Can you describe Pleo? Can you describe what it is? How big is it? What can it actually do?
Yeah. Pleo is about the size of a small cat. It had a lot of motors that gave it this kind of lifelike movement. It had things like touch sensors and an infrared camera. So it had all these cool little technical features, even though it was a toy. And the thing that really struck me about it was that it could mimic pain and distress really well. So if you held it up by the tail, it had a tilt sensor that told it what direction it was facing, and it would start to squirm and cry out. If you hit it too hard, it would start to cry. So it was very impressive in design.
And what's the second robot that you said there might have been 2 that you liked?
Yeah, so the Boston Dynamics robots are just impressive feats of engineering.
Have you met them in person?
Yeah, I recently got a chance to go visit, and I was always one of those people who watched the videos and was like, this is super cool, but also it's a product video. I don't know how many times that they had to shoot this to get it right. Yeah. But visiting them, I'm pretty sure that I was very impressed. Let's put it that way.
Yeah, in terms of the control, I think that was a transformational moment for me when I met Spot Mini in person.
Yeah.
Because, okay, maybe this is a psychology experiment, but I anthropomorphized the crap out of it. So it was like my best friend, right?
I think it's really hard for anyone to watch Spot move and not feel like it has agency.
Yeah, this movement, especially the arm on Spot Mini, really obviously looks like a head.
Yeah.
And they say, no, we didn't mean it that way, but it obviously it looks exactly like that. And so it's almost impossible to not think of it as almost like the baby dinosaur, but slightly larger. And this movement of course, the intelligence is, their whole idea is that it's not supposed to be intelligent. It's a platform on which you build higher intelligence. It's actually really, really dumb. It's just a basic movement platform.
Yeah, but even dumb robots we can immediately respond to them in this.
Oh boy, yeah, and that expands to other topics, which I don't know. There's a topic of sex, which is a weird one that I tend to avoid from robotics perspective, and most of the general public doesn't. They talk about sex robots and so on. Is that an area you've touched at all research-wise? Like the way, because that's what people imagine, sort of any kind of interaction between human and robot that shows any kind of compassion. They immediately think from a product perspective in the near term is sort of expansion of what pornography is and all that kind of stuff.
Yeah.
Do researchers touch this?
That's kind of you to like characterize it as though they're thinking rationally about product. I feel like sex robots are just such a like titillating news hook for people that they become like the story. And it's really hard to not get fatigued by it when you're in the space, because you tell someone you do human robot interaction, of course, the first thing they want to talk about is sex robots.
Really?
Like you said, yeah, it happens a lot. And it's unfortunate that I'm so fatigued by it, because I do think that there are some interesting questions that become salient when you talk about, sex with robots.
See, what I think would happen when people get sex robots, like let's up guys, okay, guys get female sex robots. What I think there's an opportunity for is an actual, like they'll actually interact. What I'm trying to say, they won't, outside of the sex would be the most fulfilling part. Like the interaction, it's like the folks who, there's movies on this, right? Who pay a prostitute and then end up just talking to her the whole time. So I feel like there's an opportunity. It's like most guys and people in general joke about the sex act, but really people are just lonely inside. They're looking for connection, many of them. And it'd be unfortunate if that connection is established through the sex industry. I feel like it should go into the front door of like, people are lonely and they want a connection.
Well, I also feel like we should kind of destigmatize the sex industry. Sure. Because, even prostitution, like there are prostitutes that specialize in disabled people who don't have the same kind of opportunities to explore their sexuality. So I feel like we should like destigmatize all of that generally.
Yeah.
But yeah, that connection and that loneliness is an interesting, topic that you bring up, because while people are constantly worried about robots replacing humans and, if people get sex robots and the sex is really good, then they won't want their, partner or whatever. But we rarely talk about robots actually filling a hole where there's nothing.
Yeah.
And what benefit that can provide to people.
Yeah, I think that's an exciting. There's a giant hole that's unfillable by humans. It's asking too much of your friends and people you're in a relationship with in your family to fill that hole. Because it's exploring the full exploring the full complexity and richness of who you are. Like, who are you really? Like, people, your family doesn't have enough patience to really sit there and listen to who are you really. And I feel like there's an opportunity to really make that connection with robots.
I just feel like we're complex as humans, and we're capable of lots of different types of relationships. So whether that's, with family members, with friends, with our pets, or with robots, I feel like there's space for all of that, and all of that can provide value in a different way.
So what I gleaned from your Twitter is your mom. I saw a quote, a reference to baby bot. What have you learned about robotics and AI from raising a human baby bot?
Well, I think that my child has just made it more apparent to me that the systems we're currently creating aren't like human intelligence. Like there's not a lot to compare there. It's just he has learned and developed in such a different way than a lot of the AI systems we're creating, that's not really interesting to me to compare. But what is interesting to me is how these systems are going to shape the world that he grows up in. And so I'm like even more concerned about kind of the societal effects of developing systems that, rely on massive amounts of data collection, for example.
So is he going to be allowed to use like Facebook or
Facebook is over. Kids don't use that anymore.
Snapchat? What do they use? Instagram?
Snapchat's over too. I don't know. I just heard that TikTok is over, which I've never even seen. So I don't know.
No.
We're old. We don't know. Is that what?
Well, it bothers me because it reveals. So I personally believe, because I've studied way too much. So I'm Jewish. So I studied the Holocaust and World War II exceptionally well. I personally believe that most of us have evil in us. That what bothers me is the abuse of robots reveals the evil in human beings.
Yeah.
And I think it doesn't just bother me. I think it's an opportunity for roboticists to help people find the better sides, the angels of their nature, right?
Yeah.
That abuse isn't just a fun side thing. That's you revealing a dark part that that should be hidden deep inside.
Yeah, I mean, you laugh, but some of our research does indicate that maybe people's behavior towards robots reveals something about their tendencies for empathy generally, even using very simple robots that we have today that like clearly don't feel anything. So, Westworld is maybe, not so far off, and it's like, depicting the bad characters as willing to go around and shoot and rape the robots, and the good characters as not wanting to do that, even without assuming that the robots have consciousness.
So there's an opportunity. It's interesting. There's an opportunity to almost practice empathy. On robots is an opportunity to practice empathy.
I agree with you. Some people would say, why are we practicing empathy on robots instead of, on our fellow humans or on animals that are actually alive and experience the world? And I don't agree with them because I don't think empathy is a zero-sum game. And I do think that it's a muscle that you can train and that we should be doing that. But some people disagree.
So the interesting thing, you've heard, raising kids, sort of asking them or telling them to be nice to the smart speakers, to Alexa and so on, so saying please and so on during the requests. I don't know if I'm a huge fan of that idea because, that's towards the idea of practicing empathy. I feel like politeness, I'm always polite to all the systems that we build, especially anything that's speech interaction based, like when we talk to the car. I'll always have a pretty good detector for please. I feel like there should be a room for encouraging empathy in those interactions. Yeah.
Okay, so I agree with you. So I'm going to play devil's advocate.
Sure.
So
what is the devil's advocate argument there?
The devil's advocate argument is that if you are the type of person who has abusive tendencies or needs to get some sort of like behavior like that out, needs an outlet for it, that it's great to have a robot that you can scream at so that you're not screaming at a person. And we just don't know whether that's true, whether it's an outlet for people or whether it just kind of, as my friend once said, trains their cruelty muscles and makes them more cruel in other situations.
So what do you think about consciousness and mortality being displayed in a robot? So not actually having consciousness, but having these kind of human elements that are much more than just the interaction, much more than just, like you mentioned, with a dinosaur moving kind of in interesting ways, but really being worried about its own death and really acting as if it's aware and self-aware and identity. Have you seen that done in robotics? What do you think about doing that? Is that a powerful good thing?
Well, I think it can be a design tool that you can use for different purposes. So I can't say whether it's inherently good or bad, but I do think it can be a powerful tool. The fact that the, pleo mimics distress when you quote unquote hurt it is a really powerful tool to get people to engage with it in a certain way. I had a research partner that I did some of the empathy work with named Palash Nandi, and he had built a robot for himself that had like a lifespan and that would stop working after a certain amount of time just because he was interested in like whether he himself would treat it differently. Mm-hmm. And we know from, Tamagotchis, those little games that we used to have that were extremely primitive, that like people respond to like this idea of mortality. And, you can get people to do a lot with little design tricks like that. Now, whether it's a good thing depends on what you're trying to get them to do.
Have a deeper relationship. Have a deeper connection. Sorry, not a relationship.
If it's for their own benefit, that sounds great.
Okay. In terms of spilling things, there creeps in this notion that starts to sound and feel like common sense reasoning. Do you think solving the general problem of robotics requires common sense reasoning, requires general intelligence, this kind of human level capability of, like you said, be robust and deal with uncertainty, but also be able to sort of reason and assimilate different pieces of knowledge that you have. What are your thoughts on the needs of common sense reasoning in the space of the general robotics problem?
So I'm going to slightly dodge that question and say that I think maybe actually it's the other way around, is that studying robotics can help us understand how to put common sense into our AI systems. One way to think about common sense is that, and why our current systems might lack common sense, is that common sense is an emergent property of actually having to interact with a particular world, a particular universe, and get things done in that universe. So you might think that, for instance, like an image captioning system, maybe it looks at pictures of the world and it types out English sentences. So it kind of deals with our world. And then you can easily construct situations where image captioning systems do things that defy common sense, like give it a picture of a person wearing a fur coat and we'll say it's a teddy bear. But I think what's really happening in those settings is that the system doesn't actually live in our world. It lives in its own world that consists of pixels and English sentences, and doesn't actually consist of having to put on a fur coat in the winter so you don't get cold. So perhaps the reason for the disconnect is that the systems that we have now simply inhabit a different universe. And if we build AI systems that are forced to deal with all of the messiness and complexity of our universe, maybe they will have to acquire common sense to essentially maximize their utility. Whereas the systems we're building now don't have to do that. They can take some shortcuts.
That's fascinating. You've a couple of times already sort of reframed the role of robotics in this whole thing. And for some reason, I don't know if my way of thinking is common, but I thought like we need to understand and solve intelligence in order to solve robotics. And you're kind of framing it as, no, robotics is one of the best ways to just study artificial intelligence and build sort of like robotics is like the right space in which you get to explore some of the fundamental learning mechanisms, fundamental sort of multimodal, multitask aggregation of knowledge mechanisms that are required for general intelligence. That's a really interesting way to think about it. But let me ask about learning. Do you have just so we can zoom in as we talk about robotics, do you have a canonical problem, sort of a simple, clean, beautiful, representative problem in robotics that you think about when you're thinking about some of these problems? We talked about robotic manipulation. To me, that seems intuitively, at least the robotics community has converged towards that as a space that's the canonical problem. If you agree, then maybe do you zoom in some particular aspect of that problem that you just like if we solve that problem perfectly, it'll unlock a major step in towards human level intelligence.
I don't think I have like a really great answer to that. And I think partly the reason I don't have a great answer kind of has to do with it has to do with the fact that the difficulty is really in the flexibility and adaptability rather than in doing a particular thing really, really well. So it's hard to just say like, oh, if you can, I don't know, like shuffle a deck of cards as fast as like a Vegas casino dealer, then you'll be very proficient. It's really the ability to quickly figure out how to do some arbitrary new thing well enough to to move on to the next arbitrary thing.
But so the source of newness and uncertainty, have you found problems in which it's easy to generate newnesses?
Yeah.
New types of newness.
Yeah. So a few years ago, so if you had asked me this question around 2016 maybe, I would have probably said that robotic grasping is a really great example of that, because it's a task with great real-world utility. You will get a lot of money if you can do it well.
What is robotic grasping?
Picking up any object.
With a robotic hand.
Yeah, exactly. So you will get a lot of money if you do it well, because lots of people want to run warehouses with robots. And it's highly non-trivial because very different objects will require very different grasping strategies. But actually, since then, people have gotten really good at building systems to solve this problem to the point where I'm not actually sure how much more progress we can make with that as the main guiding thing. But it's kind of interesting to see the kind of methods that have actually worked well in that space, because robotic grasping classically used to be regarded very much as kind of almost like a geometry problem. So people who have studied the history of computer vision will find this very familiar, that it's kind of in the same way that in the early days of computer vision, people thought of it very much as an inverse graphics thing. In robotic grasping, people thought of it as an inverse physics problem, essentially. You look at what's in front of you, figure out the shapes, then use your best estimate of the laws of physics to figure out where to put your fingers, and then you pick up the thing. And it turns out that what works really well for robotic grasping, instantiated in many different recent works, including our own, but also ones from many other labs, is to use learning methods with some combination of either exhaustive simulation or actual real-world trial and error. And it turns out that those things actually work really well, and then you don't have to worry about solving geometry problems or physics problems.
So what are, just by the way, on the grasping, what are the difficulties that have been worked on? So one is the materials of things, maybe occlusions on the perception side. Why is it such a difficult, why is picking stuff up such a difficult problem?
Yeah. It's a difficult problem because the number of things that you might have to deal with, or the variety of things that you have to deal with, is extremely large. And oftentimes things that work for one class of objects won't work for other classes of objects. So if you get really good at picking up boxes and now you have to pick up plastic bags, you just need to employ a very different strategy. And there are many properties of objects that are more than just their geometry. It has to do with, the bits that are easier to pick up, the bits that are harder to pick up, the bits that are more flexible, the bits that will cause the thing to pivot and bend and drop out of your hand, versus the bits that result in a nice secure grasp. Things that are flexible, things that if you pick them up the wrong way, they'll fall upside down and the contents will spill out. So there's all these little details that come up. But the task is still can be characterized as one task. There's a very clear notion of you did it or you didn't do it.
So if we look at sort of the subspaces of robotics that, again, as you said, robotics integrates all of them together, and we get to see how this beautiful mess interplays. But so there's nevertheless still perception. So it's the computer vision problem, broadly speaking, understanding the environment. Then there's also, maybe you can correct me on this kind of categorization of the space. Then there's prediction, in trying to anticipate what things are going to do into the future in order for you to be able to act in that world. And then there's also this game theoretic aspect of how your actions will change the behavior of others. In this kind of space, and this is bigger than reinforcement learning, this is just broadly looking at the problem in robotics, what's the hardest problem here? Mm-hmm. Or is what you said true, that when you start to look at all of them together, that's a whole another thing? You can't even say which one individually is harder, because all of them together, you should only be looking at them all together.
I think when you look at them all together, some things actually become easier. And I think that's actually pretty important. So we had, back in 2014, we had some work, basically our first work on end-to-end reinforcement learning for robotic manipulation skills from vision, which, at the time was something that seemed a little inflammatory and controversial in the robotics world. But other than the inflammatory and controversial part of it, the point that we were actually trying to make in that work is that for the particular case of combining perception and control, you could actually do better if you treat them together than if you try to separate them. And the way that we tried to demonstrate this is we picked, a fairly simple motor control task where a robot had to insert a little red trapezoid into a trapezoidal hole. And we had our separated solution, which involved first detecting the hole using a pose detector and then actuating the arm to put it in. And then our intent solution, which just mapped pixels to torques. And one of the things we observed is that if you use the intent solution, essentially the pressure on the perception part of the model is actually lower. Like, it doesn't have to figure out exactly where the thing is in 3D space. It just needs to figure out where it is, distributing the errors in such a way that the horizontal difference matters more than the vertical difference, because vertically it just pushes it down all the way until it can't go any further. And their perceptual errors are a lot less harmful, whereas perpendicular to the direction of motion, perceptual errors are much more harmful. So the point is that if you combine these two things, you can trade off errors between the components optimally to best accomplish the task, and the components can actually be weaker while still leading to better overall performance.
That's a profound idea. I mean, in the space of pegs and things like that, it's quite simple. It almost is tempting to overlook, but that's seems to be, at least intuitively, an idea that should generalized to basically all aspects of perception and control.
Of course.
That one strengthens the other.
Yeah. And we, people who have studied sort of perceptual heuristics in humans and animals find things like that all the time. So one very well-known example of this is something called the gaze heuristic, which is a little trick that you can use to intercept a flying object. So if you want to catch a ball, for instance, you could try to localize it in 3D space, estimate its velocity, estimate the effect of wind resistance, solve a complex system of differential equations in your head. Or you can maintain a running speed so that the object stays in the same position as in your field of view. So if it dips a little bit, you speed up. If it rises a little bit, you slow down. And if you follow the simple rule, you'll actually arrive at exactly the place where the object lands and you'll catch it. And humans use it when they play baseball. Human pilots use it when they fly airplanes to figure out if they're about to collide with somebody. Frogs use this to catch insects, and so on and so on. So this is something that actually happens in nature. And I'm sure this is just one instance of it that we were able to identify just because that scientists were able to identify because it's so prevalent, but there are probably many others.
Step back. What is the goal of robotics? What's the general problem of robotics we're trying to solve? You actually kind of painted two pictures here. One of sort of the narrow, one of the general. What, in your view, is the big problem of robotics? Again, ridiculously philosophical, high-level questions.
I think that, maybe there are two ways I can answer this question. One is there's a very pragmatic problem, which is like, what would make robots, what would sort of maximize the usefulness of robots? And there the answer might be something like a system where a system that can perform whatever task a human user sets for it, within the physical constraints, of course. If you tell it to teleport to another planet, it probably can't do that. But if you ask it to do something that's within its physical capability, then potentially with a little bit of additional training or a bit of additional trial and error, it ought to be able to figure it out in much the same way as like a human teleoperator ought to figure out how to drive the robot to do that. That's kind of the very pragmatic view of what it would take to kind of solve the robotics problem, if we will. But I think that there's a second answer, and the answer is a lot closer to why I want to work on robotics, which is that I think it's less about what it would take to do a really good job in the world of robotics, but more the other way around, what robotics can bring to the table to help us understand artificial intelligence.
So your dream fundamentally is to understand intelligence.
Yes, I think that's the dream for many people who actually work in this space. I think that there's something very pragmatic and very useful about studying robotics, but I do think that a lot of people that go into this field actually, the things that they draw inspiration from are the potential for robots to like help us learn about intelligence and about ourselves.
So that's fascinating. That robotics is basically the space by which you can get closer to understanding the fundamentals of artificial intelligence. So what is it about robotics that's different from some of the other approaches? So if we look at some of the early breakthroughs in deep learning or in the computer vision space and the natural language processing, there's really nice, clean benchmarks that a lot of people competed on and thereby came out with a lot of brilliant ideas. What's the fundamental difference to you between computer vision, purely defined at ImageNet, and kind of the bigger robotics problem?
So there are a couple of things. One is that with robotics, you kind of have to take away many of the crutches. So you have to deal with both the particular problems of perception, control, and so on, but you also have to deal with the integration of those things. And classically, we've always thought of the integration as kind of a separate problem. So a classic kind of modular engineering approach is that we solve the individual subproblems, then wire them together, and then the whole thing works. And one of the things that we've been seeing over the last couple of decades is that, well, maybe studying the thing as a whole might lead to just like very different solutions than if we were to study the parts and wire them together. So the integrative nature of robotics research helps us see, different perspectives on the problem. Another part of the answer is that with robotics, it casts a certain paradox into very clever relief. So that this is sometimes referred to as a Moravec's paradox, the idea that in artificial intelligence, things that are very hard for people can be very easy for machines, and vice versa. Things that are very easy for people can be very hard for machines. So, integral and differential calculus is pretty difficult to learn for people, but if you program a computer to do it, it can derive derivatives and integrals for you all day long without any trouble. Whereas some things like, drinking from a cup of water, very easy for a person to do, very hard for a robot to deal with. And sometimes when we see such blatant discrepancies, that gives us a really strong hint that we're missing something important. So if we really try to zero in on those discrepancies, we might find that little bit that we're missing. And it's not that we need to make machines better at, or worse at math and better at drinking water, but just that by studying those discrepancies, we might find some new insight.
So that could be in any space. It doesn't have to be robotics, but you're saying, I get. It's kind of interesting that robotics seems to have a lot of those discrepancies. So yeah. the Hans-Moravec paradox is probably referring to the space of the physical interaction, like you said, object manipulation, walking, all the kind of stuff we do in the physical world. How do you make sense if you were to try to disentangle the Moravec paradox? Like, why is there such a gap in our intuition about it? Why do you think manipulating objects is so hard from everything you've learned from applying reinforcement learning in this space?
Yeah, I think that one reason is maybe that for many of the other problems that we've studied in AI and computer science and so on, the notion of input, output, and supervision is much, much cleaner. So computer vision, for example, deals with very complex inputs, but it's comparatively a bit easier, at least up to some level of abstraction, to cast it as a very tightly supervised problem. It's comparatively much, much harder to cast robotic manipulation as a very tightly supervised problem. You can do it, it just doesn't seem to work all that well. So you could say that, well, maybe we get a labeled data set where we know exactly which motor commands to send, and then we train on that, but for various reasons, that's not actually like such a great solution. And it also doesn't seem to be even remotely similar to how people and animals learn to do things, because we're not told by like our parents, here's how you fire your muscles in order to walk. We do get some guidance, but the really low-level detailed stuff we figure out mostly on our own.
And that's what you mean by tightly coupled, that every single little action gets a supervised signal of whether it's a good one or not.
Right. So while in computer vision, you could sort of imagine up to a level of abstraction that maybe, somebody told you this is a car and this is a cat and this is a dog. In motor control, it's very clear that was not the case.
What's the difference between a state-of-the-art human, such as you and I? Well, I don't know if we qualify as state-of-the-art humans, but a state-of-the-art human and a state-of-the-art robot?
That's a very interesting question. Robot capability it's kind of I think it's a very tricky thing to understand, because there are some things that are difficult that we wouldn't think are difficult, and some things that are easy that we wouldn't think are easy. And there's also a really big gap between capabilities of robots in terms of hardware and their physical capability, and capabilities of robots in terms of what they can do autonomously. There is a little video that I think robotics researchers really like to show, especially robotics learning researchers like myself, from 2004 from Stanford, which demonstrates a prototype robot called the PR1. And the PR1 was a robot that was designed as a home assistance robot. And there's this beautiful video showing the PR1 tidying up a living room, putting away toys, and at the end bringing a beer to the person sitting on the couch, which looks really amazing. And then the punchline is that this robot is entirely controlled by a person.
Yes.
So in some ways, the gap between a state-of-the-art human and a state-of-the-art robot, if the robot has a human brain, is actually not that large. Now, obviously, like, human bodies are sophisticated and very robust and resilient in many ways, but on the whole, if we're willing to like spend a bit of money and do a bit of engineering, we can kind of close the hardware gap almost. But the intelligence gap, that one is very wide.
And when you say hardware, you're referring to the physical, sort of the actuators, the actual body of the robot, as opposed to the hardware on which the cognition, the hardware of the nervous system.
Yes, exactly. I'm referring to the body rather than the mind.
So
that means that the work is cut out for us. Like, while we can still make the body better, we kind of know that the big bottleneck right now is really the mind.
And how big is that gap? How big is the difference in your sense of ability to learn, ability to reason, ability to perceive the world between humans and our best robots?
The gap is very large, and the gap becomes larger the more unexpected events can happen in the world. So essentially, the spectrum along which you can measure the size of that gap is the spectrum of how open the world is. If you control everything in the world very tightly, if you put the robot in like a factory and you tell it where everything is and you rigidly program its motion, then it can do things, one might even say, in a superhuman way. It can move faster, it's stronger, it can lift up a car and things like that. But as soon as anything starts to vary in the environment, now it'll trip up, and if many, many things vary, like they would, like in your kitchen, for example, then things are pretty much like wide open.
Now, again, we're going to stick a bit on the philosophical questions, but how much on the human side of the cognitive abilities, in your sense, is nature versus nurture? So how much of it is a product of evolution, and how much of it is something we learn from sort of scratch, from the day we're born?
I'm going to read into your question as asking about the implications of this for AI.
Of course, exactly.
I'm not a biologist. I can't really speak authoritatively about that topic.
So, and to linger on it, if it's all about learning, then there's more hope for AI.
Yeah. So the way that I look at this is that, first, of course, biology is very messy. And if you ask the question, how does a person do something, or how does a person's mind do something, you can come up with a bunch of hypotheses, and oftentimes you can find support for many different, often conflicting hypotheses. One way that we can approach the question of what the implications of this for AI are is we can think about what's sufficient. So, maybe a person is from birth very, very good at some things, like, for example, recognizing faces. There's a very strong evolutionary pressure to do that. If you can recognize your mother's face, then you're more likely to survive, and therefore people are good at this. But we can also ask, like, what's the minimum sufficient thing?
Right.
And one of the ways that we can study the minimal sufficient thing is we could, for example, see what people do in unusual situations. If you present them with things that evolution couldn't have prepared them for. Our daily lives actually do this to us all the time. We didn't evolve to deal with, automobiles and space flight and whatever. So there are all these situations that we can find ourselves in, and we do very well there. Like, I can give you a joystick to control a robotic arm, which you've never used before, and you might be pretty bad for the first couple of seconds, but if I tell you, like, your life depends on using this robotic arm to, like, open this door, you'll probably manage it. Even though you've never seen this device before, you've never used a joystick to control this, and you'll kind of muddle through it. And that's not your evolved natural ability. That's your flexibility, your adaptability. And that's exactly why our current robotic systems really kind of fall flat.
But I wonder how much general, almost what we think of as common sense, pre-trained models underneath all of that. So that ability to adapt to a joystick requires you to have a kind of, I'm human, so it's hard for me to introspect all the knowledge I have about the world. But it seems like there might be an iceberg underneath of the amount of knowledge we actually bring to the table. Yeah. That's kind of the open question.
I think there's absolutely an iceberg of knowledge that we bring to the table, but I think it's very likely that iceberg of knowledge is actually built up over our lifetimes, because we have a lot of prior experience to draw on, and it kind of makes sense that the right way for us to optimize our efficiency, our evolutionary fitness, and so on, is to utilize all of that experience to build up the best iceberg we can get. And that's actually while that sounds an awful lot like what machine learning actually does, I think that for modern machine learning, it's actually a really big challenge to take this unstructured mass of experience and distill out something that looks like a common sense understanding of the world. And perhaps part of that is it's not because something about machine learning itself is broken or hard, but because we've been a little too rigid in subscribing to a very supervised, very rigid notion of learning, kind of the input-output, X's go to Y's sort of model. And maybe what we really need to do is to view the world more as like a mass of experience that is not necessarily providing any rigid supervision, but sort of providing many, many instances of things that could be. And then you take that and you distill it into some sort of common sense understanding.
I see. Well, you're painting an optimistic, beautiful picture, especially from the robotics perspective, because that means we just need to invest and build better learning algorithms, figure out how we can get access to more and more data for those learning algorithms to extract signal from, and then accumulate that iceberg of knowledge. It's a beautiful picture. It's a hopeful one.
I think it's potentially a little bit more than just that. And this is where we perhaps reach the limits of our current understanding. But one thing that I think that the research community hasn't really resolved in a satisfactory way is how much it matters where that experience comes from. Like, do you just like download everything on the internet and cram it into essentially the 21st century analog of the giant language model and see what happens? Or does it actually matter whether your machine physically experiences the world, or in the sense that it actually attempts things, observes the outcome of its actions, and kind of augments its experience that way?
That it chooses which parts of the world it gets to interact with and observe and learn from.
Right. It may be that the world is so complex that simply obtaining a large mass of sort of IID samples of the world is a very difficult way to go. But if you are actually interacting with the world and essentially performing this sort of hard negative mining by attempting what you think might work, observing the sometimes happy and sometimes sad outcomes of that, and augmenting your understanding using that experience, and you're just doing this continually for many years, maybe that sort of data in some sense is actually much more favorable to obtaining a common sense understanding. One reason we might think that this is true is that what we associate with common sense or lack of common sense is often characterized by the ability to reason about kind of counterfactual questions. Like, right. If I were to, here this bottle of water is sitting on the table, everything is fine. If I were to knock it over, which I'm not going to do, but if I were to do that, what would happen? And I know that nothing good would happen from that. But if I have a bad understanding of the world, I might think that that's a good way for me to gain more utility. If I actually go about my daily life doing the things that my current understanding of the world suggests will give me high utility, in some ways I'll get exactly the right supervision to tell me not to do those bad things and to keep doing the good things.
So there's a spectrum between IID, random walk through the space of data, and then what we humans do. Well, I don't even know if we do it optimal, but there might be beyond. So this open question that you raised, where do you think intelligent systems that would be able to deal with this world fall? Can we do pretty well by reading all of Wikipedia, sort of randomly sampling it like language models do? Or do we have to be exceptionally selective and intelligent about which aspects of the world we interact with?
So I think this is first an open scientific problem, and I don't have like a clear answer, but I can speculate a little bit. And what I would speculate is that you don't need to be super, super careful. I think it's less about like being careful to avoid the useless stuff, and more about making sure that you hit on the really important stuff. So perhaps it's okay if you spend part of your day just guided by your curiosity, visiting interesting regions of your state space. But it's important for you to, every once in a while, make sure that you really try out the solutions that your current model of the world suggests might be effective, and observe whether those solutions are working as you expect or not. And perhaps some of that is really essential to have kind of a perpetual improvement loop. Like this perpetual improvement loop is really like that's really the key that's going to potentially distinguish the best current methods from the best methods of tomorrow, in a sense.
How important do you think is exploration or total out of the box thinking, exploration in this space? As you jump to totally different domains. So you kind of mentioned there's an optimization problem. You kind of explore the specifics of a particular strategy, whatever the thing you're trying to solve. How important is it to explore totally outside of the strategies that have been working for you so far? What's your intuition there?
Yeah, I think it's a very problem-dependent kind of question. And I think that's actually, in some ways that question gets at one of the big differences between sort of the classic formulation of a reinforcement learning problem and some of the sort of more open-ended reformulations of that problem that have been explored in recent years. So classically, reinforcement learning is framed as a problem of maximizing utility, like any kind of rational AI agent, and then anything you do is in service to maximizing that utility. But a very interesting kind of way to look at, and I'm not necessarily saying this is the best way to look at it, but an interesting alternative way to look at these problems is as something where you first get to explore the world however you please, and then afterwards you will be tasked with doing something. And that might suggest a somewhat different solution. So if you don't know what you're going to be tasked with doing, and you just want to prepare yourself optimally for whatever your uncertain future holds, maybe then you will choose to attain some sort of coverage, build up sort of an arsenal of cognitive tools, if you will, such that later on, when someone tells you, now your job is to fetch the coffee for me, you'll be well prepared to undertake that task.
And that you see that as the modern formulation of the reinforcement learning problem, as a kind of the more multitask, the general intelligence kind of formulation.
I think that's one possible vision of where things might be headed. I don't think that's by any means the mainstream or standard way of doing things, and it's not like if I had to. But
I like it. It's a beautiful vision. So maybe actually can the general sort of robotics, the epitome of the robotics problem, be solved purely through learning, perhaps end-to-end learning, sort of learning from scratch, as opposed to injecting human expertise and rules and heuristics and so on?
I think that in terms of the spirit of the question, I would say yes. I mean, I think that though in some ways it's maybe like an overly sharp dichotomy. Like, I think that in some ways when we build algorithms, we, at some point a person does something. Like
hyperparameters. There's always
a person turned on the computer. A person, implemented TensorFlow. Yeah. But yeah, I think that in terms of the point that you're getting at, I do think the answer is yes. I think that we can solve many problems that have previously required meticulous manual engineering through automated optimization techniques. And actually, one thing I will say on this topic is I don't think this is actually a very radical or very new idea. I think people have been thinking about automated optimization techniques as a way to do control for a very, very long time, and in some ways, what's changed is really more the name. So, today we would say that, my robot does machine learning, it does reinforcement learning. Maybe in the 1960s, you'd say, my robot is doing optimal control. And maybe the difference between typing out a system of differential equations and doing feedback linearization versus training a neural net, maybe it's not such a large difference. It's just, pushing the optimization deeper and deeper into the thing.
Well, it's interesting you think that way, but with especially with deep learning, that the accumulation of sort of experiences in data form to form deep representations starts to feel like knowledge as opposed to optimal control. So this feels like there's an accumulation of knowledge through the learning process.
Yes, yeah. So I think that is a good point. That one big difference between learning-based systems and classic optimal control systems is that learning-based systems, in principle, should get better and better the more they do something.
Right.
And I do think that that's actually a very, very powerful difference.
So if we look back at the world of expert systems and symbolic AI and so on, of using logic to accumulate expertise, human encoded expertise, do you think that will have a role at some point? So deep learning, machine learning, reinforcement learning has shown incredible results and breakthroughs, and just inspired thousands, maybe millions of researchers. But there's this less popular now, but it used to be popular idea of symbolic AI. Do you think that will have a role?
I think in some ways, the descendants of symbolic AI actually already have a role. So, this is the highly biased history from my perspective. You say that, well, initially we thought that rational decision making involves logical manipulation. So you have some model of the world expressed in terms of logic. You have some query, like what action do I take in order for X to be true, and then you manipulate your logical symbolic representation to get an answer. What that turned into somewhere in the 1990s is, instead of building kind of predicates and statements that have true or false values, we'll build probabilistic systems where things have probabilities associated with them, probabilities of being true and false, and that turned into Bayes nets. And that provided sort of a boost to what were really, still essentially logical inference systems, just probabilistic logical inference systems. And then people said, well, let's actually learn the individual probabilities inside these models. And then people said, well, let's not even specify the nodes in the models. Let's just put a big neural net in there. But in many ways, I see these as actually kind of descendants from the same idea. It's essentially instantiating rational decision-making by means of some inference process and learning by means of an optimization process. So in a sense, I would say, yes, that it has a place. And in many ways, that place is, it already holds that place.
It's already in there. Yeah, it's just by different. It looks slightly different than it was before.
Yeah, but there are some things that we can think about that make this a little bit more obvious. Like if I train a big neural net model to predict what will happen in response to my robot's actions, and then I run probabilistic inference, meaning I invert that model to figure out the actions that lead to some plausible outcome. Like to me, that seems like a kind of logic. You have a model of the world that just happens to be expressed by a neural net, and you are doing some inference procedure, some sort of manipulation on that model to figure out, the answer to a query that you have.
It's the interpretability, it's the explainability, though, that seems to be lacking more so, because the nice thing about sort of expert systems is you can follow the reasoning of the system that to us mere humans is somehow compelling. It's just I don't know what to make of this fact that there's a human desire for intelligent systems to be able to convey in a poetic way to us why it made the decisions it did, like tell a convincing story. And perhaps that's like a silly human thing. Like we shouldn't expect that of intelligent systems. Like we should be super happy that there's intelligent systems out there. But if I were to sort of psychoanalyze the researchers at the time, I would say expert systems connected to that part, that desire of AI researchers for systems to be explainable. I mean, maybe on that topic, do you have a hope that sort of inference systems, so learning-based systems will be as explainable as the dream was with expert systems, for example?
I think it's a very complicated question because I think that in some ways the question of explainability is kind of very closely tied to the question of like performance. Like, why do you want your system to explain itself? Well, so that when it screws up, you can kind of figure out why it did it.
Right.
But in some ways that's a much bigger problem, actually. Like your system might screw up, and then it might screw up in how it explains itself, or you might have some bug somewhere so that it's not actually doing what it was supposed to do. So, maybe a good way to view that problem is really as a problem, as a bigger problem of verification and validation, of which explainability is sort of one component.
I see. I just see it differently. I see explainability. You put it beautifully. I think you actually summarized the field of explainability. But to me, there's another aspect of explainability, which is like storytelling. That has nothing to do with errors or with like the sort of it uses errors as elements of its story as opposed to a fundamental need to be explainable when errors occur. It's just that for other intelligence systems to be in our world, we seem to want to tell each other stories. And that's true in the political world, that's true in the academic world. And that neural networks are less capable of doing that, or perhaps they're equally capable of storytelling is storytelling. Maybe it doesn't matter what the fundamentals of the system are. You just need to be a good storyteller.
Maybe one specific story I can tell you about in that space is actually about some work that was done by my former collaborator, who's now a professor at MIT, named Jacob Andreas. Jacob actually works in natural language processing, but he had this idea to do a little bit of work in reinforcement learning and on how natural language can basically structure the internals of policies trained with RL. And one of the things he did is he set up a model that attempts to perform some task that's defined by a reward function, but the model reads in a natural language instruction. So this is a pretty common thing to do in instruction following. So you tell it, like, go to the red house, and then it's supposed to go to the red house. But then one of the things that Jacob did is he treated that sentence not as a command from a person, but as a representation of the internal kind of state of the mind of this policy, essentially. So that when it was faced with a new task, what it would do is it would basically try to think of possible language descriptions, attempt to do them, and see if they led to the right outcome. So it would kind of think out loud, like, I'm faced with this new task. What am I going to do? Let me go to the red house. Oh, that didn't work. Let me go to the blue room or something. Let me go to the green plant. And once it got some reward, it would say, oh, go to the green plant. That's what's working. I'm going to go to the green plant. And then you could look at the string that it came up with, and that was a description of how it thought it should solve the problem. So you could basically incorporate language as internal state, and you can start getting some handle on these kinds of things.
And then what I was kind of trying to get to is that also if you add to the reward function the convincingness of that story. So I have another reward signal of like people who review that story, how much they like it. So that, initially that could be a hyperparameter, sort of hard-coded heuristic type of thing, but it's an interesting notion of the convincingness of the story becoming part of the reward function, the objective function of the explainability. It's in the world of sort of Twitter and fake news, that might be a scary notion that the nature of truth may not be as important as the convincingness of how convincing you are in telling the story around the facts. Well, let me ask the basic question, but just to linger on NASA for a little bit, what do you think, maybe if you have other memories, but also what do you think is the future of robots in space? We mentioned HAL, but there's incredible robots that NASA's working on in general, thinking about as we venture out, human civilization ventures out into space. What do you think the future of robots is there?
Yeah, so I mean, there's the near term. For example, they just announced the rover that's going to the moon, which, that's kind of exciting, but that's like near term. My favorite series is Star Trek, right? I really hope, and even Star Trek, like if I calculate the years, I wouldn't be alive, but I would really, really love to be in that world. Like, even if it's just at the beginning, like, like Voyage, like Adventure 1.
So basically living in space.
Yeah.
With what robots? What do robots?
With Data.
What role?
The Data would have to be, even though that wasn't, that was like later. But
so Data is a robot that has human-like qualities,
right? Without the emotion chip, yeah.
You don't like emotion.
Well, so Data robots. With the emotion chip was kind of a mess, right? it took a while for that him to adapt, but. And so why was that an issue? The issue is that emotions make us irrational agents. That's the problem. And yet he could think through things, even if it was based on an emotional scenario, right? Based on pros and cons. But as soon as you made him emotional, one of the metrics he used for evaluation was his own emotions, not people around him, right? Like, and so
we do that as children, right? So we're very egocentric when we're young.
We are very egocentric.
And so isn't that just an early version of the emotion chip then? I haven't watched much Star Trek.
Except I have also met adults. Right? And so that is a developmental process. And I'm sure there's a bunch of psychologists that could go through, like you can have a 60-year-old adult who has the emotional maturity of a 10-year-old, right? And so there's various phases that people should go through in order to evolve. And sometimes you don't.
So how much psychology do you think, a topic that's rarely mentioned in robotics, but how much does psychology come to play when you're talking about HRI, human-robot interaction, when you have to have robots that actually interact with humans?
Tons. So we, like my group, as well as I, read a lot in the cognitive science literature as well as the psychology literature, because they understand a lot about human-human relations and developmental milestones and things like that. And so we tend to look to see what's been done out there. Sometimes what we'll do is we'll try to match that to see, is that human-human relationship the same as human-robot? Sometimes it is, and sometimes it's different. And then when it's different, we try to figure out, okay, why is it different in this scenario, but it's the same in the other scenario, right? And so we try to do that quite a bit.
Would you say that's, if we're looking at the future of human-robot interaction, would you say the psychology piece is the hardest? Like it's a funny notion for you as, I don't know if you consider, one way to ask it, do you consider yourself a roboticist or a psychologist?
Oh, I consider myself a roboticist that plays the act of a psychologist.
But if you were to look at yourself sort of, 20, 30 years from now, do you see yourself more and more wearing the psychology hat? Sort of another way to put it is, are the hard problems in human-robot interactions fundamentally psychology, or is it still robotics, the perception, manipulation, planning, and all that kind of stuff?
It's actually neither. The hardest part is the adaptation and the interaction. So
the learning.
It's the interface, it's the learning. And so if I think of, like, I've become much more of a roboticist / AI person than when originally, again, I was about the bionics. I was electrical engineer. I was control theory, right? Like, and then I started realizing that my algorithms needed like human data, right? And so then I was like, okay, what is this human thing, right? How do I incorporate human data? And then I realized that human perception had, like, there was a lot in terms of how we perceive the world. And so trying to figure out, how do I model human perception and so I became a HRI person, human robot interaction person, from being a control theory and realizing that humans actually offered quite a bit. And then when you do that, you become more of an artificial intelligence, AI. And so I see myself evolving more in this AI world under the lens of robotics, having hardware, interacting with people.
So you're a world-class expert researcher in robotics, and yet others, there's a few, it's a small but fierce community of people, but most of them don't take the journey into the H of HRI, into the human. So why did you brave into the interaction with humans? It seems like a really hard problem.
It's a hard problem, and it's very risky as an academic.
Yes.
And I knew that when I started down that journey, that it was very risky as an academic in this world that was nuanced. It was just developing. We didn't even have a conference, right, at the time. Because it was the interesting problems. That was what drove me. It was the fact that I looked at what interests me in terms of the application space and the problems, and that pushed me into trying to figure out what people were and what humans were and how to adapt to them. If those problems weren't so interesting, I'd probably still be sending rovers to glaciers, right? But the problems were interesting. And the other thing was that they were hard, right? So I like having to go into a room and being like, I don't know what to do. And then going back and saying, okay, I'm going to figure this out. I'm not driven when I go in, I'm like, oh, there are no surprises. Yeah. Like, I don't find that satisfying. If that was the case, I'd go someplace and make a lot more money, right? I think I stay an academic and choose to do this because I can go into a room and I'm like, oh, that's hard.
Yeah, I think just from my perspective, maybe you can correct me on it, but if I just look at the field of AI broadly, it seems that human-robot interaction has one of the most number of open problems. Like people, especially relative to how many people are willing to acknowledge that there are. This because most people are just afraid of the human, so they don't even acknowledge how many open problems there are. But it's in terms of difficult problems to solve, exciting spaces, it seems to be incredible for that.
It is, and it's exciting.
Why do you think people are so afraid, at least in popular culture, of legged robots like those worked in Boston Dynamics, or just robotics in general? If you were to psychoanalyze that fear, what do you make of it? And should they be afraid? Sorry.
So should people be afraid? I don't think people should be afraid, but with a caveat. I don't think people should be afraid, given that most of us in this world understand that we need to change something, right? So given that, now, if things don't change, be very afraid.
Which is the dimension of change that's needed? So
changing, thinking about the ramifications, thinking about like the ethics, thinking about like the conversation is going on, right? It's no longer we're going to deploy it and forget that, this is a car that can kill pedestrians that are walking across the street, right? We're not in that stage. We're putting these roads out. There are people out there.
Yes.
A car could be a weapon. Like, people are now, solutions aren't there yet, but people are thinking about this as we need to be ethically responsible as we send these systems out, robotics, medical, self-driving.
And military, too.
And military.
Which is not as often talked about, but it's really where probably these robots will have a significant impact as well.
Correct. Right. Making sure that they can think rationally, even having the conversations, who should pull the trigger, right?
But overall, you're saying if we start to think more and more as a community about these ethical issues, people should not be afraid.
Yeah, I don't think people should be afraid. I think that the return on investment, the impact, positive impact, will outweigh any of the potentially negative impacts.
So on a slightly related note, in a recent paper, The Ugly Truth About Ourselves and Our Robot Creations, you highlight some biases that may affect the function of various robotic systems. Can you talk through, if you remember, examples of some?
There's a lot of examples.
What is bias, first of all?
So bias is this, and so bias, which is different than prejudice. So bias is that we all have these preconceived notions about particular, everything from particular groups to habits to identity, right? So we have these predispositions. And so when we address a problem, we look at a problem, we make a decision, those preconceived notions might affect our outputs, our outcomes.
So there, the bias could be positive and negative. And then is prejudice the negative kind
prejudice
of bias?
Is the negative, right? So prejudice is that not only are you aware of your bias, but you are then take it and have a negative outcome, even though you're aware.
And there could be gray areas too.
There's always gray areas.
That's the challenging aspect of all ethical questions, right?
So I always so there's a funny one. And in fact, I think it might be in the paper because I think I talk about self-driving cars. But think about this. We, for teenagers, right, typically, insurance companies charge quite a bit of money if you have a teenage driver. So you could say that's an age bias, right? Yeah. But no one will claim, I mean, parents will be grumpy, but no one really says that that's not fair.
That's interesting. We don't, that's right. It's everybody in human factors and safety research almost, I mean, is quite ruthlessly critical of teenagers. And we don't question, is that okay? Is that okay to be ageist in this kind of way?
It is, and it is ageist, right? It's definitely ageist. There's no question about it. And so this is the gray area, right? Because you know that, teenagers are more likely to be in accidents. And so there's actually some data to it. But then if you take that same example and you say, well, I'm going to make the insurance higher for an area of Boston because there's a lot of accidents. And then they find out that that's correlated with socioeconomics. Well, then it becomes a problem, right? Like that is not acceptable. But yet the teenager, which is age, it's against age, is, right?
And so the way we figure that out as a society by having conversations, by having discourse. I mean, throughout history, the definition of what is ethical and not has changed, and hopefully always for the better.
Correct.
So in terms of bias or prejudice in algorithms, what examples do you sometimes think about?
So I think about quite a bit the medical domain, just because historically, right, the healthcare domain has had these biases, typically based on gender and ethnicity, primarily, a little on age, but not so much. Historically, if you think about FDA and drug trials, it's, harder to find women that, aren't childbearing. And so you may not test on drugs at the same level. Right. So there's these things. And so if you think about robotics, right, something as simple as I'd like to design an exoskeleton. Right? What should the material be? What should the weight be? What should the form factor be? Who are you going to design it around? I will say that in the US, women average height and weight is slightly different than guys. So who are you going to choose? Like, if you're not thinking about it from the beginning as, okay, when I design this and I look at the algorithms and I design the control system and the forces and the torques, if you're not thinking about, well, you have different types of body structure, you're going to design to, what you're used to. Oh, this fits in all the folks in my lab, right?
So think about it from the very beginning is important. What about sort of algorithms that train on data kind of thing? Sadly, our society already has a lot of negative bias. And so if we collect a lot of data, even if it's a balanced way, it's going to contain the same bias that a society contains. And so, is there things there that bother you?
Yeah. So you actually said something. You had said how we have biases, but hopefully we learn from them and we become better. Yes. Right. And so that's where we are now. Right. So the data that we're collecting is historic. It's based on these things when we knew it was bad to discriminate, but that's the data we have. And we're trying to fix it now, but we're fixing it based on the data that was used in the first place to discriminate.
Fix it in post.
Right. And so the decisions, and you can look at everything from the whole aspect of predictive policing, criminal recidivism. There's a recent paper that had the healthcare algorithms, which had a kind of a sensational titles. I'm not pro sensationalism in titles, but again, you read it, right? So it makes you read it. But I'm like, really, you could have.
What's the topic of the sensationalism? I mean, what's underneath it? If you could sort of educate me on what kind of bias creeps into the healthcare space?
Yeah, so...
you already kind of mentioned.
So this one the headline was racist AI algorithms. Okay, that's totally a clickbait title.
Yeah.
And so you looked at it, and so there was data that these researchers had collected. I want to say it was either Science or Nature. It was just published, but they didn't have the sensational title. Right. It was like the media. And so they had looked at demographics, I believe, between black and white women, right? And they showed that there was a discrepancy in the outcomes, right? And it was tied to ethnicity, tied to race. The piece that the researchers did actually went through the whole analysis, but of course...
the journals with AI are problematic across the board,
right,
let's say.
Right. And so this is a problem, right? And so there's this thing about, AI, it has all these problems. We're doing it on historical data, and the outcomes are uneven based on gender or ethnicity or age. But I'm always saying is like, yes, we need to do better, right? We need to do better. It is our duty to do better. But the worst AI is still better than us. Like you take the best of us and we're still worse than the worst AI, at least in terms of these things. And that's actually not discussed, right? And so I think, and that's why the sensational title, right? And so it's like, so then you can have individuals go like, oh, we don't need to use this AI. I'm like, oh, no. I want the AI instead of the doctors that provided that data, because it's still better than that.
Yes.
Right?
I think that's really important to linger on. Is the idea that this AI is racist. It's like, well, compared to what? Sort of I think we set, unfortunately, way too high of a bar for AI algorithms. And in the ethical space where perfect is, I would argue, probably impossible, then if we set the bar of perfection, essentially, of it has to be perfectly fair, whatever that means, it means we're setting it up for failure. But that's really important to say what you just said, which is, well, it's still better than human beings.
And one of the things I think that we don't get enough credit for, just in terms of as developers, is that you can now poke at it, right? So it's harder to say, is this hospital, is this city doing something, right? Until someone brings in a civil case, right? Well, with AI, it can process through all this data and say, hey, yes, there's an issue here, but here it is. We've identified it. And then the next step is to fix it. I mean, that's a nice feedback loop versus like waiting for someone to sue someone else before it's fixed, right? And so I think that power we need to capitalize on a little bit more, right? Instead of having the sensational titles, have the, okay, this is a problem and this is how we're fixing it. And people are putting money to fix it because we can make it better. I look at like facial recognition, how Joy, she basically called out a couple of companies and said, hey, and most of them were like, oh, embarrassment. And the next time it had been fixed, right? It had been fixed better, right? And then it was like, oh, here's some more issues. And I think that conversation then moves that needle to having much more fair and unbiased and ethical aspects. As long as both sides, the developers are willing to say, okay, I hear you. Yes, we are going to improve. And you have other developers who are like, hey, AI, it's wrong, but I love it, right?
Yes. What or who is the most amazing robot you've ever met, or perhaps had the biggest impact on your career?
I haven't met her, but I grew up with her. But of course, Rosie. So, and I think it's because also...
Who's Rosie?
Rosie from the Jetsons. She is all things to all people, right? Think about it. Like anything you wanted, it was like magic. It happened.
So people not only anthropomorphize, but project whatever they wish for the robot to be onto
Rosie. But also, I mean, think about it. She was socially engaging. She every so often had an attitude, right? She kept us honest. She would push back sometimes when, George was doing some weird stuff. But she cared about people, especially the kids. She was like the perfect robot.
And you've said that people don't want their robots to be perfect. Can you elaborate that? What do you think that is? Just like you said, Rosie pushed back a little bit every once in a while.
Yeah. So I think it's that. So if you think about robotics in general, we want them because they enhance our quality of life. And usually that's linked to something that's functional, right? Even if you think of self-driving cars, why is there a fascination? Because people really do hate to drive. Like there's like Saturday driving where I can just speed, but then there's the I have to go to work every day and I'm in traffic for an hour. I mean, people really hate that. And so robots are designed to basically enhance our ability to increase our quality of life. And so the perfection comes from this aspect of interaction. If I think about how we drive, if we drove perfectly, we would never get anywhere, right? So think about how many times you had to run past the light because you see the car behind you is about to crash into you, or that little kid kind of runs into the street, and so you have to cross on the other side because there's no cars, right? Like if you think about it, we are not perfect drivers. Some of it is because it's our world. And so if you have a robot that is perfect in that sense of the word, they wouldn't really be able to function with us.
Can you linger a little bit on the word perfection? So from the robotics perspective, what does that word mean, and how is sort of the optimal behavior as you're describing different than what we think of perfection?
Yeah, so perfection, if you think about it in the more theoretical point of view, it's really tied to accuracy, right? So if I have a function, can I complete it at 100% accuracy with 0 errors? And so that's kind of, if you think about perfection in the sense of the word.
If you could hang out for a day with a robot, real or from science fiction, movies, books, safely, and get to pick his or her, their brain, who would you pick?
Gotta say it's Data.
Data.
I was gonna say Rosie, but I'm not really interested in her brain. I'm interested in Data's brain.
Data pre or post emotion chip?
Pre.
But don't you think it'd be a more interesting conversation post emotion chip?
Yeah, it would be drama. And I'm human. Yeah. I deal with drama all the time.
Yeah.
But the reason why I want to pick Data's brain is because I could have a conversation with him and ask, for example, how can we fix this ethics problem, right? And he could go through like the rational thinking, and through that, he could also help me think through it as well. And so there's like these questions, fundamental questions I think I could ask him that he would help me also learn from. And that fascinates me.
I don't think there's a better place to end it. Ayanna, thank you so much for talking. It was an honor.
Thank you. Thank you. This was fun.
Thanks for listening to this conversation. And thank you to our presenting sponsor, Cash App. Download it. Use code LEXPODCAST. You'll get $10, and $10 will go to First, a STEM education nonprofit that inspires hundreds of thousands of young minds to become future leaders and innovators. If you enjoy this podcast, subscribe on YouTube, give it 5 stars on Apple Podcast, follow on Spotify, support it on Patreon, or simply connect with me on Twitter. And now let me leave you with some words of wisdom from Arthur C. Clarke. Whether we are based on carbon or on silicon makes no fundamental difference. We should each be treated with appropriate respect. Thank you for listening, and hope to see you next time. Just out of curiosity, Anki, Jibo, Mayfield Robotics, with the Robot Curie, Sci-Fi Works, Rethink Robotics, we're all these amazing robotics companies created by incredible roboticists, and they've all went out of business recently. Why do you think they didn't last longer? Why is it so hard to run a robotics company, especially one like these, which are fundamentally HRI, human robot interaction robots?
Yeah.
Or personal robots.
Each one has a story. Only one of them I don't understand. And that was Anki. That's actually the only one I don't understand.
I don't understand it either. It's
no. I mean, I look like from the outside. I've looked at their sheets. I've looked at like the data. That's
you mean like business wise?
Yeah,
you don't understand. Gotcha.
Yeah, and like I look at that data, and I'm like, they seem to have like product market fit. Like So that's the only one I don't understand. The rest of it was product market fit.
What's product market fit? Just that of like, how do you think about it?
Yeah. So although we think robotics was getting there, right? But I think it's just the timing. It just their clock just timed out. I think if they had been given a couple more years, they would have been okay. But the other ones were still fairly early by the time they got into the market. And so product market fit is, I have a product that I want to sell at a certain price. Are there enough people out there, the market, that are willing to buy the product at that market price for me to be a functional, viable, profit-bearing company, right? So product market fit. If it costs you $1,000 and everyone wants it and only is willing to pay $1, you have no product market fit, even if you could sell it for, it's enough for $1 because you can't.
So how hard is it for robots? Sort of maybe if you look at iRobot, the company that makes Roombas, vacuum cleaners, can you comment on, did they find the right product, market product fit? Like, are people willing to pay for robots is also another kind of question.
So if you think about iRobot and their story, right? Like when they first, they had enough of a runway, right? When they first started, they weren't doing vacuum cleaners, right? They were they were contracts, primarily government contracts, designing robots.
Military robots.
Yeah, that's what they were. That's how they started, right? And
they still do a lot of incredible work there. But yeah, that was the initial thing that gave them enough funding to
then try to. The vacuum cleaner is what I've been told was not like their first rendezvous in terms of designing a product, right?
Nope.
And so they were able to survive until they got to the point that they found a product price market, right? And even if you look at the Roomba, the price point now is different than when it was first released, right? It was an early adopter price, but they found enough people who were willing to fund it. And I forgot what their loss profile was for the first couple of, years, but they became profitable in sufficient time that they didn't have to close their doors.
So they found there's still people willing to pay a large amount of money, so over $1,000 for a vacuum cleaner. Unfortunately for them, now that they've proved everything out, figured it all out, now there's competitors.
Yeah. And so that's the next thing, right? The competition, and they have quite a number, even internationally. Like there's some products out there you can go to, Europe and be like, oh, I didn't even know this one existed. Yeah. So this is the thing though, like with any market, this is not a bad time, although, as a roboticist, it's kind of depressing. But I actually think about things like I would say that all of the companies that are now in the top 5 or 6, they weren't the first to the stage, right? Like Google was not the first search engine, sorry, Alta Vista, right? Facebook was not the first, sorry, MySpace, right? Like think about it. They were not the first players. Those first players, like they're not in the top 5, 10 of Fortune 500 companies, right? They started to prove out the market. They started to get people interested. They started the buzz, but they didn't make it to that next level. But the second batch, right? The second batch, I think, might make it to the next level.
When do you think the Facebook of
the Facebook of robotics?
Sorry, I take that phrase back because people deeply, for some reason, well, I know why, but it's, I think, exaggerated, distrust Facebook because of the privacy concerns and so on. And with robotics, one of the things you have to make sure is all the things we talked about is to be transparent and have people deeply trust you to let a robot into their lives, into their home. But when do you think the second batch of robots will, is it 5, 10 years, 20 years that we'll have robots in our homes and robots in our hearts?
So if I think about, and because I try to follow the VC kind of space in terms of robotic investments. And right now, and I don't know if they're going to be successful. I don't know if this is the second batch. But there's only one batch that's focused on like the first batch, right? And then there's all these self-driving X's, right? And so I don't know if they're a first batch of something or if, like, I don't know quite where they fit in. But there's a number of companies, the co-robot, I call them co-robots, that are still getting VC investments. Some of them have some of the flavor of like Rethink Robotics. Some of them have some of the flavor of like Curie.
What's a co-robot?
So basically a robot and human working in the same space. So some of the companies are focused on manufacturing. So having a robot and human working together in a factory. Some of these co-robots are robots and humans working in the home, working in clinics. Like there's different versions of these companies in terms of their products, but they're all, so Rethink Robotics would be like one of the first, at least well-known companies focused on this space. So I don't know if this is a second batch or if this is still part of the first batch. That I don't know. And then you have all these other companies in this self-driving, space. And I don't know if that's a first batch or again a second batch.
Yeah. So there's a lot of mystery about this now. Of course, it's hard to say that this is the second batch until it, it proves out, right?
Correct.
Yeah, exactly.
Yeah, we need a unicorn.
Yeah, exactly. I saw a video of you talking to Charles Isbell about Westworld, the TV series. You guys were doing a kind of thing where you're watching new things together, but let's rewind back. Is there a sci-fi movie or book or shows that was profound, that had an impact on you philosophically, or just like specifically something you enjoyed nerding out about?
Yeah, interesting. I think a lot of us have been inspired by robots in movies. The one that I really like is there's a movie called Robot and Frank, which I think is really interesting because it's very near-term future, where robots are being deployed as helpers in people's homes. And it was, and we don't know how to make robots like that at this point, but it seemed very plausible. It seemed very realistic or imaginable. And I thought that was really cool because they're awkward. They do funny things that raise some interesting issues, but it seemed like something that would ultimately be helpful and good if we could do it right.
Yeah, he was an older, cranky gentleman, right?
He was an older, cranky jewel thief, yeah.
It's kind of a funny little thing, which is, he's a jewel thief, and so he pulls the robot into his life, which is something you could imagine taking a home robotics thing and pulling into whatever quirky thing that's involved in your existence.
That's meaningful to you.
Yeah.
Exactly so. Yeah, and I think from that perspective, I mean, not all of us are jewel thieves, and so when we bring our robots into our lives,
yourself. Yeah,
it explains a lot about this apartment, actually. But no, the idea that people should have the ability to, make this technology their own, that it becomes part of their lives, and I think it's hard for us as technologists to make that kind of technology. It's easier to mold people into what we need them to be. And just that opposite vision, I think, is really inspiring.
And then there's a anthropomorphization where we project certain things on them, because I think the robot was kind of dumb. But I have a bunch of Roombas I play with, and you immediately project stuff onto them. Much greater level of intelligence. We'll probably do that with each other too. Much greater degree of compassion.
That's right. One of the things we're learning from AI is where we are smart and where we are not smart.
Yeah. I believe you've written, Drake.
There's a team of people. I certainly spent a lot of hours on it myself.
Well, what is Drake, and what does it take to create a simulation environment for the kind of difficult control problems we're talking about?
Right. So Drake is the simulator that I've been working on. There are other good simulators out there. I don't like to think of Drake as just a simulator, because we write our controllers in Drake, we write our perception systems a little bit in Drake, but we write all of our low-level control and even planning and optimization in Drake.
So it has optimization capabilities?
Absolutely, yeah. I mean, Drake is three things, roughly. It's an optimization library, which is sits on it provides a layer of abstraction in C++ and Python for commercial solvers. You can write linear programs, quadratic programs, semi-definite programs, sums of squares programs, the ones we've used, mixed integer programs, and it will do the work to curate those and send them to whatever the right solver is, for instance, and it provides a level of abstraction. The second thing is a system modeling language, a bit like LabVIEW or Simulink, where you can make block diagrams out of complex systems. Or it's like ROS in that sense, where you might have lots of ROS nodes that are each doing some part of your system. But to contrast it with ROS, we try to write, if you write a Drake system, then you have to, it asks you to describe a little bit more about the system. If you have any state, for instance, in the system, any variables that are going to persist, you have to declare them. Parameters can be declared and the like. But the advantage of doing that is that you can, if you like, run things all on one process, but you can also do control design against it. You can do, simple things like rewinding and playing back your simulations. For instance, these things, you get some rewards for spending a little bit more upfront cost in describing each system. And I was inspired to do that because I think the complexity of Atlas, for instance, is just so great. And I think although, Ross has been incredible, absolute huge fan of what it's done for the robotics community, but the ability to rapidly put different pieces together and have a functioning thing is very good. But I do think that it's hard to think clearly about a bag of disparate parts, Mr. Potato Head kind of software stack. And if you can, ask a little bit more out of each of those parts, then you can understand the way they work better. You can try to verify them and the like, or you can do learning against them. And then one of those systems, the last thing, I said the first two things that Drake is, but the last thing is that there is a set of multi-body equations, rigid body equations, that is trying to provide a system that simulates physics. And that we also have renderers and other things, but I think the physics component of Drake is special in the sense that we have done excessive amount of engineering to make sure that we've written the equations correctly. Every possible tumbling satellite or spinning top or anything that we could possibly write as a test is tested. We are making some, I think, fundamental improvements on the way you simulate contact.
So what does it take to simulate contact? It just seems, there's something just beautiful the way you were like explaining contact and you're like tapping your fingers on the table while you're doing it. Just
easily, right?
Easily. Just not even like, it was like helping you think, I guess. What so you have this like awesome demo of loading or unloading a dishwasher, just picking up a plate, grasping it like for the first time. That just seems like so difficult. How do you simulate any of that?
So it was really interesting that what happened was that we started getting more professional about our software development during the DARPA Robotics Challenge. I learned the value of software engineering and how to bridle complexity. I guess that's what I want to somehow fight against and bring some of the clear thinking of controls into these complex systems we're building for robots. Shortly after the DARPA Robotics Challenge, Toyota opened a research institute, TRI, Toyota Research Institute. They put one of there's 3 locations. One of them is just down the street from MIT, and I helped ramp that up right out as a part of my the end of my sabbatical, I guess. So TRI has given me the TRI robotics effort, has made this investment in simulation in Drake, and Michael Sherman leads a team there of just absolutely top-notch dynamics experts that are trying to write those simulators that can pick up the dishes. And there's also a team working on manipulation there that is taking problems like loading the dishwasher, and we're using that to study these really hard corner cases kind of problems in manipulation. So for me, this, simulating the dishes, we could actually write a controller. If we just cared about picking up dishes in the sink once, we could write a controller without any simulation whatsoever, and we could call it done. But we want to understand, like, what is the path you take to actually get to a robot that could perform that for any dish in anybody's kitchen with enough confidence that it could be a commercial product, right? And it has deep learning perception in the loop. It has complex dynamics in the loop. It has controller. It has a planner. And how do you take all of that complexity and put it through this engineering discipline and verification and validation process to actually get enough confidence to deploy? I mean, the DARPA challenge made me realize that that's not something you throw over the fence and hope that somebody will harden it for you, that there are really fundamental challenges in closing that last gap.
They're doing the validation and the testing.
I think it might even change the way we have to think about the way we write systems. What happens if you have the robot running lots of tests, it screws up, it breaks a dish, right? How do you capture that? I said you can't run the same simulation or the same experiment twice on a real robot. Do we have to be able to bring that one-off failure back into simulation in order to change our controllers, study it, make sure it won't happen again? Is it enough to just try to add that to our distribution and understand that on average, we're going to cover that situation again? There's like really subtle questions at the corner cases that I think we don't yet have satisfying answers for.
Like, how do you find the corner cases? That's one kind of. Do you think it's possible to create a systematized way of discovering corner cases efficiently?
Yes.
In whatever the problem is?
Yes. I mean, I think we have to get better at that. I mean, control theory has, for decades, talked about active experiment design.
What's that?
So people call it curiosity these days. It's roughly this idea of trying to exploration or exploitation, but in the active experiment design is more specific. You could try to understand the uncertainty in your system, design the experiment that will provide the maximum information to reduce that uncertainty. If there's a parameter you want to learn about, what is the optimal trajectory I could execute to learn about that parameter, for instance? Scaling that up to something that has a deep network in the loop and a planning in the loop is tough. We've done some work on, with Matt O'Kelly and Amansina, we've worked on some falsification algorithms that are trying to do rare event simulation that try to just hammer on your simulator. And if your simulator is good enough, you can spend a lot of time, or you can write good algorithms that try to spend most of their time in the corner cases. So you basically imagine you're building an autonomous car and you want to put it in, downtown New Delhi all the time, right? Accelerated testing. If you can write sampling strategies which figure out where your controller is performing badly in simulation and start generating lots of examples around that, it's just the space of possible places where things can go wrong is very big. So it's hard to write those algorithms.
Yeah, rare event simulation is just like a really compelling notion. If it's possible,
we joked and we call it the black swan generator.
It's a black swan,
right? Because you don't just want the rare events; you want the ones that are highly impactful.
I mean, those are the most sort of profound questions we ask of our world. Like, what's the worst that can happen? But what we're really asking isn't some kind of like computer science worst case analysis. We're asking like, what are the millions of ways this can go wrong? And that's like our curiosity. We humans, I think, are pretty bad at, we just like run into it. And I think there's a distributed sense because there's now like 7.5 billion of us. And so there's a lot of them, and then a lot of them write blog posts about the stupid thing they've done. So we learn in a distributed way. There's some.
I think that's going to be important for robots too.
Yeah,
I mean that's another massive theme at Toyota Research for robotics is this fleet learning concept. Is the idea that I, as a humanoid, don't have enough time to visit all of my states. Right? It's very hard for one robot to experience all the things. But that's not actually the problem we have to solve, right? We're going to have fleets of robots that can have very similar appendages. And at some point, maybe collectively, they have enough data that their computational processes should be set up differently than ours, right?
I have this vision of just, all these dishwasher unloading robots. That robot dropping a plate and a human looking at the robot, probably pissed off.
Yeah.
But that's a special moment to record. I think one thing in terms of fleet learning, and I've seen that because I've talked to a lot of folks, just like Tesla users or Tesla drivers. They're another company that's using this kind of fleet learning idea. And one hopeful thing I have about humans is they really enjoy when a system improves, learns. So they enjoy fleet learning. And they're the reason it's hopeful for me is they're willing to put up with something that's kind of dumb right now. And they're like, if it's improving, they almost like enjoy being part of the, like, teaching it. Almost like if you have kids, like you're teaching them something.
Right.
And, I think that's a beautiful thing, because that gives me hope that we can put dumb robots out there. The problem with on the Tesla side with cars can kill you. That makes the problem so much harder. Dishwasher unloading is a little safe. That's why home robotics is really exciting. And just to clarify, for people who might not know, TRI, Toyota Research Institute, so they're pretty well known for like autonomous vehicle research, but they're also interested in home robotics.
Yep. There's a big group multiple groups working on home robotics. It's a major part of the portfolio.
Awesome.
There's also a couple other projects in advanced materials discovery, using AI and machine learning to discover new materials for car batteries and the like, for instance. Yeah. Cool. And that's been actually an incredibly successful team. There's new projects starting up too. So
I think we've kind of talked about it, but you taught a course on underactuated robotics. I believe that was the name of it, actually.
That's right.
Can you talk about it in that context? What is underactuated robotics?
Right. So underactuated robotics is my graduate course. It's online mostly now. So, in the sense that the lectures
versions of it, I think.
Right.
The YouTube, really great. I recommend it highly.
Look on YouTube for the 2020 versions until March, and then you have to go back to 2019 thanks to COVID. No, I've poured my heart into that class. And lecture 1 is basically explaining what the word underactuated means. So people are very kind to show up and then maybe have to learn what the title of the course means over the course of the first lecture.
That first lecture is really good. You should watch it.
Thanks. It's a strange name, but I thought it captured the essence of what control was good at doing and what control was bad at doing. So what do I mean by underactuated? So a mechanical system has many degrees of freedom, for instance. I think of a joint as a degree of freedom, and it has some number of actuators, motors. So if you have a robot that's bolted to the table that has 5 degrees of freedom and 5 motors, then you have a fully actuated robot. If you take away one of those motors, then you have an underactuated robot. Now, why on earth? I have a good friend who likes to tease me. He said, Russ, if you had more research funding, would you work on fully actuated robots?
Yeah.
And the answer is no. The world gives us underactuated robots, whether we like it or not. I'm a human. I'm an underactuated robot, even though I have more muscles than my big degrees of freedom, because I have, in some places, multiple muscles attached to the same joint. But still, there's a really important degree of freedom that I have, which is the location of my center of mass in space, for instance. All right, I can jump into the air, and there's no motor that connects my center of mass to the ground in that case. So I have to think about the implications of not having control over everything. The passive dynamic walkers are the extreme view of that, where you've taken away all the motors, and you have to let physics do the work. But it shows up in all of the walking robots, where you have to use some of the actuators to push and pull even the degrees of freedom that you don't have an actuator on.
That's referring to walking if you're like falling forward. Like, is there a way to walk that's fully actuated?
So it's a subtle point. When you're in contact and you have your feet on the ground, there are still limits to what you can do, right? Unless I have suction cups on my feet, I cannot accelerate my center of mass towards the ground faster than gravity because I can't get a force pushing me down, right? But I can still do most of the things that I want to. So you can get away with basically thinking of the system as fully actuated unless you suddenly needed to accelerate down super fast. But as soon as I take a step, I get into more nuanced territory. And to get to really dynamic robots or airplanes or other things, I think you have to embrace the underactuated dynamics. Manipulation, people think, is manipulation underactuated? Even if my arm is fully actuated, I have a motor. If my goal is to control the position and orientation of this cup, then I don't have an actuator for that directly. So I have to use my actuators over here to control this thing. Now it gets even worse. Like, what if I have to button my shirt? Okay. What are the degrees of freedom of my shirt, right? That's a hard question to think about. Yeah. It kind of makes me queasy as thinking about my state space control ideas. But actually those are the problems that make me so excited about manipulation right now, is that it breaks some of it breaks a lot of the foundational control stuff that I've been thinking about.
Is there, what are some interesting insights you could say about trying to solve an underactuated, like control in an underactuated system?
So I think the philosophy there is let physics do more of the work. The technical approach has been optimization. So you typically formulate your decision-making for control as an optimization problem, and you use the language of optimal control, and sometimes often numerical optimal control, in order to make those decisions and balance, these complicated equations and in order to control. You don't have to use optimal control to do underactuated systems, but that has been the technical approach that has borne the most fruit at least in our line of work.
And there's so in underactuated systems, when you say let physics do some of the work, so there's a kind of feedback loop that observes the state that the physics brought you to. So like there's a perception there. There's a feedback somehow. Do you ever loop in like complicated perception systems into this whole picture?
Right around the time of the DARPA challenge, we had a complicated perception system in the DARPA challenge. We also started to embrace perception for our flying vehicles at the time. We had a really good project on trying to make airplanes fly at high speeds through forests. Sertac Karaman was on that project, and it was a really fun team to work on. He's carried it much farther forward since then.
And so that's using cameras for perception?
So that was using cameras. At the time, we felt like LiDAR was too heavy and too power heavy to be carried on a light UAV, and we were using cameras. And that was a big part of it, was just how do you do even stereo matching at a fast enough rate with a small camera, a small onboard compute. Since then, we have now, the deep learning revolution unquestionably changed what we can do with perception for robotics and control. So in manipulation, we can use perception in a much deeper way. And we get into not only, I think the first use of it naturally would be to ask your deep learning system to look at the cameras and produce the state, which is like the pose of my thing, for instance. But I think we've quickly found out that that's not always the right thing to do.
Why is that?
Because what's the state of my shirt? Imagine I've
very noisy, you mean? Or
if the first step of me trying to button my shirt is estimate the full state of my shirt, including like what's happening in the back here, whatever, that's just not the right specification. There's aspects of the state that are very important to the task. There are many that are unobservable and not important to the task. So you really need, it begs new questions about state representation. Another example that we've been playing with in lab has been just the idea of chopping onions, okay? Or carrots. Turns out to be better. So onions stink up the lab. And they're hard to see in a camera. But so
the details matter, yeah.
Details matter, So if I'm moving around a particular object, right, then I think about, it's got a position or an orientation in space. That's the description I want. Now, when I'm chopping an onion, okay, like the first chop comes down. I have now 100 pieces of onion. Does my control system really need to understand the position and orientation and even the shape of the 100 pieces of onion in order to make a decision? Probably not, and if I keep going, I'm just getting more and more. Is my state space getting bigger as I cut? It's not right. So somehow I think there's a richer idea of state. It's not the state that is given to us by Lagrangian mechanics. There is a proper Lagrangian state of the system, but the relevant state for this is some latent state, is what we call it in machine learning. But there's some different state representation,
some compressed representation,
and that's what I worry about saying compressed, because I don't mind that it's low dimensional or not, but it has to be something that's easier to think about
by us humans.
Or my algorithms.
Or the algorithms being like optimal control.
So for instance, if the contact mechanics of all of those onion pieces and all the permutations of possible touches between those onion pieces, you can give me a high dimensional state representation, I'm okay if it's linear.
Yeah.
But if I have to think about all the possible shattering combinatorics of that, then my robot's going to sit there thinking, and the soup's going to get cold or something.
So since you taught the course, it kind of entered my mind the idea of underactuated as really compelling to see the world in this kind of way. Do you ever, if we talk about onions or you talk about the world with people in it in general, do you see the world as basically an underactuated system? Do you often look at the world in this way, or is this overreach?
Underactuated is a way of life, man.
Exactly. I guess that's what I'm asking.
I do think it's everywhere. I think in some places, we already have natural tools to deal with it. It rears its head. I mean, in linear systems, it's not a problem. We just like an underactuated linear system is really not sufficiently distinct from a fully actuated linear system. It's a subtle point about when that becomes a bottleneck in what we know how to do with control. It happens to be a bottleneck, although we've gotten incredibly good solutions now. But for a long time, I felt that was the key bottleneck in legged robots. And roughly now, the underactuated course is, me trying to tell people everything I can about how to make Atlas do a backflip, right? I have a second course now that I teach in the other semesters, which is on manipulation. And that's where we get into now more of that's a newer class. I'm hoping to put it online this fall completely. And that's going to have much more aspects about these perception problems and the state representation questions, and then how do you do control. And the thing that's a little bit sad is that, for me at least, is there's a lot of manipulation tasks that people want to do and should want to do. They could start a company with it and be very successful, that don't actually require you to think that much about or dynamics at all, even, but certainly underactuated dynamics. Once I have, if I reach out and grab something, if I can sort of assume it's rigidly attached to my hand, then I can do a lot of interesting, meaningful things with it without really ever thinking about the dynamics of that object. So we've built systems that kind of reduce the need for that, enveloping grasps and the like. But I think the really good problems in manipulation. So manipulation, by the way, is more than just pick and place. That's like a lot of people think of that, just grasping. I don't mean that. I mean buttoning my shirt. I mean tying shoelaces. How do you program a robot to tie shoelaces? And not just one shoe, but every shoe, right? That's a really good problem. It's tempting to write down like the infinite dimensional state of the of the laces. That's probably not needed to write a good controller. I know we could hand design a controller that would do it, but I don't want that. I want to understand the principles that would allow me to solve another problem that's kind of like that. But I think if we can stay pure in our approach, then the challenge of tying anybody's shoes is a great challenge.
That's a great challenge. I mean, and the soft touch comes into play there. That's really interesting. First of all, I mean, I'll probably do it in the introduction, but you're one of the great robotics people at MIT. You're a professor at MIT. You teach a lot of amazing courses. You run a large group, and you have a important history for MIT, I think, as being a part of the DARPA Robotics Challenge. Can you maybe first say what is the DARPA Robotics Challenge, and then tell your story around it, your journey with it?
Yeah, sure. So the DARPA Robotics Challenge, it came on the tails of the DARPA Grand Challenge and DARPA Urban Challenge, which were the challenges that brought us, put a spotlight on self-driving cars. Gil Pratt was at DARPA and pitched a new challenge that involved disaster response. It didn't explicitly require humanoids, although humanoids came into the picture. This happened shortly after the Fukushima disaster in Japan, and our challenge was motivated roughly by that, because that was a case where if we had had robots that were ready to be sent in, there's a chance that we could have averted disaster. And certainly after in the disaster response, there were times where we would have loved to have sent robots in. So in practice, what we ended up with was a grand challenge, a DARPA Robotics Challenge, where Boston Dynamics was to make humanoid robots. People like me and the amazing team at MIT were competing first in a simulation challenge to try to be one of the ones that wins the right to work on one of the Boston Dynamics humanoids in order to compete in the final challenge, which was a physical challenge.
And at that point, it was decided as humanoid robots early on.
There were two tracks. You could enter as a hardware team where you brought your own robot, or you could enter through the Virtual Robotics Challenge as a software team that would try to win the right to use one of the Boston Dynamics robots.
Which are called Atlas.
Humanoid
robots.
Yeah. It was a 400-pound marvel, but a pretty big, scary-looking robot.
Expensive too.
Expensive
at the time, yeah.
Mm-hmm.
Okay, so I mean, how did you feel at the prospect of this kind of challenge? I mean, it seems, autonomous vehicles. Yeah, I guess that sounds hard, but not really. From a robotics perspective, it's like, didn't they do it in the 80s? Is the kind of feeling I would have, like when you first look at the problem. It's on wheels, but like humanoid robots. That sounds really hard. So what are psychologically speaking, what were you feeling? Excited, scared? Why the heck did you get yourself involved in this kind of messy challenge?
We didn't really know for sure what we were signing up for, in the sense that you could have something that, as it was described in the call for participation, that could have put a huge emphasis on the dynamics of walking and not falling down and walking over rough terrain, or the same description, because the robot had to go into this disaster area and turn valves and pick up a drill, cut the hole through a wall. It had to do some interesting things. The challenge could have really highlighted perception and autonomous planning, or it ended up that locomoting over complex terrain played a pretty big role in the competition. So.
And the degree of autonomy wasn't clear.
The degree of autonomy was always a central part of the discussion. So what wasn't clear was how far we would be able to get with it. So the idea was always that you want semi-autonomy, that you want the robot to have enough compute that you can have a degraded network link to a human. And so the same way we had degraded networks at many natural disasters, you'd send your robot in, you'd be able to get a few bits back and forth, but you don't get to have enough potentially to fully operate the robot, every joint of the robot. So, and then the question was, and the gamesmanship of the organizers was to figure out what we're capable of, push us as far as we could, so that it would differentiate the teams that put more autonomy on the robot and had a few clicks and just said, go there, do this, go there, do this, versus someone who's picking every footstep or something like that.
So what were some memories, painful, triumphant, from the experience? Like, what was that journey? Maybe if you can dig in a little deeper, maybe even on the technical side, on the team side, that whole process of from the early idea stages to actually competing.
I mean, this was a defining experience for me. It came at the right time for me in my career. I had gotten tenure before I was due a sabbatical, and most people do something, relaxing and restorative for a sabbatical.
So you got tenure before before this?
Yeah. It was a good time for me. We had a bunch of algorithms that we were very happy with. We wanted to see how far we could push them, and this was a chance to really test our mettle, to do more proper software engineering. The team, we all just worked our butts off. We, were in that lab almost all the time. Okay, so there were some, of course, high highs and low lows throughout that. Anytime you're, not sleeping and devoting your life to a 400-pound humanoid. I remember actually one funny moment where we're all super tired, and so Atlas had to walk across cinder blocks. That was one of the obstacles. And I remember Atlas was powered down and hanging limp, on its harness, and the humans were there, like laying, picking up and laying the brick down so that the robot could walk over it. And I thought, what is wrong with this? We've got a robot just watching us do all the manual labor so that it can take its little, stroll across the terrain. Yeah. But even the virtual robotics challenge was super nerve-wracking and dramatic. I remember. So we were using Gazebo as a simulator on the cloud, and there was all these interesting challenges. I think the investment that OSR FC, whatever they were called at that time, Brian Gerke's team at Open Source Robotics, they were pushing on the capabilities of Gazebo in order to scale it to the complexity of these challenges. So, up to the virtual competition. So the virtual competition was, you will sign on at a certain time, and we'll have a network connection to another machine on the cloud that is running the simulator of your robot. And your controller will run on this computer, and the physics will run on the other, and you have to connect. Now, the physics, they wanted it to run at real-time rates because there was an element of human interaction, and humans could, if you do want to tally up, it works way better if it's at frame rate.
Oh, cool. Mm-hmm.
But it was very hard to simulate these complex scenes at real-time rate. So right up to like days before the competition, the simulator wasn't quite at real-time rate. And that was great for me because my controller was solving a pretty big optimization problem. And it wasn't quite at real-time rate. So I was fine. I was keeping up with the simulator. We were both running at about 0.7. And I remember getting this email. And by the way, the perception folks on our team hated that they knew that if my controller was too slow, the robot was going to fall down. And no matter how good their perception system was, if I can't make my controller fast enough. Anyways, we get this email like 3 days before the virtual competition. It's for all the marbles. We're going to either get a humanoid robot or we're not. Mm-hmm. And we get an email saying, good news. We made the robot, does the simulator faster. It's now 1 point. And I was just like, oh man, what are we going to do here? So that came in late at night for me.
A few days ahead.
I went over, it happened that Frank Permenter, who's a very, very sharp, he was a student at the time, working on optimization. He was still in lab. Frank, we need to make this quadratic programming solver faster. Not like a little faster. It's actually, and we wrote a new solver for that QP together that night.
And you solve terrifying. So there's a really hard optimization problem that you're constantly solving. You didn't make the optimization problem simpler. You wrote a new solver.
So, I mean, your observation is almost spot on. What we did was what everybody, I mean, people know how to do this, but we had not yet done this idea of warm starting. So we are solving a big optimization problem at every time step. But if you're running fast enough, the optimization problem you're solving on the last time step is pretty similar to the optimization you're going to solve at the next.
Got it.
We, of course, had told our commercial solver to use warm starting, but even the interface to that commercial solver was causing us these delays. So what we did was we basically wrote, we called it fast QP at the time. We wrote a very lightweight, very fast layer, which would basically check if nearby solutions to the quadratic program which were very easily checked, could stabilize the robot. And if they couldn't, we would fall back to the solver.
You couldn't really test this well, right? Or like,
I mean, so we always knew that if we fell back to, it got to the point where if for some reason things slowed down and we fell back to the original solver, the robot would actually literally fall down. So it was a harrowing sort of ledge we were sort of on. But I mean, it actually, like the 400-pound humanoid could come crashing to the ground if your solver's not fast enough. But yeah, we had lots of good experiences.
So can I ask you a weird question? I get about the idea of hard work. So actually, people like students of yours that I've interacted with, and just in robotics, people in general, but they have moments have worked harder than most people I know in terms of, if you look at different disciplines of how hard people work, but they're also like the happiest. Like, just like, I don't know. It's the same thing with like running. People that push themselves to like the limit, they also seem to be like the most like full of life somehow. And I get often criticized, like, you're not getting enough sleep. What are you doing to your body? Blah, blah, blah. Like this kind of stuff. And I usually just kind of respond like, I'm doing what I love. I'm passionate about it. I love it. I feel like it's invigorating. I don't think the lack of sleep is what hurts you. I think what hurts you is stress and lack of doing things that you're passionate about. But in this world, yeah, I mean, can you comment about why the heck robotics people are willing to push themselves to that degree? Is there value in that? And why are they so happy?
I think you got it right. I mean, I think the causality is not that we work hard, and I think other disciplines work very hard too, but I don't think it's that we work hard and therefore we are happy. I think we found something that we're truly passionate about. It makes us very happy. And then we get a little involved with it and spend a lot of time on it. What a luxury to have something that you want to spend all your time on, right?
We could talk about this for many hours, but maybe if we could pick, is there something on the technical side, on the approach that you took that's interesting, that turned out to be a terrible failure or a success that you carry into your work today, about all the different ideas that were involved in making, whether in the simulation or in the real world, making this semi-autonomous system work?
I mean, it really did teach me something fundamental about what it's going to take to get robustness out of a system of this complexity. I would say the DARPA challenge really was foundational in my thinking. I think the autonomous driving community thinks about this. I think lots of people thinking about safety critical systems that might have machine learning in the loop are thinking about these questions. For me, the DARPA challenge was the moment where I realized, we've spent every waking minute running this robot. And again, for the physical competition, days before the competition, we saw the robot fall down in a way it had never fallen down before. I thought, how could we have found that? We only have one robot. It's running almost all the time. We just didn't have enough hours in the day to test that robot. Something has to change, right? And I think that, I would say that the team that won was from KAIST, was the team that had two robots and was able to do not only incredible engineering, just absolutely top rate engineering, but also they were able to test at a rate and discipline that we didn't keep up with.
What does testing look like? What are we talking about here? Like what's a loop of test, like from start to finish, what does a loop of testing look like?
Yeah, I mean, I think there's a whole philosophy to testing. There's the unit tests, and you can do that on a hardware. You can do that in a small piece of code. You write one function, you should write a test that checks that function's input and outputs. You should also write an integration test at the other extreme of running the whole system together, where that try to turn on all of the different functions that you think are correct. It's much harder to write the specifications for a system level test, especially if that system is as complicated as a humanoid robot. But the philosophy is sort of the same. On the real robot, it's no different, but on a real robot, it's impossible to run the same experiment twice. So if you see a failure, you hope you caught something in the logs that tell you what happened, but you'd probably never be able to run exactly that experiment again. And right now, I think our philosophy is just basically Monte Carlo estimation, is just run as many experiments as we can, maybe try to set up the environment to make the things we are worried about happen as often as possible. But really, we're relying on somewhat random search in order to test. Maybe that's all we'll ever be able to. But I think, because there's an argument that the things that'll get you are the things that are really nuanced in the world, and it'll be very hard to, for instance, put back in a simulation.
Yeah, I guess the edge cases. What was the hardest thing? Like, so you said walking over rough terrain, like just taking footsteps. I mean, people. It's so dramatic and painful in a certain kind of way to watch these videos from the DRC of robots falling.
Yep.
It's just so heartbreaking. I don't know. Maybe it's because, for me at least, we anthropomorphize the robot. Of course, it's also funny for some reason. Like humans falling is funny. It's some dark reason. I'm not sure why it is so, but it's also like tragic and painful. And so, speaking of which, I mean, what made the robots fall and fail in your view?
So I can tell you exactly what happened I contributed one of those. Our team contributed one of those spectacular falls. Every one of those falls has a complicated story. I mean, at one time, the power effectively went out on the robot because it had been sitting at the door waiting for a green light to be able to proceed, and its batteries, and therefore it just fell backwards and smashed its head to its ground, and it was hilarious, but it wasn't because of bad software, right? But for ours, so the hardest part of the challenge, the hardest task, in my view, was getting out of the Polaris. It was actually relatively easy to drive the Polaris. Can
you tell the story? Sorry to interrupt.
No,
the story of the car. People should watch this video. I mean, the thing you've come up with is just brilliant. But anyway, sorry. What's
we kind of joke. We call it the big robot little car problem because somehow the race organizers decided to give us a 400-pound humanoid, and then they also provided the vehicle, which was a little Polaris, and the robot didn't really fit in the car, so you couldn't drive the car with your feet under the steering column. We actually had to straddle the main column of the and have basically one foot in the passenger seat, one foot in the driver's seat, and then drive with our left hand. But the hard part was we had to then park the car, get out of the car. It didn't have a door, that was okay, but it's just getting up from crouched, from sitting, when you're in this very constrained environment.
First of all, I remember after watching those videos, I was much more cognizant of how hard it is for me to get in and out of the car especially. Like, it's actually a really difficult control problem.
Yeah.
I'm very cognizant of it when I'm like injured for whatever reason.
It's really hard.
Yeah. So how did you approach this problem?
So we had you think of NASA's operations, and they have these checklists, pre-launch checklists, and the like. We weren't far off from that. We had this big checklist, and on the first day of the competition, we were running down our checklist, and one of the things we had to do, we had to turn off the controller, the piece of software that was running, that would drive the left foot of the robot in order to accelerate on the gas, and then we turned on our balancing controller. And the nerves, jitters of the first day of the competition, someone forgot to check that box and turn that controller off. So we used a lot of motion planning to figure out a sort of configuration of the robot that we could get up and over. We relied heavily on our balancing controller. And basically when the robot was in one of its most precarious, sort of configurations, trying to sneak its big leg out of the side, the other controller that thought it was still driving told its left foot to go like this, and that wasn't good. But it turned disastrous for us because what happened was a little bit of push here. Actually, we have videos of us, running into the robot with a 10-foot pole, and it kind of will recover. But this is a case where there's no space to recover. So a lot of our secondary balancing mechanisms about like take a step to recover, they were all disabled because we were in the car and there's no place to step. So we were relying on our just lowest level reflexes. And even then, I think just hitting the foot on the seat, on the floor, we probably could have recovered from it. But the thing that was bad that happened is when we did that and we jostled a little bit, the tailbone of our robot was only a little off the seat. It hit the seat. And the other foot came off the ground just a little bit. Wow. And nothing in our plans had ever told us what to do if your butt's on the seat and your feet are in the air.
Feet in the air.
And then the thing is, once you get off the script, things can go very wrong, because even our state estimation, our system that was trying to collect all the data from the sensors and understand what's happening with the robot, it didn't know about this situation. So it was predicting things that were just wrong. And then we did a violent shake and fell off in our face first out of the robot.
But like into the destination.
That's true. We fell in, we got our point for egress.
But so is there any hope that's interesting. Is there any hope for Atlas to be able to do something when it's just on its butt and feet in the air?
Absolutely.
So you can,
No, so that is one of the big challenges. And I think it's still true. Boston Dynamics and Animal, and there's this incredible work on legged robots happening around the world. Most of them still are very good at the case where you're making contact with the world at your feet, and they have typically point feet relatively. They're balls on their feet, for instance. If those robots get in a situation where the elbow hits the wall or something like this, that's a pretty different situation. Now they have layers of mechanisms that will make, I think, the more mature solutions have ways in which the controller won't do stupid things. But a human, for instance, is able to leverage incidental contact in order to accomplish a goal. In fact, if you push me, I might actually put my hand out and make a brand new contact. The feet of the robot are doing this on quadrupeds, but we mostly in robotics are afraid of contact on the rest of our body, which is crazy. There's this whole field of motion planning, collision-free motion planning. And we write very complex algorithms so that the robot can dance around and make sure it doesn't touch the world.
So people are just afraid of contact because contact is seen as it's
still a difficult control problem and sensing problem.
Do you see a future of where like robots are in our home and like robots that have like actuators that look like arms in our home, or like, more like humanoid type robots? Or are we gonna do the same thing that you just mentioned, that the dishwasher is no longer a robot? We're going to just not even see them as robots. But what's your vision of the home of the future 10, 20 years from now, 50 years if you get crazy?
Yeah, I think we already have Roombas cruising around. We have Alexas or Google Homes on our kitchen counter. It's only a matter of time till they spring arms and start doing something useful like that. So I do think it's coming. I think lots of people have lots of motivations for doing it. It's been super interesting actually learning about Toyota's vision for it, which is about helping people age in place. Because I think that's not necessarily the first entry, the most lucrative entry point, but it's the problem maybe that we really need to solve no matter what. And so I think there's a real opportunity. It's a delicate problem. How do you work with people, help people, keep them active, engaged, but improve their quality of life and help them age in place, for instance.
It's interesting because older folks are also, there's a contrast there because they're not always the folks who are the most comfortable with technology, for example. So there's a division that's interesting there, that you can do so much good with a robot for older folks, but there's a gap to fill of understanding. It's actually kind of beautiful. Robot is learning about the human, and the human is kind of learning about this new robot thing. And it's also with at least with like when I talk to my parents about robots, there's a little bit of a blank slate there too. Like you can, they don't know anything about robotics, so it's completely like wide open. They don't have, they haven't, my parents haven't seen Black Mirror. so like it's a blank slate. Here's a cool thing. Like, what can it do for me?
Yeah.
So it's an exciting space.
I think it's a really important space. I do feel like, a few years ago, drones were successful enough in academia. They kind of broke out and started in industry, and autonomous cars have been happening. It does feel like manipulation in logistics, of course, first, but in the home shortly after seems like one of the next big things that's going to really pop.
Can you say, what does it take to control a robot? Like, what is the control problem of a robot? And in general, what is a robot in your view? Like, how do you think of this system?
What is a robot?
What is a robot?
I think
robotics. Told you ridiculous questions.
No, it's good. There's standard definitions of combining computation with some ability to do mechanical work. I think that gets us pretty close. But I think robotics has this problem that once things really work, we don't call them robots anymore. Like my dishwasher at home is pretty sophisticated, beautiful mechanisms. There's actually a pretty good computer, probably a couple chips in there doing amazing things. We don't think of that as a robot anymore, which isn't fair, because then what roughly it means that robotics always has to solve the next problem and doesn't get to celebrate its past successes. Even factory room floor robots are super successful. They're amazing. But that's not the ones, people think of them as robots, but they don't, if you ask what are the successes of robotics, somehow it doesn't come to your mind immediately.
So the definition of robot is a system with some level of automation that fails frequently.
Something like it's the computation plus mechanical work and an unsolved problem.
Unsolved problem, yeah. So from a perspective of control and mechanics, dynamics, what is a robot?
So there are many different types of robots. The control that you need for a Jibo robot, some robot that's sitting on your countertop and interacting with you but not touching you, for instance, is very different than what you need for an autonomous car or an autonomous drone. It's very different than what you need for a robot that's going to walk or pick things up with its hands, right? My passion has always been for the places where you're interacting more, you're doing more dynamic interactions with the world. So walking, now manipulation. And the control problems there are beautiful. I think contact is one thing that differentiates them from many of the control problems we've solved classically, right? The modern control grew up stabilizing fighter jets that were passively unstable, and there's like amazing success stories from control all over the place. Power grid, there's all kinds of, it's everywhere that we don't even realize, just like AI is now.
So you mentioned contact. Like, what's contact?
So an airplane is an extremely complex system, or a spacecraft landing or whatever. But at least it has the luxury of things change relatively continuously. That's an oversimplification. But if I make a small change in the command I send to my actuator, then the path that the robot will take tends to change only by a small amount.
And there's a feedback mechanism here. That's what we're talking about.
Mechanism. And thinking about this as locally, like a linear system, for instance, I can use more linear algebra tools to study systems like that, generalizations of linear algebra to these smooth systems. What is contact? The robot has something very discontinuous that happens when it makes or breaks, when it starts touching the world. And even the way it touches or the order of contacts can change the outcome in potentially unpredictable ways. Not unpredictable, but complex ways. I do think there's a little bit of a lot of people will say that contact is hard in robotics, even to simulate. And I think there's a little bit of there's truth to that, but maybe a misunderstanding around that. So what is limiting is that when we think about our robots and we write our simulators, we often make an assumption that objects are rigid. And when it comes down, that their mass moves stays in a constant position relative to each other itself. And that leads to some paradoxes when you go to try to talk about rigid body mechanics and contact. And so, for instance, if I have a 3-legged stool with just imagine it comes to a point at the legs, so it's only touching the world at a point. If I draw my high school physics diagram of this system, then there's a couple of things that I'm given by elementary physics. I know if the table is at rest, if it's not moving, it's zero velocities. That means that the normal force, all the forces are in balance. So the force of gravity is being countered by the forces that the ground is pushing on my table legs. I also know, since it's not rotating, that the moments have to balance. And since it's a 3-dimensional table, it could fall in any direction. It actually tells me uniquely what those 3 normal forces have to be. If I have 4 legs on my table, 4-legged table, and they were perfectly machined to be exactly the same height, and they're set down and the table's not moving, then the basic conservation laws don't tell me there are many solutions for the forces that the ground could be putting on my legs that would still result in the table not moving. Now, the reason that seems fine, I could just pick one. But it gets funny now, because if you think about friction, what we think about with friction is our standard model says the amount of force that the table will push back. If I were to now try to push my table sideways, I guess I have a table here, is proportional to the normal force. So if I'm barely touching and I push, I'll slide. But if I'm pushing more and I push, I'll slide less. It's called Coulomb friction, is our standard model. Now, if you don't know what the normal force is on the 4 legs and you push the table, then you don't know what the friction forces are going to be.
Right.
And so you can't actually tell. The laws just aren't explicit yet about which way the table's going to go. It could veer off to the left. It could veer off to the right. It could go straight. So the rigid body assumption of contact leaves us with some paradoxes, which are annoying for writing simulators and for writing controllers. We still do that sometimes because soft contact is potentially harder numerically or whatever, and the best simulators do both or do some combination of the two. But anyways, because of these kind of paradoxes, there's all kinds of paradoxes in contact, mostly due to these rigid body assumptions. It becomes very hard to write the same kind of control laws that we've been able to be successful with for fighter jets. We haven't been as successful writing those controllers for manipulation.
Right, so you don't know what's going to happen at the point of contact, at the moment of contact.
There are situations absolutely where our laws don't tell us. So the standard approach, that's okay. I mean, instead of having a differential equation, you end up with a differential inclusion, it's called. It's a set valued equation. It says that I'm in this configuration, I have these forces applied on me, and there's a set of things that could happen, right? And
those aren't continuous. So when you say like non-smooth, they're not only not smooth, but this is discontinuous?
The non-smooth comes in when I make or break a new contact first, or when I transition from stick to slip. So you typically have static friction, and then you'll start sliding, and that'll be a discontinuous change in velocity, for instance, especially if you come to rest or.
That's so fascinating. Okay, so what do you do? Sorry, I interrupted you.
That's fine.
What's the hope under so much uncertainty about what's going to happen? What are you supposed to do?
I mean, control has an answer for this. Robust control is one approach, but roughly, you can write controllers which try to still perform the right task despite all the things that could possibly happen. The world might want the table to go this way and this way, but if I write a controller that pushes a little bit more and pushes a little bit, I can certainly make the table go in the direction I want. It just puts a little bit more of a burden on the control system, right? And these discontinuities do change the control system because the way we write it down right now, every different control configuration, including sticking or sliding or parts of my body that are in contact or not, looks like a different system. And I think of them, I reason about them separately or differently, and the combinatorics of that blow up, right? So I just don't have enough time to compute all the possible contact configurations of my humanoid. Mm-hmm. Interestingly, I mean, I'm a humanoid. I have lots of degrees of freedom, lots of joints. I've only been around for a handful of years. It's getting up there, but I haven't had time in my life to visit all of the states in my system. Certainly all the contact configurations. So if step one is to consider every possible contact configuration that I'll ever be in, that's probably not a problem I need to solve, right?
Just as a small tangent, what's a contact configuration? Just so we can enumerate, what are we talking about?
Yeah.
How many are there?
The simplest example maybe would be, imagine a robot with a flat foot. And we think about the phases of gait where the heel strikes and then the front toe strikes, and then you can heel up, toe off. Those are each different contact configurations. I only had 2 different contacts, but I ended up with 4 different contact configurations. Now, Of course, I might have my robot might actually have bumps on it or other things, so it could be much more subtle than that, right? But it's just even with one sort of box interacting with the ground already in the plane has that many, right? And if I was just even a 3D foot, then probably my left toe might touch just before my right toe and things get subtle. Now, if I'm a dexterous hand and I go to talk about just grabbing a water bottle, if I have to enumerate every possible order that my hand came into contact with the bottle, then I'm dead in the water. Any approach that we were able to get away with that in walking, because we mostly touched the ground within a small number of points, for instance, and we haven't been able to get dexterous hands that way.
So, I mean, you've mentioned that people think that contact is really hard, and that's the reason that robotic manipulation is really hard. Is there any flaws in that thinking?
So I think simulating contact is one aspect. And people often say that that one of the reasons that we have a limit in robotics is because we do not simulate contact accurately in our simulators. And I think that is the extent to which that's true is partly because our simulators, we haven't got mature enough simulators. There are some things that are still hard, difficult, that we should change. But we know what the governing equations are. They have some foibles, like this indeterminacy, but we should be able to simulate them accurately. We have an incredible open source community in robotics, but it actually just takes a professional engineering team a lot of work to write a very good simulator like that.
Now where does I don't think we talked about it, but what's soft robotics? So we talked about like rigid bodies, Like, if we can just linger on this whole touch thing.
Yeah. So what's soft robotics? I told you that I really dislike the fact that robots are afraid of touching the world all over their body. So there's a couple reasons for that. If you look carefully at all the places that robots actually do touch the world, they're almost always soft. They have some sort of pad on their fingers or a rubber sole on their foot. But if you look up and down the arm, we're just pure aluminum or something. Yeah. So that makes it hard, actually. In fact, hitting the table with your rigid arm or nearly rigid arm it has some of the problems that we talked about in terms of simulation. I think it fundamentally changes the mechanics of contact when you're soft, right? You turn point contacts into patch contacts, which can have torsional friction. You can have distributed load. If I want to pick up an egg, right? If I pick it up with 2 points, then in order to put enough force to sustain the weight of the egg, I might have to put a lot of force to break the egg. If I envelop it with contact all around, then I can distribute my force across the shell of the egg and have a better chance of not breaking it. So soft robotics is, for me, a lot about changing the mechanics of contact.
Does it make the problem a lot harder?
Quite the opposite. It changes the computational problem. I think because of our world and our mathematics has biased us towards rigid.
I see.
But it really should make things better in some ways, right? I think the future is unwritten there. But the other thing it can do
ultimately, sorry to interrupt, but I think ultimately it will make things simpler if we embrace the softness of the world.
It makes things smoother, right? So the result of small actions is less discontinuous, but it also means potentially less, instantaneously bad. For instance, I won't necessarily contact something and send it flying off. The other aspect of it that just happens to dovetail really well is that soft robotics tends to be a place where we can embed a lot of sensors too. So if you change your hardware and make it more soft, then you can potentially have a tactile sensor, which is measuring the deformation. So there's a team at TRI that's working on soft hands, and you get so much more information if you can put a camera behind the skin roughly, and get fantastic tactile information, which is it's super important. Like in manipulation, one of the things that really is frustrating is if you work super hard on your perception system for your head-mounted cameras, and then you've identified an object, you reach down to touch it, and the last thing that happens right the most important time, you stick your hand and you're occluding your head-mounted sensors, right? So in all the part that really matters, all of your off-board sensors are occluded. And really, if you don't have tactile information, then you're blind in an important way. So it happens that soft robotics and tactile sensing tend to go hand in hand.
Let me ask another ridiculous question. I think this might be the last ridiculous question, but
I doubt it.
I aspire to ask as many ridiculous questions of a brilliant MIT professor. Okay. I don't know if you've seen the Black Mirror.
It's funny. I never watched the episode. I know when it happened, though, because I gave a talk to some MIT faculty one day on a unassuming, Monday or whatever. I was telling them about the state of robotics. And I showed some video from Boston Dynamics of the quadruped Spot at the time. It was the early version of Spot. And there was a look of horror that went across the room. And I said, "What? I've shown videos like this a lot of times. What happened?" And it turns out that this video this Black Mirror episode had changed the way people watched the videos I was putting out.
The way they see these kinds of robots. So I talked to so many people who are just terrified because of that episode, probably, of these kinds of robots. I almost want to say they almost kind of like enjoy being terrified. I don't even know what it is about human psychology that kind of imagine doomsday, the destruction of the universe or our society, and kind of like enjoy being afraid. I don't want to simplify it, but it feels like they talk about it so often. It almost there does seem to be an addictive quality to it. I talked to a guy, there's a guy named Joe Rogan, who's kind of the flag bearer for being terrified of these robots. Do you have two questions? One, do you have an understanding of why people are afraid of robots? And the second question is, in Black Mirror, just to tell you the episode, I don't even remember it that much anymore, but these robots, I think they can shoot like a pellet or something. They basically have, it's basically a spot with a gun. And how far are we away from having robots that go rogue like that? You know, basically Spot that goes rogue for some reason and somehow finds a gun.
Right. So, I mean, I'm not a psychologist. I think I don't know exactly why people react the way they do. I think we have to be careful about the way robots influence our society and the like. I think that's a responsibility that roboticists need to embrace. I don't think robots are going to come after me with a kitchen knife or a pellet gun right away. And I mean, if they were programmed in such a way, but I used to joke with Atlas that all I had to do was run for 5 minutes and its battery would run out. But actually, they've got a very big battery in there by the end. So it was over an hour. I think the fear is a bit cultural, though, because I mean, you notice that, like, I think in my age in the U.S., we grew up watching Terminator, right? If I had grown up at the same time in Japan, I probably would have been watching Astro Boy. And there's a very different reaction to robots in different countries, right? So I don't know if it's a human innate fear of metal marvels or if it's something that we've done to ourselves with our sci-fi.
Yeah, the stories we tell ourselves through movies, through just through popular media. But if I were to tell, you know, if you were my therapist and I said I'm really terrified that we're going to have these robots very soon that will hurt us, like, how do you approach making me feel better? Like, why shouldn't people be afraid? I mean, I think there's a video that went viral recently. Everything with Spot and Boston Dynamics goes viral in general, but usually it's like really cool stuff, like they're doing flips and stuff, or like sad stuff, Atlas being hit with a broomstick or something like that. But there's a video where I think one of the new production Spot robots, which are awesome, it was like patrolling somewhere in some country, and like people immediately were like saying like this is like the dystopian future, like the surveillance state. For some reason, like you can just have a camera, like something about Spot being able to walk on 4 feet would like really terrified people. So like what do you say to those people? I think there is a legitimate fear there because so much of our future is uncertain. But at the same time, technically speaking, it seems like we're not there yet. So what do you say?
I mean, I think technology is complicated. It can be used in many ways. I think there are purely software attacks that somebody could use to do great damage. Maybe they have already. I think wheeled robots could be used in bad ways too. Drones, right? I don't think that. Let's see. I don't want to be building technology just because I'm compelled to build technology and I don't think about it. But I would consider myself a technological optimist, I guess, in the sense that I think we should continue to create and evolve, and our world will change. And if we will introduce new challenges, we'll screw something up maybe, but I think also we'll invent ourselves out of those challenges and life will go on.
So it's interesting because you didn't mention like this is technically too hard.
I don't think robots are. I think people attribute a robot that looks like an animal as maybe having a level of self-awareness or consciousness or something that they don't have yet, right? So it's not. I think our ability to anthropomorphize those robots is probably we're assuming that they have a level of intelligence that they don't yet have, and that might be part of the fear. So in that sense, it's too hard, but. There are many scary things in the world, right? So I think we're right to ask those questions. We're right to think about the implications of our work.
Right. In the short term, as we're working on it, for sure. Is there something long term that scares you about our future with AI and robots? A lot of folks, from Elon Musk to Sam Harris to a lot of folks talk about the existential threats about artificial intelligence. Oftentimes, robots kind of inspire that the most because of the anthropomorphism. Do you have any fears?
It's an important question. I think I like Rod Brooks' answer maybe the best on this. I think, and it's not the only answer he's given over the years, but maybe one of my favorites is, he says, it's not going to be, he's got a book, Flesh and Machines, I believe. It's not going to be the robots versus the people. We're all going to be robot people because, we already have smartphones. Some of us have serious technology implanted in our bodies already, whether we have a hearing aid or a pacemaker or anything like this. People with amputations might have prosthetics. That's a trend, I think, that is likely to continue. I mean, this is now wild speculation. But, when do we get to cognitive implants and the like? And
with Neuralink, brain-computer interfaces. That's interesting. So there's a dance between humans and robots. It's going to be impossible to be scared of the other out there, the robot, because the robot will be part of us, essentially. It'd be so intricately sort of part of our society that...
and it might not even be implanted part of us, but just it's so much a part of our society.
So in that sense, the smartphone is already the robot we should be afraid of. Yeah. And all the usual fears arise of the misinformation, the manipulation, all those kinds of things the problems are all the same. They're human problems, essentially. It feels like.
Yeah. I think the way we interact with each other online is changing the value we put on, personal interaction. And that's a crazy big change that's going to happen and rip through has already been ripping through our society, right? And that has implications that are massive. I don't know if they should be scared of it or go with the flow, but I don't see, some battle lines between humans and robots being the first thing to worry about.
I do want to just, as a kind of comment, and maybe you can comment about your just feelings about Boston Dynamics in general, but, I love science. I love engineering. I think there's so many beautiful ideas in it. And when I look at Boston Dynamics or legged robots in general, I think they inspire people curiosity and feelings in general, excitement about engineering more than almost anything else in popular culture. And I think that's such an exciting responsibility and possibility for robotics. And Boston Dynamics is riding that wave pretty damn well. Like, they found it, they've discovered that hunger and curiosity in the people, and they're doing magic with it. I don't care if I guess it's their company, they have to make money, right? But they're already doing incredible work and inspiring the world about technology. Do you have thoughts about Boston Dynamics and maybe others, your own work in robotics and inspiring the world in that way?
I completely agree. I think Boston Dynamics is absolutely awesome. I think I show my kids those videos, and the best thing that happens is sometimes they've already seen them, right? I think I just think it's a pinnacle of success in robotics that is just one of the best things that's happened. Absolutely, completely agree.
One of the heartbreaking things to me is how many robotics companies fail. Mm-hmm. How hard it is to make money with the robotics company. Like iRobot went through hell just to arrive at a Roomba to figure out one product. And then there's so many home robotics companies like Jibo and Anki. The cutest toy, that's a great robot, I thought, went down. I'm forgetting a bunch of them, but a bunch of robotics companies fail.
Yeah.
Rod's company, Rethink Robotics. Do you have anything hopeful to say about the possibility of making money with robots?
Oh, I think you can't just look at the failures. You can, Boston Dynamics is a success. There's lots of companies that are still doing amazingly good work in robotics. This is the capitalist ecology or something, right? I think you have many companies, you have many startups, and they push each other forward, and many of them fail, and some of them get through, and that's sort of the natural
way of
those things. I don't know that is robotics really that much worse. I feel the pain that you feel too. Every time I read one of these, I sometimes it's friends, and I definitely wish it went better or went differently. But I think it's healthy and good to have bursts of ideas, bursts of activities. Ideas, if they are really aggressive, they should fail sometimes. Certainly, that's the research mantra, right? If you're succeeding at every problem you attempt, then you're not choosing aggressively enough.
Is it exciting to you, the new Spot?
Oh, it's so good.
When are you getting him as a pet?
Yeah, I have to dig up $75K right now. But,
it's so cool that there's a price tag. You can go and then actually buy it. And
I have a Skydio R1. Love it. So, no, I would absolutely be a customer.
I wonder what your kids would think about it.
I actually. Zach from Boston Dynamics would let my kid drive in one of their demos one time, and that was just so good, so good. And again, I'll forever be grateful for that.
And there's something magical about the anthropomorphization of that arm. It adds another level of human connection. I'm not sure we understand from a control aspect the value of anthropomorphization. I think that's an understudied and understood engineering problem. There's been psychologists have been studying it. I think it's part manipulating our mind to believe things is a valuable engineering. This is another degree of freedom that can be controlled.
I like that. Yeah, I think that's right. I think there's something that humans seem to do, or maybe my dangerous introspection is. I think we are able to make very simple models that assume a lot about the world very quickly. And then it takes us a lot more time, like your wrestling. You probably thought you knew what you were doing with wrestling, and you were fairly functional as a complete wrestler. And then you slowly got more expertise. So maybe it's natural that our first level of defense against seeing a new robot is to think of it in our existing models of how humans and animals behave. And it's just, and as you spend more time with it, then you'll develop more sophisticated models that will appreciate the differences.
Exactly. Now you're a serious person. I'm a little bit of an idiot, and I'm going to ask you some dumb questions. So I do martial arts. So jiu-jitsu, I've wrestled my whole life. So let me ask the question, whenever people learn that I do any kind of AI, or I mentioned robots and things like that, they say, when are we going to have robots that, that can win in a wrestling match or in a fight against a human? So we just mentioned sitting on your butt, feet in the air. That's a common position in jiu-jitsu. When you're on the ground, when you're down opponent. difficult do you think is the problem? And when will we have a robot that can defeat a human in a wrestling match? And we're talking about a lot. Like, I don't know if you're familiar with wrestling, but essentially,
not very.
It's basically the art of contact. It's like it's because you're picking contact points, and then using like leverage, like to off balance to trick people. Like you make them feel like you're doing one thing, and then they change their balance, and then you switch what you're doing, and then results in a throw or whatever. So like it's basically the art of multiple contacts. So
awesome. That's a nice description of it. So there's also an opponent in there, right? So if
very dynamic,
right? If you are wrestling a human and are in a game theoretic situation with the human, that's still hard. But just to speak to the quickly reasoning about contact part of it, for instance,
maybe even throwing the game theory out of it, almost
right.
Almost like a non-dynamic opponent.
Right. There's reasons to be optimistic, but I think our best understanding of those problems are still pretty hard. I have been increasingly focused on manipulation, partly where that's a case where the contact has to be much more rich. And there are some really impressive examples of deep learning policies, controllers that can appear to do good things through contact. We've even got new examples of deep learning models of predicting what's going to happen to objects as they go through contact. But I think the challenge you just offered there still eludes us, right? The ability to make a decision based on those models quickly. I have to think, though, it's hard for humans too when you get that complicated. I think probably you had maybe a slow motion version of where you learn the basic skills, and you've probably gotten better at it. And there's much more subtlety, but it might still be hard to actually, really on the fly take a, model of your humanoid and figure out how to plan the optimal sequence. That might be a problem we never solve.
Well, one of the most amazing things to me about we can talk about martial arts. We could also talk about dancing. It doesn't really matter. It's too human. I think it's the most interesting study of contact. It's not even the dynamic element of it. It's when you get good at it, it's so effortless. Like I'm very cognizant of the entirety of the learning process being essentially like learning how to move my body in a way that I could throw very large weights around effortlessly. And I can feel the learning. Like I'm a huge believer in drilling of techniques, and you can just like feel you're learning it intellectually a little bit, but a lot of it is the body learning it somehow. Like instinctually, and whatever that learning is, that's really, I'm not even sure if that's equivalent to like a deep learning a controller. I think it's something more. It feels like there's a lot of distributed learning going on.
Yeah, I think there's hierarchy and composition.
Yeah,
probably in the systems that we don't capture very well yet. You have layers of control systems. You have reflexes at the bottom layer, and you have a system that's capable of planning a vacation to some distant country, which is you probably don't have a controller, a policy for every possible destination you'll ever pick, right? But there's something magical in the in-between, and how do you go from these low-level feedback loops to something that feels like a pretty complex set of outcomes. My guess is I think there's evidence that you can plan at some of these levels, right? So Josh Tenenbaum just showed it in his talk the other day. He's got a game he likes to talk about. I think he calls it the Pick 3 game or something, where he puts a bunch of clutter down in front of a person, and he says, "Okay, pick 3 objects," and it might be a telephone or a shoe or a Kleenex box or whatever. And apparently you pick 3 items, and then he says, okay, pick the first one up with your right hand, the second one up with your left hand. Now using those objects, now as tools, pick up the third object. Right. So that's down at the level of physics and mechanics and contact mechanics that I think we do have policies for, we do control for, almost feedback. But somehow we're able to still, I've never picked up a telephone with a shoe and a water bottle before. And it takes me a little longer to do that the first time. But most of the time we can sort of figure that out. So, yeah, I think the amazing thing is this ability to be flexible with our models, plan when we need to, use our well-oiled controllers when we don't, when we're in familiar territory. Having models, I think the other thing you just said was something about, I think your awareness of what's happening is even changing as you improve your expertise, right? So maybe you have a very approximate model of the mechanics to begin with, and as you gain expertise, you get a more refined version of that model. You're aware of muscles or balance components that you just weren't even aware of before. So how do you scaffold that?
Yeah, plus the fear of injury, the ambition of goals, of excelling, and fear of mortality. Let's see, what else is in there as the motivations? Overinflated ego in the beginning, and then a crash of confidence in the middle. All of those seem to be essential for the learning process.
And if all that's good, then you're probably optimizing energy efficiency.
Yeah, right. So we have to get that right. There was this idea that you would have robots play soccer better than human players by 2050. That was the goal. Was the goal to beat world champion team, to become a World Cup, beat like a World Cup level team. So are we going to see that first, or a robot? If you're familiar, there's an organization called UFC for mixed martial arts. Are we going to see a World Cup championship soccer team that are robots, or a UFC champion mixed martial artist that's a robot?
It's very hard to say one thing is some problem is harder than the other. What probably matters is who started the organization that I think RoboCup has a pretty serious following, and there is a history now of people playing that game, learning about that game, building robots to play that game, building increasingly more human robots. It's got momentum. And so if you want to have mixed martial arts compete, you better start your organization now, right? I think almost independent of which problem is technically harder, because they're both hard and they're both different.
That's a good point. Those videos are just hilarious. That especially the humanoid robots trying to play soccer. They're kind of terrible right now.
I guess there is Robo Sumo wrestling. There's like the Robo One competitions where they do have these robots that go on a table and basically fight. So maybe I'm wrong. Maybe.
First of all, do you have a year in mind for RoboCup, just from a robotics perspective? Seems like a super exciting possibility that, in the physical space, this is what's interesting. I think the world is captivated. I think it's really exciting. It inspires just a huge number of people when a machine beats a human at a game that humans are really damn good at. So you're talking about chess and Go, but that's in the world of digital. I don't think machines have beat humans at a game in the physical space yet, but that would be just.
You have to make the rules very carefully, right? If Atlas kicked me in the shins, I'm down, and and game over. So there's, it's very subtle on
I think
what's fair.
I think the fighting one is a weird one, because you're talking about a machine that's much stronger than you. But in terms of soccer, basketball, all those kinds
even
of
soccer, right? As soon as there's contact or whatever, and there are some things that the robot will do better. I think if you really set yourself up to try to see, could robots win the game of soccer as the rules were written, the right thing for the robot to do is to play very differently than a human would play. You're not going to get, the perfect soccer player robot. You're going to get something that exploits the rules, exploits its super actuators, its super low bandwidth, feedback loops or whatever, and it's going to play the game differently than you want it to play.
Yeah.
I bet there's loopholes, right? We saw that in the DARPA challenge, that it's very hard to write a set of rules that someone can't find a way to exploit.
What is the most amazing or beautiful robot that you've ever had the chance to work with?
I think it was Domo, which was made by one of my grad students, Aaron Edsinger. It now sits in Daniela Russo's office, director of CSAIL. And it was just a beautiful robot. And Aaron was really clever. He didn't give me a budget ahead of time. He didn't tell me what he was going to do. He just started spending money. He spent a lot of money.
Yeah.
He and Jeff Weber, who was a mechanical engineer who Aaron insisted he bring with him when he became a grad student, built this beautiful, gorgeous robot, Domo, which is a upper torso humanoid, two arms,
with fingers,
three-fingered hands, and face, eyeballs, all not the eyeballs, but everything else. Series elastic actuators. You can interact with it. Cable driven. All the motors are inside, and it's just gorgeous.
The eyeballs are actuated too, or no?
Oh yeah, the eyeballs are actuated with cameras, and so it had a visual attention mechanism.
Wow,
looking when people came in and looking in their face and talking with them.
Yeah. Wow, was it amazing?
The beauty of it. You said what was the most beautiful?
Beauty. What is the most beautiful?
It's just mechanically gorgeous. As everything Aaron builds has always been mechanically gorgeous. It's just exquisite in the detail.
Are we talking about mechanically, like literally the amount of actuators? The
actuators, the cables. He anodizes different parts, different colors, and it just looks like a work of art.
What about the face? Do you find the face beautiful in robots?
When you make a robot, it's making a promise for how well it will be able to interact. So I always encourage my students not to overpromise.
Even with its essence, like the thing it presents, it should not overpromise.
Yeah. So the joke I make, which I think you'll get, is if your robot looks like Albert Einstein, it should be as smart as Albert Einstein. Yeah. So the only thing in Domo's face is the eyeballs, and because that's all it can do. It can look at you and pay attention, and so there is no. It's not like one of those Japanese robots that looks exactly like a person at all.
But see, the thing is, us humans and dogs too don't just use eyes as attentional mechanisms. They also use it to communicate as part of the communication. Like a dog can look at you, look at another thing, and look back at you, and that designates that we're going to be looking at that thing together.
Or intent. Intent. On both Baxter and Sawyer at Rethink Robotics, they had a screen with, graphic eyes, so it wasn't actually where the cameras were pointing, but the eyes would look in the direction it was about to move its arm, so people in the factory nearby were not surprised by its motions because it gave that intent away.
Before we talk about Baxter, which I think is a beautiful robot, let's go back to the beginning. When did you first fall in love with robotics? We're talking about beauty and love to open the conversation. This is great.
I've got these. I was born in the end of 1954, and I grew up in Adelaide, South Australia. And I have these two books that are dated 1961. So I'm guessing my mother found them in a store in 62 or 63. How and Why Wonder books. How and Why Wonder book of electricity, and a How and Why Wonder book of giant brains and robots. And I learned how to build circuits, when I was 8 or 9, simple circuits, and I read, learned the binary system and saw all these drawings mostly of robots, and then I tried to build them for the rest of my childhood.
Wait, 61 you said?
This was when the two books. I've still got them at home.
What does the robot mean in that context?
No, they were some of the robots that they had were arms, big arms to move nuclear material around, but they had pictures of welding robots that looked like humans under the sea, welding stuff underwater. So they weren't real robots, but they were, what people were thinking about for robots.
What were you thinking about? Were you thinking about humanoids? Were you thinking about arms with fingers? Were you thinking about faces or cars?
No, actually, to be honest, I realized my limitation on building mechanical stuff. So I just built the brains mostly. I out of different technologies as I got older. I built a learning system which was chemical based, and I had this ice cube tray. Each well was a cell, and by applying voltage to the two electrodes, it would build up a copper bridge. So over time, it would learn a simple network, so I could teach it stuff. And that was mostly things were driven by my budget, and nails as electrodes and a ice cube tray was about my budget at that stage. Later, I managed to buy transistors, and then I could build gates and flip-flops and stuff.
So one of your first robots was an ice cube tray.
Yeah. And it was very cerebral because it learned to add.
Okay. Very nice. Well, just a decade or so before, in 1950, Alan Turing wrote the paper that formulated the Turing test. And he opened that paper with the question, can machines think? So let me ask you this question. Can machines think? Can your ice cube tray one day think?
Certainly machines can think, because I believe you're a machine and I'm a machine, and I believe we both think. I think
Speak for yourself.
I think any other philosophical position is sort of a little ludicrous. What does think mean if it's not something that we do? And we are machines. So yes, machines can, but do we have a clue how to build such machines? That's a very different question. Are we capable of building such machines? Are we smart enough? We think we're smart enough to do anything, but maybe we're not. Maybe, we're just not smart enough to build stuff like us.
The kind of computer that Alan Turing was thinking about, do you think there is something fundamentally or significantly different between between our ears, the biological computer that humans use, and the computer that he was thinking about from a sort of high level philosophical?
Yeah, I believe that it's very wrong. In fact, I'm halfway through I think it'll be about a 480 page book titled, the working title is Not Even Wrong. And if I may, I'll tell you a bit about that book. Please. So there's three thrusts to it. One is the history of computation, what we call computation. Mm-hmm. It goes all the way back to some manuscripts in Latin from 1614 and 1620 by Napier and Kepler, through Babbage and Lovelace. And then Turing's 1936 paper is what we think of as the invention of modern computation. And that paper, by the way, did not set out to, invent computation. It set out to negatively answer one of Hilbert's three later set of problems. He called it an effective way of getting answers. And Hilbert really worked with rewriting rules, as did Church, who also, at the same time, a month earlier than Turing, disproved Hilbert's one of these three hypotheses. The other two had already been disproved by Gödel. So Turing set out to disprove it, because it's always easier to disprove these things than to prove that there is an answer. And so he needed, and it really came from his professor while he was an undergrad at Cambridge, who turned it into, is there a mechanical process? So he wanted to show a mechanical process that could calculate numbers, because that was a mechanical process that people used to generate tables. They were called computers, the people at the time. Mm-hmm. And they followed a set of rules where they had paper and they would write numbers down, and based on the numbers, they'd keep writing other numbers. And they would produce numbers for these tables, engineering tables, that the more iterations they did, the more significant digits came out. And so Turing in that paper set out to define what sort of machine could do that, mechanical machine, where it could produce an arbitrary number of digits in the same way a human computer did. And he came up with a very simple set of constraints where there was an infinite supply of paper, the tape of the Turing machine, and each Turing machine had came with a set of instructions that, as a person could do with pencil and paper, write down things on the tape and erase them and put new things there. And he was able to show that that system was not able to do something that Hilbert had hypothesized. So he disproved it. But he had to show that this system was good enough to do whatever could be done, but couldn't do this other thing.
Yeah.
And there he said, and he says in the paper, I don't have any real arguments for this, but based on intuition. So that's how he defined computation. And then if you look over the next, from 1936 up until really around 1975, you see people struggling with, is this really what computation is? Mm-hmm. And so Marvin Minsky, very well known in AI, but also a fantastic mathematician, in his book, Finite and Infinite Machines from the mid-60s, which is a beautiful, beautiful mathematical book, says at the start of the book, well, what is computation? Turing says it's this, and yeah, I sort of think it's that. It doesn't really matter whether the stuff's made of wood or plastic. It's just, that relatively cheap stuff can do this stuff. And so, yeah, it seems like computation. And Donald Knuth, in his first volume of his, Art of Computer Programming in around 1968, says, well, what's computation? It's this stuff, like Turing says, that a person could do each step without too much trouble. And so one of his examples of what would be too much trouble was a step which required knowing whether Fermat's last theorem was true or not, because it was not known at the time. And that's too much trouble for a person to do as a step. And Hopcroft and Ullman sort of said a similar thing later that year. And by 1975, in the Aho Hopcroft and Ullman book, they're saying, well, we don't really know what computation is, but intuition says this is sort of about right, and this is what it is. That's computation. It's a sort of agreed upon thing which happens to be really easy to implement in silicon. And then we had Moore's law, which took off, and it's been an incredibly powerful tool. Mm-hmm. I certainly wouldn't argue with that. The version we have of computation, incredibly powerful.
Can we just take a pause? So what we're talking about is there's an infinite tape with some simple rules of how to write and on that tape, and that's what we're kind of thinking about. This is computation.
Yeah, and it's modeled after humans, how humans do stuff. And I think it's Turing says in the 36 paper, one of the critical facts here is that a human has a limited amount of memory. Mm-hmm. So that's what we're going to put onto our mechanical computers. Mm-hmm. So unlike mass or charge or it's not given by the universe. This is what we're going to call computation.
Yeah.
And then it has this really it had this really good implementation which has completely changed our technological world. That's computation. Second part of the book, or argument in the book, I have this 2x2 matrix with science in the top row, engineering in the bottom row. Left column is intelligence, right column is life. Mm-hmm. So in the bottom row, the engineering, there's artificial intelligence and there's artificial life. Mm-hmm. In the top row, there's neuroscience and abiogenesis. How does living matter how does non-living matter become living matter?
Yes.
4 disciplines. These 4 disciplines all came into the current form in the period 1945 to 1965.
That's interesting.
There was neuroscience before, but it wasn't effective neuroscience. It was, there are these ganglia and there's electrical charges, but no one knows what to do with it. And furthermore, there were a lot of players who are common across them. I've identified common players except for artificial intelligence and abiogenesis. I don't have, but for any other pair, I can point to people who worked in them. And a whole bunch of them, by the way, were at the Research Lab for Electronics at MIT, where Warren McCulloch held forth. And in fact, McCulloch, Pitts, Littman, and Maturana wrote the first paper on functional neuroscience called What the Frog's Eye Tells the Frog's Brain, where instead of it just being this bunch of nerves, they sort of showed what different anatomical components were doing and telling other anatomical components and, generating behavior in the frog.
Would you put them as basically the fathers or one of the early pioneers of what are now called artificial neural networks?
Yeah, I mean, McCulloch and Pitts. Pitts was much younger than him. In 1943, had written a paper inspired by Bertrand Russell on a calculus for the ideas immanent in neural systems, where they had tried to, without any real proof, they had tried to give a formalism for neurons, basically in terms of logic, and gates, or gates, and not gates, with no real evidence that was what was going on, but they talked about it, and that was picked up by Minsky for his 1953 dissertation on which was a neural network, we would call it today. It was picked up by John von Neumann when he was designing the EDVAC computer in 1945. He talked about its components being neurons, based on, and in references. He's only got 3 references, and one of them is the McCulloch-Pitts paper. So all these people, and then the AI people and the artificial life people, which was John von Neumann originally.
There's like overlap between all of them.
They're all going around at the same time. And 3 of these 4 disciplines turned to computation as their primary metaphor. So I've got a couple of chapters in the book. One is titled, Wait, Computers Are People? Because that's where our computers came from.
Yeah.
From people who were computing stuff. And then I've got another chapter, Wait, People Are Computers? Which is about computational neuroscience.
Yes.
So there's this whole circle here. And that computation is it. And, I have talked to people about, well, maybe it's not computation that goes on in the head. Of course it is.
Yeah.
Okay, well, when Elon Musk's rocket goes up, is it computing? Is that how it gets into orbit? By computing? But we've got this idea, if you want to build an AI system, you write a computer program.
Yeah, in the sense, so the word computation very quickly starts doing a lot of work that it was not initially intended to do. It's the second of saying, if you talk about the universe as essentially performing a computation.
Yeah, right. Wolfram does this. He turns it into computation. You don't turn rockets into computation.
Yeah. By the way, when you say computation in our conversation, do you tend to think of computation narrowly in the way Turing thought of computation?
It's gotten very squishy.
Yeah,
squishy.
Okay.
Over time. But computation in the way Turing thinks about it and the way most people think about it actually fits very well with thinking like a hunter-gatherer. There are places, and there can be stuff in places, and the stuff in places can change, and it stays there until someone changes it. And it's this metaphor of place and container, which, is a combination of our place cells in our hippocampus and our cortex. But this is how we use metaphors for mostly to think about. And when we get outside of our metaphor range, we have to invent tools which we can sort of switch on to use. So calculus is an example of a tool. It can do stuff that our raw reasoning can't do, and we've got conventions of when you can use it or not. But sometimes, people try to, all the time, we always try to get physical metaphors for things, which is why quantum mechanics has been such a problem for 100 years, because it's a particle. No, it's a wave. It's got to be something we understand. And I say, no, it's some weird mathematical object that's different from those, but we want that metaphor. Well, I suspect that 100 years or 200 years from now, neither quantum mechanics nor dark matter will be talked about in the same terms, in the same way that phlogiston's theory eventually went away because it just wasn't an adequate explanatory metaphor. That metaphor was the stuff. There is stuff in the burning. The burning is in the matter. Whereas it turns out the burning was outside the matter. It was the oxygen.
So our desire for metaphor and combined with our limited cognitive capabilities gets us into trouble.
That's my argument in this book. Now, and people say, well, what is it then? And I say, well, I wish I knew that. I'd write a book about that. But I give some ideas. But so there's the three things. Computation is sort of a particular thing we use. Can I tell you one beautiful thing? Yes, thing I've done. Please. So, I used an example of a thing that's different from computation. You hit a drum and it vibrates, and there are some stationary points on the drum surface, because the waves are going up and down, the stationary points. Now, you could compute them to arbitrary precision, but the drum just knows them. The drum doesn't have to compute. What was the very first computer program ever written by Ada Lovelace? Mm-hmm. To compute Bernoulli numbers. And Bernoulli numbers are exactly what you need to find those stable points in the drum surface.
Wow.
Anyway, and there was a bug in her program. The arguments to divide were reversed in one place.
And it still worked.
Well, no, she never got to run it. They never built the analytical engine. She wrote the program without a,
So computation is
sort of, a thing that's become dominant as a metaphor, but is it the right metaphor? All three of these four fields adopted computation, and a lot of it swirls around Warren McCulloch and all his students, and he funded a lot of people, and our human metaphors, our limitations to human thinking, all play into this. They're the three themes of the book. So I have a little to say about computation.
So you co-founded iRobot, as we mentioned, one of the most successful robotics companies ever. What are you most proud of with that company and the approach you took to robotics?
Well, there's something I'm quite proud of there, which may be a surprise. But I was still on the board when this happened. It was March 2011. And we sent robots to Japan, and they were used to help shut down the Fukushima Daiichi nuclear power plant, which was everything was. I've been there since. I was there in 2014. And the robots, some of the robots were still there. I was proud that we were able to do that. Why were we able to do that? And people have said, well, Japan is so good at robotics. It was because we had about 6,500 robots deployed in Iraq and Afghanistan, teleopt, but with intelligence, dealing with roadside bombs. So we had, I think it was at that time, 9 years of in-field experience with the robots in harsh conditions. Whereas the Japanese robots, which were, this goes back to what annoys me so much, getting all the hype. Look at that. Yeah. Look at that Honda robot. It can walk. Wow, the future's here. Couldn't do a thing because they weren't deployed, but we had deployed in really harsh conditions for a long time. And so we're able to do something very positive in a very bad situation.
What about just the simple, and for people who don't know, one of the things that iRobot has created is the Roomba vacuum cleaner. What about the simple robot that is the Roomba, quote unquote simple, that's deployed in tens of millions of homes? What do you think about that?
Well, I make the joke that I started out life as a pure mathematician and turned into a vacuum cleaner salesman. So if you're going to be an entrepreneur, be ready to do anything. But I was, there was a wacky lawsuit that I got deposed for not too many years ago, and I was the only one who had email from the 1990s, and no one in the company had it. So I went through my email, and it reminded me of the joy of what we were doing, and what was I doing? what was I doing at the time we were building the Roomba? One of the things was we had this incredibly tight budget because we wanted to put it on the shelves at $200. There was another home cleaning robot at the time. It was the Electrolux Trilobite, which sold for €2,000. And to us, that was not going to be a consumer product. Mm-hmm. So we had reason to believe that $200 was a thing that people would buy at. That was our aim. But that meant we had, that's on the shelf making profit. Mm-hmm. That means the cost of goods has to be minimal. So I find all these emails of me going, I'd be in Taipei for a MIT meeting, and I'd stay a few extra days. I'd go down to Hsinchu and talk to these little tiny companies, lots of little tiny companies outside of TSMC, Taiwan Semiconductor Manufacturing Corporation, which let all these little companies be fabless. They didn't have to have their own fab, so they could innovate. And they were building, their innovations were to build stripped down 6802s. 6802 was what was in an Apple I. Get rid of half the silicon and still have it be viable. And I'd previously got some of those for some earlier failed products of iRobot. And that was in Hong Kong, going to all these companies that built, they weren't gaming in the current sense. There were these handheld games that you would play. Mm-hmm. Or birthday cards, because we had about a 50-cent budget for computation. So I'm trekking from place to place, looking at their chips, looking at what they'd removed. Yeah. Their interrupt handling is too weak for a general purpose. So I was going deep technical detail. And then I found this one from a company called Winbond, which had, and I'd forgotten it had this much RAM. It had 512 bytes of RAM, and it was in our budget, and it had all the capabilities we needed.
Yeah.
So,
and you were excited.
Yeah, and I was reading all these emails. Colin, I found this. So,
did you ever think that you guys could be so successful? Like eventually, this company would be so successful. Could you possibly have imagined?
No, we never did think that. We had 14 failed business models up till 2002, and then we had 2 winners the same year. No, and then I remember the board, because by this time we had some venture capital in. The board went along with us building some robots for aiming at the Christmas 2002. Mm-hmm. market, and we went 3 times over what they authorized and built 70,000 of them and sold them all in that first, because we released on September 18th, and they were all sold by Christmas. So it was so we were gutsy, but
but yeah, you didn't think this will take over the world. Well, this is so a lot of amazing robotics companies have gone under over the past few decades. Why do you think it's so damn hard to run a successful robotics company?
There's a few things. One is expectations of capabilities by the founders that are off base.
The founders, not the consumer, the founders.
Yeah, expectations of what can be delivered.
Sure.
Mispricing, and what a customer thinks is a valid price is not rational necessarily.
Yeah.
And expectations of customers. And just the sheer hardness of getting people to adopt a new technology. And I've suffered from all 3 of these. I've had more failures than successes. In terms of companies, I've suffered from all 3. So,
do you think one day there will be a robotics company, and by robotics company I mean where your primary source of income is from robots, that will be a $1 trillion+ company? And if so, what would that company do?
I can't, because I'm still starting robot companies.
Yeah.
I'm not making any such predictions in my own mind. I'm not thinking about $1 trillion company. And by the way, I don't think, in the 90s, anyone was thinking that Apple would ever be $1 trillion company. So these are very hard to predict.
But sorry to interrupt, but don't you, because I kind of have a vision in a small way, a big vision in a small way, that I see that there would be robots in the home at scale, like Roomba, but more, and that's $1 trillion.
Right, and I think there's a real market pull for them because of the demographic inversion. Who's going to do all the stuff for the older people? Mm-hmm. There's too many. I'm leading here. There's going to be too many of us, and but we don't have capable enough robots to make that economic argument at this point. Do I expect that will happen? Yes, I expect it will happen. But I got to tell you, we introduced the Roomba in 2002, and I stayed another 9 years. We were always trying to find what the next home robot would be, and still today, the primary product of 20 years later, almost 20 years later, 19 years later, the primary product is still the Roomba. So iRobot hasn't found the next one.
Do you think it's possible for one person in the garage to build it versus like Google launching Google self-driving car that turns into Waymo? Do you think it's this is almost like what it takes to build a successful robotics company? Do you think it's possible to go from the ground up, or is it just too much capital investment?
Yeah, so it's very hard to get there without a lot of capital. And we're starting to see, fair chunks of capital for some robotics companies. Series B's, I just saw one yesterday for $80 million, I think it was, for Covariant. But it can take real money to get into these things, and you may fail along the way. I've certainly failed at Rethink Robotics, and we lost $150 million in capital there.
So Rethink Robotics is another amazing robotics company you co-founded. So what was the vision there? What was the dream? And what are you most proud of with Rethink Robotics?
I'm most proud of the fact that we got robots out of the cage in factories that was safe, absolutely safe for people and robots to be next to each other.
So these are robotic arms.
Robotic arms.
They're able to pick up stuff and interact with humans.
Yeah, and that the humans could retask them without writing code.
Right.
And now that's sort of become an expectation for a lot of other little companies and big companies are advertising they're doing.
That's both an interface problem and also a safety problem.
Yeah. So I'm most proud of that. I let myself be talked out of what I wanted to do. And, you've always got, I can't replay the tape. I can't replay it. Maybe if I'd been stronger and I remember the day, I remember the exact meeting.
Can you take me through that meeting?
Yeah. So I'd set as a target for the company that we were going to build $3,000 robots with force feedback that were safe for people to be around.
Wow.
That was my goal. And we built, so we started in 2008, and we had prototypes built of plastic gearboxes, mm-hmm. and at a $3,000, lifetime, or $3,000, I was saying we're going to go after not the people who already have robot arms in factories, the people who would never have a robot arm. We're going to go after a different market, so we don't have to meet their expectations. Mm-hmm. And so we're going to build it out of plastic. It doesn't have to have a 35,000 hour lifetime. It's going to be so cheap that it's OPEX, not CAPEX. Mm-hmm. And so we had a prototype that worked reasonably well, but the control engineers were complaining about these plastic gearboxes with a beautiful little planetary gearbox that we could use something called series elastic actuators. We embedded them in there. We could measure forces. We knew when we hit something, etc. the control engineers were saying, yeah, but there's this torque ripple, because these plastic gears, they're not great gears, and there's this ripple, and trying to do force control around this ripple is so hard. And I'm not going to name names, but I remember one of the mechanical engineers saying, we'll just build a metal gearbox with spur gears, and it'll take 6 weeks, we'll be done, problem solved. 2 years later, we got the spur gearbox working.
Yeah.
We cost reduced it every possible way we could. But now the price went up to, and then the CEO at the time said, well, we have to have 2 arms, not 1 arm. So our first robot product, Baxter, now costs $25,000. And the only people who were going to look at that were people who had arms in factories, because that was somewhat cheaper for 2 arms than arms in factories. But they were used to 0.1 millimeter reproducibility of motion and certain velocities. And I kept saying, but that's not what we're giving you. You don't need position repeatability. You use force control like a human does. No, but we want that repeatability. We want that repeatability. All the other robots have that repeatability. Why don't you have that repeatability?
So can you clarify? Force controls, you can grab the arm and you can move it.
Well, you can move it around. But suppose you can you see that?
Yes.
Suppose you want to.
Yes.
Suppose this thing is a precise thing that's got to fit here in this right angle.
Yeah.
Under position control, you have fixtured where this is. You know where this is precisely, and you just move it. And it goes there. In force control, you would do something like slide it over here till we feel that, and slide it in there.
Gotcha.
And that's how a human gets precision.
Yeah.
They use force feedback.
Yes.
And get the things to mate rather than just go straight to it.
Yeah.
Couldn't convince our customers who were in factories and were used to thinking about things a certain way. And they wanted it. So then we said, okay, we're going to build an arm that gives you that. So now we ended up building a $35,000 robot with 1 arm with, what are they called? A certain sort of gearbox made by a company whose name I can't remember right now, but it's the name of the gearbox. But it's got torque ripple in it. So now there was an extra 2 years of solving the problem of doing the force with the torque ripple. So we had to do the thing we had avoided. And for the plastic gearboxes, we ended up having to do. The robot was now overpriced, and
that was your intuition from the very beginning, kind of that this is you're opening a door to solve a lot of problems that you're eventually going to have to solve this problem anyway.
Yeah, and also I was aiming at a low price to go into a different market.
Low price
that didn't have
$3,000 would be amazing.
Yeah, I think we could have done it for $5,000. But you talked about setting the goal a little too far for the engineers.
Yeah, exactly. So why would you say that company not failed but went under?
We had buyers, and there's this thing called the Committee on Foreign Investment in the U.S., CFIUS, and that had previously been invoked twice around where the government could stop foreign money coming into a U.S. company based on defense requirements. We went through due diligence multiple times. We were going to get acquired, but every consortium had Chinese money in it. And all the bankers would say at the last minute, this isn't going to get past CFIUS. And the investors would go away. And then we had 2 buyers. Once we were about to run out of money, 2 buyers. And one used heavy-handed legal stuff with the other one. Said they were going to take it and pay more. Dropped out when we were out of cash, and then bought the assets at 1/30th of the price they had offered a week before. It was a tough week.
Does it hurt to think about like an amazing company that didn't, like iRobot didn't find a way?
Yeah, it was tough. I said I was never going to start another company. I was pleased that everyone liked what we did so much that the team was hired by 3 companies within a week. Everyone had a job in one of these 3 companies. Some stayed in their same desks because another company came in and rented the space. So I felt good about people not being out on the street.
So Baxter has a screen with a face. That's a revolutionary idea for a robot manipulation, like for a robotic arm. How much opposition did you get?
Well, first, the screen was also used during codeless programming, where you taught by demonstration. It showed you what its understanding of the task was. So it had 2 roles. Some customers hated it, and so we made it so that when the robot was running, it could be showing graphs of what was happening and not show the eyes. Other people, and some of them surprised me who they were saying, well, this one doesn't look as human as the old one. We like the human looking.
Yeah.
So there was a mixed bag there.
But do you think that's, I don't know, I'm kind of disappointed whenever I talk to roboticists, like the best robotics people in the world. They seem to not want to do the eyes type of thing. Like they seem to see it as a machine as opposed to a machine that can also have a human connection. I'm not sure what to do with that. It seems like a lost opportunity. I think the $1 trillion company will have to do the human connection very well, no matter what it does.
Yeah, I agree.
Can I ask you a ridiculous question?
Sure. I might give a ridiculous answer.
Do you think, maybe by way of asking the question, let me first mention that you're kind of critical of the idea of the Turing test as a test of intelligence. Let me first ask this question. Do you think we'll be able to build an AI system that humans fall in love with and it falls in love with the human? Like romantic love?
Well, we've had that with humans falling in love with cars, even back in the 50s.
It's a different love, right?
Well,
I think there's a lifelong partnership where you can communicate and grow. Like,
I think we're a long way from that. I think we're a long way. I think Blade Runner was, had the time scale totally wrong.
Yeah, but to me, honestly, the most difficult part is the thing that you said with the Marvex paradox is to create a human form that interacts and perceives the world. But if we just look at a voice, like the movie Her, or just like an Alexa type voice, I tend to think we're not that far away.
Well, for some people, maybe not. But as humans, as we think about the future, we always try to, and this is the premise of most science fiction movies. You've got the world just as is today, and you change one thing, right? But that's not how. And it's the same with the self-driving car. You change one thing. Yeah. No, everything changes.
Yes,
everything grows together. So surprisingly, it might be surprising to you, it might not. I think the best movie about this stuff was Bicentennial Man. And what was happening there? It was schmaltzy but what was happening there? As the robot was trying to become more human, the humans were adopting the technology of the robot and changing their bodies.
Yeah.
So there was a convergence happening in a sense. So we will not be the same. We're already talking about genetically modifying our babies. There's more and more stuff happening around that. We will want to modify ourselves even more for all sorts of things. We put all sorts of technology in our bodies to improve it. I've got things in my ears so that I can sort of hear you.
Yeah.
So we're always modifying our bodies. So I think it's hard to imagine exactly what it will be like in the future.
But on the Turing test side, do you think, so forget about love for a second. Let's talk about just like the Alexa Prize. Actually, I was invited to be interviewer for the Alexa Prize or whatever. That's in 2 days. Their idea is success looks like a person wanting to talk to an AI system for a prolonged period of time, like 20 minutes. how far away are we, and why is it difficult to build an AI system with which you'd want to have a beer and talk for an hour or 2 hours, like not to check the weather or to check music, but just like to talk as friends.
Yeah, well, we saw Weizenbaum back in the 60s with his program Eliza, being shocked at how much people would talk to Eliza. And I remember, in the 70s typing, stuff to Eliza to see what it would come back with. I think right now, and this is a thing that Amazon's been trying to improve with Alexa. There is no continuity of topic. There's not. You can't refer to what we talked about yesterday. Mm-hmm. It's not the same as talking to a person where there seems to be an ongoing existence, which changes.
We share moments together and they last in our memory together.
Yeah, and there's none of that. And there's no sort of intention of these systems that they have any goal in life, even if it's to be happy. They don't even have a semblance of that. Now, I'm not saying this can't be done. I'm just saying I think this is why we don't feel that way about them, or that's a sort of a minimal requirement. If you want the sort of interaction you're talking about, it's a minimal requirement. Whether it's going to be sufficient, I don't know. We haven't seen it yet. We don't know what it feels like. But
I tend to think it's not as difficult as solving intelligence, for example, and I think it's achievable in the near term. But on the Turing test, why don't you think the Turing test is a good test of intelligence?
Oh, because again, the Turing, if you read the paper, Turing wasn't saying this is a good test. He was using it as a rhetorical device to argue that if you can't tell the difference between a computer and a person, you must say that the computer's thinking, because you can't tell the difference, then it's thinking. You can't say something different. What it has become as this sort of weird game of fooling people. Yeah. So back at the AI lab in the late 80s, we had this thing that still goes on called the AI Olympics. And one of the events we had one year was the original imitation game, as Turing talked about, because he starts by saying, can you tell whether it's a man or a woman? Mm-hmm. So we did that at the lab. We had, you'd go and type and the thing would come back and you had to tell whether it was a man or a woman. One man came up with a question that he could ask, which was always a dead giveaway of whether the other person was really a man or a woman. What he would ask them: did you have green plastic toy soldiers as a kid? Yeah. What do you do with them? And a woman trying to be a man would say, "Oh, I lined them up. We had wars, we had battles." Yeah. And the man, just being a man, would say, "I stomped on them. I burnt them." So that's what the Turing test with computers has become. What's the trick question? That's why I say
that's right.
It's sort of devolved into this weirdness.
Right. Nevertheless, conversation not formulated as a test is a fascinatingly challenging dance. It's a really hard problem. To me, conversation, when non-posed as a test, is a more intuitive illustration how far away we are from solving intelligence than like computer vision. It's hard. Computer vision is harder for me to pull apart, but with language, with conversation, you could see.
Because language is so human.
It's so human. We can so clearly see it. Shit, you mentioned something I was going to go off on. Okay. All right. What are your thoughts about, since I'm a robotics person, I'd be curious to see, like, what do you think about the space at all? About, first of all, autonomous vehicles with Tesla Autopilot and Waymo self-driving car. I'm not sure if you're familiar with all the autonomous vehicles and so on.
Yeah.
So those are robots on wheels. And then there's also legged robots. So next time you're in Austin, you get to meet some of the legged robots I've been working on. And I find those kind of a fascinating way to explore the nature of intelligence in our computers, but also explore our own intelligence and also explore our own like what makes us connect to other living beings, whether it's dogs, cats, or other humans. Like there's some magic there that's beyond just intelligence. And I like when I have the robot dog, there's some aspect to it that, I don't know, brings me joy in a way that a dog does, in a way that a good friend does. Yeah.
That's interesting.
And I'm not sure if that's some kind of anthropomorphism, like where I'm projecting my hopes for this, what this thing is, but
maybe a little of that.
But it's kind of built in. I mean, it's just a source of joy. Maybe it's connected to the fact that there's just like a loneliness within all of us, within me, and it's just nice to have other things in your life that move, that recognize you, that kind of thing. I mean, I suppose it's nice to even just have a plant.
Yeah, it is. Plant goes a long way. You see a guy with plants in his apartment, it changes the apartment because they're alive. You got to water them. You got to put sun on them. So yeah, I think there's something there, and I think you can see people's reactions when you show them advanced technology, like these dog robots or these robots that dance and shit. People are like, "What the fuck?" Like it hits home in some way, whether it's fear or you want to fuck them, clearly, whatever it is. But it does connect with you in some way. So. I'm with you. And I think, this is why I don't think robots will take over. You always hear that, robot, they're making them too advanced, they're going to wipe us out, blah, blah, blah. If robots get at human emotions, that is scary because they could get mad at us and kill us, and they're stronger, and they don't need sleep, they don't need food, they don't need water, they don't get jealous, they don't, but if they have emotions, then I think we can dominate them. Because who knows emotions better than us? We've got thousands of years of evolutionary emotional bullshit. We can go, hey, robot, I heard your wife fucked that Black & Decker, huh? They're going to crumble. We can bully them.
Emotionally manipulate robots?
Yes, that's when we'll win. Right now, they could kill us. They could just, we'd all die. Then we shoot them back. Bing, 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 bing. That's no good. But if they do get emotions, then we can go, hey, you look like hell. What is that, a rusty bolt? Hey, you're dropping some oil there, you loser. I think we can win if they do get emotions.
So this goes back to your father being able to undercut you with a single word.
You're right.
Yeah. So we're the creators of the robots, and then the robots will just you'll say the exact thing.
Yeah.
Where the robot would be like, that son of a bitch.
Yeah.
And then he goes back to his hole and just sits there miserable.
Right, yeah, hardware looks more like software to me. You can't get it up. Yada, yada, yada.
Yeah.
So you mentioned to go back to Swarm.
Yeah.
So that was interesting to you, first of all, in your own work, but also I believe you said something that was inspiring from Neil Stephenson as well. So when you say Swarm, are you thinking about architectures, or are you thinking about artificial intelligence like robotics, or are those kind of intermixed?
I think the future that we're seeing is that they're going to be intermixed, which is really exciting. So the future of space habitats are one of intelligent structures, maybe not all the way to how. And the 2001 Space Odyssey reference that scares people about the habitat having a mind of its own. But certainly we're building systems now where the habitat has sensing technology that allows it to communicate its basic functions, maintaining life support for the astronauts, but could also communicate in symbiosis with these swarm robots that would be on the outside of the spacecraft, whether it's in a microgravity orbiting environment or on the surface. And these little robots, they crawl, just a la Neil Stephenson and Seven Eves, they crawl along the outside of the spacecraft looking for micrometeorite punctures or gas leaks or other faults and defects. And right now, we're just working on the diagnosis. So can the swarm, with its collective intelligence, act in symbiosis with the spacecraft and detect things? But in the future, we'd also love for these little micro robots to repair in situ and really be like ants living in a tree, all together connected to the spacecraft.
Do you envision the system to be fully distributed, and just like an ant colony, if one of them is damaged or, whatever, loses control and all those kinds of things, that doesn't affect the performance of the complete system, or does it need to be centralized? This is more like almost like a technical question. Do you think
good architecture question?
Right. From the ground up, it's so scary to go fully distributed.
Yes.
But it's also exceptionally powerful, right? Robust, resilient to the harsh conditions of space. Where do you, if you look into the next 10, 20, 100 years, starting from scratch, do you think we should be doing architecture-wise distributed systems?
For space, yes, because it gives you this redundancy and safety profile that's really critical. So whether it's small swarm robots where it doesn't matter if you lose a few of them, to habitats that instead of having a central monolithic habitat, you might actually be able to have a decentralized node of a space station, so that you can, kind of right out of Star Wars, you can shut a blast door if there's a fire or if there's a conflict in a certain area, and you can move the humans and the crew into another decentralized node of the spacecraft. There's another idea out of Neil Stephenson's Seven Eves, actually, where these arklets, which were decentralized spacecraft that could form and dock little temporary space stations with each other, and then separate and go off on their way and have a decentralized approach to living in space.
So the self-assembly component of that too. So this is your PhD work and beyond. You explored autonomously self-assembling space architecture for future space tourist habitats and space stations in orbit around Earth, Moon, and Mars. There's few things I personally find sexier than self-assembling autonomously self-assembling space architecture. In general, it doesn't even need to be space. The idea of like self-assembling architectures is really interesting, like building a bridge or something like that through self-assembling materials. It feels like an incredibly efficient way to do it because optimization is built in. So you can build like the most optimal structures given dynamic, uncertain, changing conditions.
Mm-hmm.
So maybe can you talk about your PhD work, about this work about tesserae? What is it in general? Any cool stuff, because this is super cool.
Yeah, absolutely. So tesserae is my PhD research. It's this idea that we could take tiles that construct a large structure like a buckyball. Yeah, this is exactly what we're looking at here, which is the tiles that are packed flat in a rocket. They're released to float in microgravity. Magnets, pretty powerful electropermanent magnets on their edges, draw them together for autonomous docking. So there's no human in the loop here, and there's no central agent coordinating, saying tile 1, go to tile 2. It's completely decentralized system. They find each other on their own. What we don't show in this video is what happens if there's an error, right? So what happens if they bond incorrectly? The tiles have sensing, so proximity sensing, magnetometer, other sensors that allow them to detect a good bond versus a bad bond and pulse off and self-correct, which anybody who works in this, the field of self-assembly will tell you that error detection and correction, just like error detection in a DNA sequence or protein folding, is really important part of the system for that robustness. And so we've done a lot of work to engineer that ability for the tiles to be self-determining. They know whether they're forming the structure that they're supposed to form or not.
They know if they're in a toxic relationship and they need to get out.
Right. If they need to separate, exactly. Yeah.
All right. This is like so amazing. And for people who are just listening to this, there's a lot. I mean, how large are these tiles?
So the size that we use in the lab, they can really be any size because we can scale them down to do testing in microgravity. So we sent tiles that were about 3 inches wide to the International Space Station a couple years ago to test the code, test the state machine, test the algorithm of self-assembly. But now we're actually building our first ever human scale tiles. They're human size, so a little smaller than maybe your average human. But they're 2.5 feet on edge length. The larger scale that we would love to build in the future would actually be tiles that are big enough to form a buckyball, big open spherical approximation volume, that'd be about 10 meters in diameter, so 30 feet, which is much bigger and grander in terms of open space than any current module on the ISS. And one of the goals with this project was to say, what's the purpose? of next generation space architecture? Should it be something that really inspires and delights people? When you float into that space, can you get goosebumps in the way that you do when you walk into a really stunning piece of architecture on Earth? And so we think that self-assembly, this modular, reconfigurable algorithm for constructing space structures in orbit, is going to give us this promise of space architecture that's actually worth living in.
Living in, I thought you also meant from like outside artistic perspective. When you see the whole thing, it's just
with the aesthetics of it. Absolutely.
You know, when you like go like into Vegas or something, whenever you go into a city and it like over the hill appears in front of you. And I mean, there's something majestic about seeing like, wow, humans created that. It gives you like hope about like if these a bunch of ants were able to figure out how to build skyscrapers that light up, and in general the design of these tiles and the way you envision it are pretty scalable.
Yes. And they're inspired by exactly what you mentioned a moment ago, which is we have these patterns of self-assembly on Earth. Mm-hmm. And there's a lot of fantastic MIT research that we're building this concept on. So like Daniela Roos at CSAIL and Pebbles, taking the power of magnets to create units that are themselves interchangeable, this notion of programmable matter. And so we're interested in going really big with it to build big scale space structures with programmable tiles. But there's also a really fascinating, end of that on the other side of the spectrum, which is how small can you go with matter that's programmable and stacks and builds itself and creates a bridge or something in the future.
What do you envision the thing would look like? Like when you imagine a thing far into the future where there's so we're not even thinking about like small space, well, let's not call them small, but our currently sized space stations, but like something gigantic. What do you envision? Is this something with symmetry, or is this something we can't even come up with yet? Is there beautiful structures that you imagine in your mind?
I've got 3 candidates that I would love to build. If we're talking about monumental space architecture, one is, what does a space cathedral look like? It can be a secular cathedral. It doesn't necessarily have to be about religion, but that notion of long sight lines, inspiring, stunning architecture when you go in. And you can imagine floating, instead of, being on the ground and only looking up in space, you could be in a central node, and each direction you look at, all the cardinal directions, are spires going off in a really large and long way. So that's concept number 1. Number 2 would be something more organic that's not just geometric. So here, one of the ideas that we're working on at MIT in my lab is to say, could you, instead of the tesserae model, right, which is self-assembling a shell, could you define a module that's a node, a small node that someone can live in, and you self-assemble a lot of those together? They're called plesiohedrons, like space-filling solids. And you dock a bunch of them together, and you can create a really organic structure out of that. So this is the same way that muscles accrete to appear. You can have these nodes that dock together, and one shape that I would love to form out of this is something like a nautilus, a seashell. That beautiful, Fibonacci spiral sequence that you get in that shape, which I think would be a stunning and fabulous aggregated space station.
You said so many cool words. Plesiohedron.
Yeah, plesiohedron.
So that's a space-filling
solid. The simplest thing to think about is like a
sphere?
cube.
Oh, cube.
A cube, right? So you can stack cubes together, and if you had an infinite number of cubes, you'd fill all that space. There's no gaps in between the cubes. They stack and fill space. Another plesiohedron is a truncated octahedron, and that's actually one of the candidate structures that we think would be great for space stations.
What's the truncated part?
So you cut off an octahedron, actually has little pointy areas. Right. You truncate certain sections of it, and you get surfaces that are on the structure that are cubes and I think hexagons. I'd have to remind myself exactly what the faces are. But overall, a truncated octahedron can be bonded to other truncated octahedrons, and just like a cube, it fills all the gaps as you build it out. So you can imagine 2 truncated octahedrons, they come together at an airlock, which is what we space people call doors in space, and you dock them on all sides, and you've basically created this decentralized network of space nodes that make a big space station. And once you have enough of them and you're growing with enough big units, you can do it in any macro shape you want. That's where the Nautilus comes in, is could we design an organically inspired shape for a space station?
Can I just say how awesome it is to hear you say, we space people? I know you meant people that are doing research on space exploration, space technology, but it also made me think of a future. There's Earth people, and there's those space people, and then
I'd love to unite those two.
Yeah, no, for sure, for sure. But like, it's like New Yorkers and like Texans or something like that. Yeah, of course you live for a time in New York and then you go up to Boston, but for a time you're the space people. Oh, I know those space people. They're kind of wild up there.
Let's see how that dynamic evolves.
Yeah, exactly. Yeah. There's that culture forms, and I would love to see what kind of culture once you have sort of more and more civilians. I mean, there's a human. I mean, I love psychology and sociology, and I'll maybe ask you about that too, which is like the dynamic between humans. You have to kind of start considering that when you start spending more and more time up in space, and start sending civilians, start sending bigger and bigger groups of people, and then of course the beautiful and the ugly emerges from the human nature that we haven't been able to escape up to this point. But when you say the plesiahedrons, these kinds of shapes, are they multifunctional? Like, is the idea you'd be able to, humans can occupy them safely in some of them, and some others have some other purposes?
Exactly. One could be sleeping quarters. One could be a greenhouse or an agricultural unit. One could be a storage depot. Essentially, all of the different rooms or functions that you might need in a space station could be subdivided into these nodes and then stacked together. And one of the promises of both Tesserae, my original PhD research, which is these shells, and then this follow-on node concept, is that right now we build space stations, and once they're built, they're done. You can't really change them profoundly. But the benefit of a modular self-assembling system is you can disassemble it. You can completely reconfigure it. So if your mission changes, or the number of people in space that you want to host, if you have a space conference happening like South by Southwest.
I was thinking space party, but space conference is good too.
Then maybe all of a sudden you want to change out what were window tiles yesterday, cupola tiles, and make them into a berthing port so that you can welcome 5 new spaceships to come and join you in space. That's what this promise of reconfigurable space architecture might allow us to explore.
I've been hanging out with Grimes recently. I just feel like she belongs up in space. This is like designed for artists, essentially. Like, imagine, I mean, this is what South by keeps introducing me to, is there's like the weird and the beautiful people, and like the artists. And it feels like there's a lot of opportunities for art and design.
100%.
It's like space is a combination of arts, design, and great engineering with a it's safety critical with like the highest of stakes. So you can't mess it up. And is there, first of all, you talking about tiling? So Neil Stephenson is obsessed about tile. I don't know if it's related to any of this, but he seems to be obsessed with like, how do you tile a space? That's like a geometric notion, like the tessellation. And it's a beautiful idea for architecture that you can self-assemble these different shapes, and you can have probably some centralized guidance of the kind of thing you want to build, but they also kind of figure stuff out themselves in terms of the low level details, in terms of the figuring out when everything fits just right for the OCD people. Like, what's that subreddit? Pleasantly. It's like really fun. Everything, they have like videos of everything is just pleasant when everything just fits perfectly.
Very pleasing. All the tolerances come together well. Yeah.
So they figure that out on themselves, and the local robotics problem. Exactly. But by the way, was Pebbles? What's the Pebbles project?
The Pebbles project are little cubes that have EPMs in them, electropermanent magnets, and they can self-disassemble. So they'll turn off, and so you'll have this little structure that all of a sudden can flip the little pebbles over and essentially just disaggregate.
They have to make some pleasing sounds.
Yes.
And what that's gonna. So I'm supposed to talk to Danielle, so I'll probably spend an hour just discussing the sounds on the pebbles. Okay. What were we talking about? So that's because you mentioned 2, I think.
Right. My third one.
Yeah. Is there a third one?
My third one is a ring world. Just because every science fiction book ever that's worth anything has a ring world in it. And
this is like a donut?
A donut, yeah. So a really big torus that could encircle a planet or encircle another celestial body, maybe an asteroid or a small moon. And the promise here is just the beauty of being able to have that geometry in orbit and all that surface area for solar panels and docking and essentially just all of what that enables to have a ring world at that scale in orbit.
Well, by the way, for the viewers, we're looking at figure 11. What paper is this from? This is hexagonal tiling of a torus generated in Mathematica, referencing code and approach from 2 citations. So we're looking at a tiled donut. And I'm now hungry. So this is is this from your thesis or no?
This is probably, this is in my thesis. This looks like it was one of my earlier papers. This was an approach to say, great, we've come up with this tessellation approach for a buckyball. And we picked the buckyball because it is the most efficient surface area to volume shape. And what's expensive in space? The surface area, shipping up all that material. So we wanted something that would maximize the volume. But if we think about ring worlds and other shapes, we wanted to look at how do you tile a torus, and this is one example with hexagons, to be able to say, could we take this same tesserae approach of self-assembling tiles and create other geometries?
This is so freaking cool. This is awesome.
Yeah.
You're the founder and director of the MIT Space Exploration Initiative. It includes a ton of projects. So I just wanted to, they're focused, I guess, on life in space, from astrobiology, like we talked about, to habitats. Are there some other interesting projects part of this initiative that you are that pop to mind that you find particularly cool?
Absolutely. One is the future of in-space manufacturing. So if we're going to build large-scale space structures, yes, it's great to ship them up from Earth and self-assemble them. But what about extrusion in orbit? It's one of the best technologies to leverage in microgravity because you can extrude a particularly long beam that would sag in a normal gravity environment, but might be able to become the basis of a truss or a large-scale space structure. So we're doing miniature tests of extrusion and are excited to fly this on the International Space Station in a few months. We are working on swarm robots. We have just announced, actually, MIT's return to the moon. So my organization is leading this mission for MIT, going back to the surface of the moon as early as the end of this year, 2022, maybe early 2023, and trying to take data from our research payloads at this historic South Pole site where NASA's supposed to send the first humans back on the Artemis 3 mission. So our hope is to directly support that human mission with our data.
How does that connect to the swarm aspects? Does it connect?
It does. Yeah. So we're actually going to fly one of the little astro ants. That's the current plan.
Nice.
One of the little swarm robots on the top of a rover. That's part of the
ants
mission.
riding a rover?
Yes. Exactly. An ant riding a rover. That rover gets packed in a lander. That lander gets packed in a SpaceX rocket. So it's a whole nesting dolls situation to get to the moon.
Mother of robot dragons.
Yes. Yeah,
okay.
Exactly.
So this one, a swarm of one?
Swarm of one, exactly. We're testing out. It's a tech demonstration mission, not a true swarm. Yeah, there they are. Those are the astro ants.
Wow. And this was a distributed system, and in theory, you could have a ton of these.
Yes. These could also be centralized. So they have wireless technology that could also talk to a central base station, and we'll be assessing kind of case by case whether it makes sense to operate them in a decentralized swarm or to command them in a centralized swarm.
Each robot is equipped with 4 magnetic wheels, which enable the robot to attach to any magnetic surface, so you can operate basically in any environment. We tested the mobility of all robots on different materials in a microgravity environment.
On the Vomit Comet, prior to going to the moon.
That must look so cool. So they're basically moving along different like metallic surfaces.
Yeah, exactly. It's interesting when you just a minute ago talking about the reflection of how space can be so aspirational and so uniting. There's a great quote from Bill Anders from the Apollo 8 mission to the moon, which is it's the Earthrise photo that was taken where you see the Earth coming up over the horizon of the moon. And the quote is something along the lines of, we came all the way to discover the moon, and what we really discovered was the Earth. This really powerful image looking back. And so we're also trying to think for our lunar mission, we realized we're a very privileged group at MIT to get the opportunity to do this. How could we bring humanity along with us? And so one of the things we're still testing out, I don't know if we're going to be able to swing it, would be to do something like a Twitch plays Pokemon, but with the robot. So let a lot of people on Earth actually control the robot, or at least benefit from the data that we're gathering and try to release the data openly. So we're exploring a couple different ideas for how do we engage more people in this mission.
That would be surreal to be able to interact in some way with the thing that's out there.
Exactly.
On another surface.
Direct connection.
Connection. I think about artificial intelligence in that same way, which is like building robots puts a mirror to us humans.
Certainly.
It makes us like wonder about like, what is intelligence? What is consciousness? And what is actually valuable about human beings? When an AI system learns to play chess better than humans, you start to let go of this idea that humans are special because of intelligence. It's something else. It's maybe the flame of human consciousness. It's the capacity to feel deeply, to both suffer and to love, all those things. And that somehow AI to me sort of puts a mirror to that. You mentioned HAL 9000. You have to bring it up with these swarm bots crawling on the surface of your cocoon in space.
Right.
I mean, all right. Let me steel man the HAL 9000 perspective here.
Okay.
The poor guy just wanted to maintain the mission, and the astronauts were. I mean, I don't know if people often talk about that, but like doctors have to make difficult decisions too. When there's limited resources, you actually do have to sacrifice human life often because you have to make decisions.
Right.
And I think Hal was probably making that kind of decision about what's more important, the lives of individual astronauts or
the mission.
Yeah. And I feel like AI when other humans will need to make these decisions. And it also feels like AI systems will need to help make those decisions. I don't know. I guess my question is about greater and greater collective intelligence by systems. Do you worry about that? What is the right way to sort of solve this problem, keeping a human in the loop? Do you think about this kind of stuff? Or are they sufficiently dumb now, the robots, that's not yet on the horizon to think about?
I think it should be on the horizon. It's always good to think about these things early because we make a lot of technical design decisions at this phase working with swarm robots that it would be better to have thought about some of these questions early in the life cycle of a project. There is a real interest in NASA right now thinking about the future of human-robot interaction, HRI, and what is the right synergy in terms of level of control for the human versus level of dependence or control for the robot. And we're beginning to test out more of these scenarios. For example, the Gateway space station, which is meant to be in orbit around the moon as a staging base for the surface operations, is meant to be able to function autonomously with no humans in it for months at a time because they think it's going to be seasonal. They think we might not be constantly staffing it. So this will be a really great test of, I don't know that anybody's yet worried about HAL 9000 evolving, but certainly just the robustness of some of these AI systems that might be asked to autonomously maintain the station while the humans are away, or detection algorithms that are going to say, if you had a human pilot, they might see debris in orbit and steer around it. There'll be a lot of autonomous navigation that has to happen. That'll be one of the early test beds where we'll start to get a little bit closer to that future.
Well, the HRI component is really interesting to me, especially when the I includes like almost friendship. Because like people don't realize this, I think, that we humans long for connection. And when you have even a basic interaction that's just like supposed to be just like serving you or something, you still project, it's still a source of meaning and connection. And so you do have to think about that. I mean, HAL 9000, the movie maybe doesn't portray it that way, but I'm sure there's a relationship there between the astronauts and the robot.
Yeah.
Especially when you have greater and greater level of intelligence. And maybe that addresses the happiness question too.
Yeah. I think there's a great book by Kate Darling, who's one of my colleagues at MIT.
Yeah, she's amazing. She's already been on this podcast, but we talk all the time, and we're supposed to talk, and we've been missing each other, and we're gonna make it happen soon.
Yeah.
Come down to Texas, Kate. All right. Anyway, yeah, she's amazing. And she has this book. Her whole work is about this
connection with robots. Yeah.
This beautiful connection that we have with robots. But I think it's greater and greater importance when it's out in space because it could help alleviate some of the loneliness.
Right. One of the projects in the book that I gave you, which is this catalog of the projects that we've worked on over the last 5 years, is this social robot that was developed at the Media Lab. And one of the first years in 2017 that we flew a zero-G flight, we took the social robot along and tried to do a little bit of a very scaled down human study to look at these questions, because you do imagine that we would form a bond, a real bond with the social robots that might be not just serving us on a mission, but really be our teammates on a future mission. And I do think that that could have a powerful role in the mental health and just the stability of a crew, is to have some other robot friends come along.
What do you, by the way, the book you mentioned is Into the Anthropocosmos, a whole space catalog from the space catalog.
Get that reference.
Yeah, so call out to Earth catalog, a whole space catalog from the MIT Space Exploration Initiative. What about the happiness? You said that that's one of the problems of when you're out in space. How do you keep humans happy? Again, asking for a friend.
Yes. I mean, one of the big challenges is you can't just open a window or walk out a door and blow off steam, right? You can't just go somewhere to clear your head. And in that sense, you need to build habitats that are homes that really care for the humans inside them and have, whether it's biophilia and a place where you can go and feel like you're in nature, or a VR headset, which for some people is a poor simulacrum, but is maybe better than nothing. You need to be thinking about these technological interventions that are going to have to be part of your home and be part of your maybe day-to-day ritual to keep you steady and balanced and happy or feeling fulfilled.
Mm-hmm. What about other humans? Relationship with other humans?
Yeah.
Do those get weird when you get past a certain number of humans?
I'm not an expert in this area, but an anecdote that I'll share. My understanding is that NASA has still not decided whether it's better to send married couples or single crew members, in terms of you want some level of stability. You don't want to have the drama of romantic relationships like you're alluding to before, but they can't decide because married couples also fight and have a really tough dynamic. And so there's a lot of open questions still to answer about what is the ideal psychological makeup of a crew. And we're starting to test some of these things with the civilian crews that are going up with Inspiration 4, like last fall with SpaceX, and AX-1 that's going to fly in a few days here in March. As we begin to lengthen the time of those civilian crews, I think we'll start to learn a little bit more about just average, everyday human-to-human dynamics, and not the astronauts that are themselves selected to be perfect human specimens, very good to work with, easy to get along with.
I wish you collected more data about this pandemic, because I feel like it's a good rough simulation of what it'd be out in space. A lot of people were in lockdown, some married couples. I think a lot of marriages broke up. A lot of marriages got closer together. So it's like, and then the single people, some of them went off the cliff, and some of them discovered their new happiness and meaning, and so on. It's a beautiful little experiment, a painful one.
Yeah.
Is there a thorough way to really test that? Because it's such a costly experiment to send humans up there, but I guess you can always return back to Earth if it's not working out.
That's what we hope. That's what you hope. You don't have like a Apollo 13 situation that doesn't quite make it back. But yeah, this is also why Mars is such a challenge. The moon is only 3 days away. That's a lot quicker to recover from if there's a psychological problem with the crew or any type of maintenance problem, anything. 3 years is such a challenge compared to these other domains that we've been getting more used to in terms of human spaceflight. So this is a question that we will need to have explored more before we start really sending crews to Mars.
So you're a young scientist. Do you think in your lifetime you will go out into orbit, you will go out beyond into deep space and potentially I don't know if you can call yourself a civilian. I don't know if that's what you count as, but you as a curious ant from MIT step on Mars?
Yes.
So
That's a firm.
Are you coming back?
Firm, yes. Yeah, I'm coming back. I don't want that one-way mission. I want the two-way mission. But yes, I mean, I think we're already talking about a pretty near-term opportunity where I could send graduate students to the International Space Station. Yeah,
okay.
So no, not a sacrifice.
Right.
No, but send graduate
students
for the experience. Send graduate students to the ISS to do their research.
Yes.
I do think you and I both would have an opportunity to go to a lunar base of some sort within our lifetime, and there's a good chance, if we really wanted to, we might have to really advocate for it, apply to an astronaut program. There will be some avenues for humans in our lifetime to go to Mars.
What's the bar for like health? Do you think that bar will keep getting lower and lower in terms of how healthy, how athletic, like how the psychological profile, all those kinds of things?
Yeah. For one, we're going to build more robust habitats that don't depend on astronauts being so impeccably well trained. So we're going to make it better for inclusion and just opening access to space. But there's a fantastic group called Astro Access that is already helping disabled space flyers do zero-G flights and potentially get access to the ISS. And some of the things that we think of as disabilities on Earth are hyper abilities in space. You don't need really powerful legs in space. What you'd really benefit from having is a third arm, more ways to kind of move yourself around and grip and interact. So we are already seeing a much more open-minded approach to who gets to go to space, and Astro Access is a wonderful organization doing some of that work.
I'm hoping introversion will also be a superpower in space. Okay, so you led the OpenAI robotics team. Can you give an overview of the cool things you were able to accomplish? What are you most proud of?
So when we started robotics, we knew that actually reinforcement learning works, and it is possible to solve fairly complicated problems. Like for instance, AlphaGo is an evidence that it is possible to build superhuman Go players. Dota 2 is an evidence that it's possible to build superhuman agents playing Dota. So I asked myself a question, what about robots out there? Could we train machines to solve arbitrary tasks in the physical world? Our approach was, I guess, let's pick a complicated problem that if we would solve it, that means that we made some significant progress in the domain, and then we went after the problem. So we noticed that actually the robots out there, they are kind of at the moment optimized per task. So you can have a robot that it's like, if you have a robot opening a battle, it's very likely that the end factor is a battle opener. And in some sense, that's a hack to be able to solve a task, which makes any task easier. And I asked myself, so what would be a robot that can actually solve many tasks?
Yeah.
And we concluded that human hands have such a quality that indeed they are, you have 5 kind of tiny arms attached. Individually, they can manipulate pretty broad spectrum of objects. Mm-hmm. So we went after trying to solve Rubik's Cube single-handed. We picked this task because we thought that there is no way to hard-code it. And it's also, we picked the robot on which it would be hard to hard-code it. And we went after the solution such that it could generalize to other problems.
And just to clarify, it's one robotic hand solving the Rubik's Cube. The hard part isn't the solution to the Rubik's Cube, is the manipulation of the of like having it not fall out of the hand, having it use the 5 baby arms to rotate different parts of the Rubik's Cube to achieve the solution.
Correct.
Yeah. So what was the hardest part about that? What was the approach taken there? What are you most proud of?
Obviously, we have like a strong belief in reinforcement learning. Mm-hmm. And one path it is to do reinforcement learning in the real world. Other path is to the simulation. In some sense, the tricky part about the real world is at the moment our models, they require a lot of data. Yeah. There is essentially no data. And we decided to go through the path of the simulation. And in simulation, you can have infinite amount of data. Mm-hmm. The tricky part is the fidelity of the simulation. And also, can you in simulation represent everything that you represent otherwise in the real world? And, it turned out that because there is lack of fidelity, it is possible to, what we arrived at is training a model that doesn't solve one simulation, but it actually solves the entire range of simulations, which vary in terms of like what's exactly the friction of the cube or weight or so. And the single AI that can solve all of them ends up working well with the reality.
How do you generate the different simulations?
So, there's plenty of parameters out there. We just pick them randomly. And in simulation, model just goes for thousands of years and keeps on solving Rubik's Cube in each of them. And the thing is, the neural network that we used, it has a memory. And as it presses, for instance, the side of the cube, it can sense, that's actually, this side was difficult to press. Mm-hmm. I should press it stronger. And throughout this process, kind of learns even how to solve this particular instance of the Rubik's Cube by given mass. It's kind of like sometimes when you go to a gym and after bench press, you try to lift the glass and you kind of forgot and your hand goes like up right away because kind of you got used to maybe different weight and it takes a second to adjust.
Yeah.
And this kind of a memory the model gained through the process of interacting with the cube in the simulation.
I appreciate you speaking to the audience with the bench press. All the bros in the audience probably working out right now. There's probably somebody listening to this actually doing bench press. So maybe put the bar down and pick up the water bottle and you'll know exactly what Wojciech is talking about. Okay. So what was the hardest part of getting the whole thing to work?
So the hardest part is at the moment when it comes to physical world, when it comes to robots, they require maintenance. It's hard to replicate them a million times. Yeah. It's hard to replay things exactly. I remember this situation that one guy at our company, he had like a model that performs way better than other models in solving Rubik's Cube. And, we didn't know what's going on, why it's that. And it turned out that, he was running it from his laptop that had better CPU or better, or maybe local GPU as well. Mm-hmm. And because of that, there was less of a latency and the model was the same. Mm-hmm. And that actually made solving Rubik's Cube more reliable. So in some sense, there might be some subtle bugs like that when it comes to running things in the real world. Even hinting on that, you could imagine that the initial models, you would like to have models which are insanely huge neural networks, and you would like to give them even more time for thinking. And when you have these real-time systems, then you might be constrained actually by the amount of latency. And ultimately, I would like to build a system that it is worth for you to wait 5 minutes because it gives you the answer that you are willing to wait for 5 minutes.
So latency is a very unpleasant constraint under which to operate.
Correct. And also there is actually one more thing which is tricky about robots. There is actually not much data. So the data that I'm speaking about would be data of first-person experience from the robot, and like gigabytes of data like that. If we would have gigabytes of data like that of robots solving various problems, it would be very easy to make a progress on robotics. And you can see that in case of text or code, there is a lot of data, like a first-person perspective data on writing code.
Yeah, so you mentioned this really interesting idea that if you were to build like a successful robotics company, so OpenAI's mission is much bigger than robotics. This is one of the things you've worked on. But if it was a robotics company, that you wouldn't so quickly dismiss supervised learning.
Correct.
That you would build a robot that was perhaps an empty shell, like dumb, and it would operate under teleoperation. So you would invest. That's just one way to do it. Invest in direct human control of the robots as it's learning, and over time add more and more automation.
That's correct. So let's say that's how I would build a robotics company today. If I would be building a robotics company, which is spend $10 million or so recording human trajectories, controlling a robot.
After you find a thing that the robot should be doing that there's a market fit for, like that you can make a lot of money with that product.
Correct.
Yeah.
So I would record data and then I would essentially train supervised learning model on it. That might be the path today. Long term, I think that actually what is needed is to train powerful models over video. So you have seen maybe models that can generate images like DALL-E.
Mm-hmm.
And people are looking into models generating videos. There are like various algorithmic questions, even how to do it. And it's unclear if there is enough compute for this purpose. But I suspect that the models which would have a level of understanding of video, same as GPT has a level of understanding of text, could be used to train robots to solve tasks. They would have a lot of common sense.
If one day, I'm pretty sure one day, there will be a robotics company. By robotics company, I mean the primary source of income is from robots that is worth over $1 trillion. What do you think that company will do?
I think self-driving cars, no?
It's interesting because my mind went to personal robotics, robots in the home. It seems like there's much more market opportunity there. I think it's very difficult to achieve. I mean, this this might speak to something important, which is I understand self-driving much better than I understand robotics in the home. So I understand how difficult it is to actually solve self-driving to a level, not just the actual computer vision and the control problem and just the basic problem of self-driving, but creating a product that would undeniably be that would cost less money, like it would save you a lot of money, like orders of magnitude less money, that could replace Uber drivers, for example. So car sharing that's autonomous, that creates a similar or better experience in terms of how quickly you get from A to B, or just whatever, the pleasantness of the experience, the efficiency of the experience, the value of the experience, and at the same time, the car itself costs cheaper. I think that's very difficult to achieve. I think there's a lot more low-hanging fruit in the home.
That could be. I also want to give you perspective on like how challenging it would be at home, or like maybe kind of depends on the exact problem that you'd be solving. Like if we're speaking about these robotic arms and hands, these things, they cost tens of thousands of dollars or maybe 100K. And maybe if there would be economy of scale, these things would be cheaper. But actually, for any household to buy it, the price would have to go down to maybe $1,000.
Yeah, I personally think that so self-driving car, it provides a clear service. I don't think robots in the home, there'll be $1 trillion company, will just be all about service. Meaning it will not necessarily be about like a robotic arm that's helps you, I don't know, open a bottle or wash the dishes or any of that kind of stuff. It has to be able to take care of that whole, the therapist thing you mentioned. I think that's, of course, there's a line between what is a robot and what is not. Like, does it really need a body? But, some AI system with some embodiment, I think.
So the tricky part, when you think actually what's the difficult part, is when the robot has, when there is a diversity of the environment with which the robot has to interact, that becomes hard. So, on one spectrum, you have industrial robots. As they are doing over and over the same thing, it is possible to some extent to prescribe the movements. And with very small amount of intelligence, the movement can be repeated millions of times. Mm-hmm. There are also, various pieces of industrial robots where it becomes harder and harder. Like, for instance, in case of Tesla, it might be a matter of putting a rack inside of a car. Mm-hmm. And, because the rack kind of moves around, it's not that easy. It's not exactly the same every time. It ends up being the case that you need actually humans to do it. Mm-hmm. While, welding cars together, it's a very repetitive process. Mm-hmm. Then in case of self-driving itself, the difficulty has to do with the diversity of the environment, but still the car itself, the problem that you are solving is you try to avoid even interacting with things. you are not touching anything around, because touching itself is hard. And then if you would have in the home robot that, has to touch things, and like if these things, they change the shape, if there is a huge variety of things to be touched, then that's difficult. If you are speaking about the robot, which there is, head that is smiling in some way with cameras, that it doesn't, touch things, that's relatively simple.
Okay. So to both agree and to push back. So you're referring to touch, like soft robotics, like the actual touch. But I would argue that you could formulate just basic interaction between, like non-contact interaction is also a kind of touch. And that might be very difficult to solve. That's the basic, not disagreement, but that's the basic open question to me with self-driving cars and disagreement with Elon, which is how much interaction is required to solve self-driving cars? How much touch is required? You said that in your intuition, touch is not required. In my intuition, to create a product that's compelling to use, you're going to have to interact with pedestrians, not just avoid pedestrians, but interact with them. When we drive around in major cities, we're constantly threatening everybody's life with our movements. And that's how they respect us. There's a game theory going on with pedestrians. And I'm afraid you can't just formulate autonomous driving as a collision avoidance problem.
So I think it goes beyond, like a collision avoidance is the first order approximation. But then, at least in case of Tesla, they are gathering data from people driving their cars. And I believe that's an example of supervised learning data that they can train their models on. And they are doing it, which, can give a model this like another level of behavior that is needed to actually interact with the real world.
Yeah, it's interesting how much data is required to achieve that. What do you think of the whole Tesla autopilot approach, the computer vision based approach with multiple cameras, and as a data engine, it's a multitask, multi-headed neural network, and it's this fascinating process of similar to what you're talking about with the robotics approach, which is, you deploy a neural network and then there's humans that use it, and then it runs into trouble in a bunch of places and that stuff is sent back. So like the deployment discovers a bunch of edge cases, and those edge cases are sent back for supervised annotation, thereby improving the neural network, and that's deployed again. It goes over and over until the network becomes really good at the task of driving, becomes safer and safer. What do you think of that kind of approach to robotics?
I believe that's the way to go. So in some sense, even when I was speaking about, collecting trajectories from humans, that's like a first step. And then you deploy the system, and then you have humans revising all the issues. And in some sense, like this approach converges to a system that doesn't make mistakes, because for the cases where there are mistakes, you gather data how to fix them, and the system will keep on improving.
So there's a very, to me, difficult question of how hard that, how long that converging takes, how hard it is. The other aspect of autonomous vehicles, this probably applies to certain robotics applications, is society, right? They put, as the quality of the system converges. So one, there's a human factors perspective of psychology of humans being able to supervise those, even with teleoperation, those robots. And the other is society willing to accept robots. Currently, society is much harsher on self-driving cars than it is on human-driven cars in terms of the expectation of safety. So the bar is set much higher than for humans. And so if there's a death in an autonomous vehicle, that's seen as a much more dramatic than a death in a human-driven vehicle. Part of the successful deployment of robots is figuring out how to make robots part of society, both on the human side, on the media journalist side, and also on the policy government side. And that seems to be, maybe you can put that into the objective function to optimize. But that is definitely a tricky one, and I wonder if that is actually the trickiest part for self-driving cars or any system that's safety critical. It's not the algorithm; it's the society accepting it.
Yeah, I would say I believe that the part of the process of deployment is actually showing people that the given things can be trusted.
Yeah.
And, trust is also like a glass that is actually really easy to crack it.
Yeah.
And damage it. And I think that's actually very common with innovation, that there is some resistance toward it.
Yeah.
And it's just a natural progression. So in some sense, people will have to keep on proving that indeed these systems are worth being used. And I would say, I also found out that often the best way to convince people is by letting them experience it.
Yeah, absolutely. That's the case with Tesla Autopilot, for example. That's the case with with basically robots in general. It's kind of funny to hear people talk about robots like there's a lot of fear, even with like legged robots. But when they actually interact with them, there's joy. I love interacting with them. And the same with the car. With a robot, if it starts being useful, I think people immediately understand. And if the product is designed well, they fall in love. You're right.
It's actually even similar when I'm thinking about Copilot, the GitHub Copilot. There was a spectrum of responses that people had. And ultimately, the important piece was to let people try it out. Mm-hmm. And then many people just loved it.
Especially like programmers.
Yeah, programmers. But like some of them, they came with a fear.
Yeah.
But then you try it out and you think, actually, that's cool. And you can try to resist the same way as, you could resist moving from punch cards to, let's say, C++ or so. Mm-hmm. And it's a little bit futile.
So, on that point, with a small tangent, but I think an important one, another industry in which I would say the only other industry in which there is automation actually touching people's lives today is autonomous vehicles.
Mm-hmm.
What the vision you just described of using computer vision and using cheap camera sensors, there's a debate on that of LiDAR versus computer vision. And sort of the Elon Musk famously said that LiDAR is a crutch, that really in the long term, camera only is the right solution, which echoes some of the ideas you're expressing. Of course, the domain in terms of its safety criticality is different. But what do you think about that approach in the autonomous vehicle space? And in general, do you see a connection between the incredible real world challenges you have to solve in the home with Roomba? And I saw a demonstration of some of them, corner cases, literally, and autonomous vehicles.
So there's absolutely a tremendous overlap between both the problems, a robot vacuum and an autonomous vehicle are trying to solve, and the tools and the types of sensors that are being applied in the pursuit of the solutions. In my world, my environment is actually much harder than the environment in automobile travels. We don't have roads. We have T-shirts. We have steps. We have a near infinite number of patterns and colors and surface textures on the floor.
Especially from a visual perspective. So
visually,
the looks
it's really tough.
Is infinitely variable.
On the other hand, safety is way easier on the inside. My robots, they're not very heavy. They're not very fast. If they bump into your foot, you think it's funny. And, autonomous vehicles kind of have the inverse problem.
Right.
And so that for me saying vision is the future, I can say that without reservation. For autonomous vehicles, I think I believe what Elon's saying about the future is ultimately going to be vision. Maybe if we put a cheap LiDAR on there as a backup sensor, it might not be the worst idea in the world.
So the stakes are much higher.
The stakes are much higher.
You have to be much more careful thinking through how far away that future is, right?
Right. But I think that the primary environmental understanding sensor is going to be a visual.
In his 1942 short story, Run Around, from his iRobot collection, Isaac Asimov proposed the 3 laws of robotics in order: don't harm humans, obey orders, protect yourself. So 2 questions. First, does the Roomba follow these 3 laws? And also, more seriously, what role do you hope to see robots take in modern society and in the future world?
So the 3 laws are very thought-provoking and require such a profound understanding of the world a robot lives in, the ramifications of its action and its own sense of self, that it's not a relevant bar. At least it won't be a relevant bar for decades to come. And so if Roomba follows the 3 laws, and I believe it does, it is designed to help humans, not hurt them. It's designed to be inherently safe. And we design it to last a long time. It's not through any AI or intent on the robot's part. It's because following the 3 laws is aligned with being a good robot product. So I guess it does, but not by explicit design.
So then the bigger picture, what role do you hope to see robots take in what's currently mostly a world of humans?
We need robots to help us continue to improve our standard of living. We need robots because the average age of humanity is increasing very quickly, and simply the number of people young enough and spry enough to care for the elder growing demographic is inadequate. And so what is the role of robots? Today, the role is to make our lives a little easier, a little cleaner, maybe a little healthier. But in time, robots are going to be the difference between real gut-wrenching declines in our ability to live independently and maintain our standard of living, and a future that is the bright one where we have more control over our lives, can spend more of our time focused on activities we choose. And I'm so honored and excited to be playing a role in that journey.
So I got to ask you, I think this is a fundamental and fascinating question, because iRobot has been a successful company and a rare successful robotics company. So Anki, Jibo, Mayfield Robotics with their Robot Curie, Sci-Fi Works, Rethink Robotics. These were robotics companies that were founded and run by brilliant people. But all, very unfortunately, at least for us roboticists, all went out of business recently. So why do you think they didn't last longer? Why do you think it is so hard to keep a robotics company alive?
I say this only partially in jest, that back in the day before Roomba, I was a high-tech entrepreneur building robots. But it wasn't until I became a vacuum cleaner salesman that we had any success. So the point is, technology alone doesn't equal a successful business. We need to go and find the compelling need where the robot that we're creating can deliver clearly more value to the end user than it costs. And this is not a marginal thing where you're looking at the scale and you're like, it's close. Maybe we can hold our breath and make it work. It's clearly more value than the cost of the robot to bring in the store. And I think that the challenge has been finding those businesses where that's true in a sustainable fashion. When you get into entertainment style things, you could be the cat's meow one year, but 85% of toys, regardless of their merit, fail to make it to their second season. It's just super hard to do so. And so that's just a tough business. And there's been a lot of experimentation around what is the right type of social companion, what is the right robot in the home that is doing something other than tasks people do every week that they'd rather not do. And I'm not sure we've got it all figured out right. And so that you get brilliant roboticists with super interesting robots that ultimately don't quite have that magical user experience, and thus that value benefit equation remains ambiguous.
So you, as somebody who dreams of robots, changing the world, what's your estimate? How big is the space of applications that fit the criteria that you just described, where you can really demonstrate an obvious significant value over the alternative non-robotic solution?
Well, I think that we're just about none of the way to achieving the potential of robotics at home. But we have to do it in a really eyes wide open, honest fashion. And
so another way to put that is the potential is infinite, because we did take a few steps, but you're saying those steps are just very initial steps. So the Roomba is a hugely successful product, but you're saying that's just the very, very beginning.
That's just the very, very beginning. It's the foot in the door. And, I think I was lucky that in the early days of robotics, people would ask me, when are you going to clean my floor? It was something that I grew up saying, I got all these really good ideas, but everyone seems to want their floor clean. Right. And so maybe we should do that. Then
your good ideas
earn the right to do the next thing after that.
So the good ideas have to match with the desire of the people, and then the actual cost has to, like the business, the financial aspect has to all match together.
Yeah, I during our partnership back a number of years ago with Johnson Wax, they would explain to me that they would go into homes and just watch how people lived and try to figure out what were they doing that they really didn't really like to do, but they had to do it frequently enough that it was top of mind and understood as a burden. Hey, let's make a product, or come up with a solution to make that pain point less challenging.
And sometimes we do certain burdens so often as a society that we actually don't even realize, like it's actually hard to see that burden is something that could be removed. So it does require just going into the home and staring at, wait, how do I actually live life? What are the pain points?
Yeah, and getting those insights is a lot harder than it would seem it should be in retrospect.
So how hard on that point, I mean, one of the big challenges of robotics is driving the cost down to something that people would afford. So people would be less likely to buy a Roomba if it costs $500,000, right? Which is probably sort of what a Roomba would cost several decades ago. So how do you drive, which I imagine is very difficult, how do you drive the cost of a Roomba or a robot down such that people would want to buy it?
When I started building robots, the cost of the robot had a lot to do with the amount of time it took to build it. And so that we would build our robots out of aluminum. I would go spend my time in the machine shop on the milling machine, cutting out the parts and so forth. And then when we got into the toy industry, I realized that if we were building at scale, I could determine the cost of the robot instead of adding up all the hours to mill out the parts, but by weighing it. And that's liberating. You can say, wow, the world has just changed as I think about construction in a different way. The 3D CAD tools that are available to us today, the operating at scale where I can do tooling and injection mold an arbitrarily complicated part, and the cost is going to be basically the weight of the plastic in that part, is incredibly exciting and liberating and opens up all sorts of opportunities. And for the sensing part of it, where we are today is, instead of trying to build skin, which is like really hard. For a long time, I spent creating strategies and ideas around how could we duplicate the skin on the human body, because it's such an amazing sensor.
Yeah.
The instead of going down that path, why don't we focus on vision and how many of the problems that face a robot trying to do real work could be solved with a cheap camera and a big ass computer.
Yeah.
And Moore's law continues to work.
Yeah.
The cell phone industry, the mobile industry is giving us better and better tools that can run on these embedded computers. And I think we passed an important moment maybe 2 years ago where you could put machine vision capable processors on robots at consumer price points. And I was waiting for it to happen. We had avoided putting lasers on our robots to do navigation, and instead spent years researching how to do vision-based navigation, because you could just see it where these technology trends were going. And between injection molded plastic and a camera with a computer capable of running machine learning and visual object recognition, I could build an incredibly affordable, incredibly capable robot. And that's going to be the future journey.
So you give me a tour. You showed me some of the long histories now, 29 years that iRobot has been at it, creating some incredible robots. You showed me PackBot. You showed me a bunch of other stuff that led up to Roomba, that led to Brava and Terra. So let's skip that incredible history in the interest of time, because we already talked about it. I'll show this incredible footage. You mentioned elderly and robotics in society. I think the home is a fascinating place for robots to be. So where do you see robots in the home? Currently, I would say, once again, probably most homes in the world don't have a robot. So how do you see that changing? Where do you think is the big initial value add that robots can do?
So iRobot has sort of, over the years, narrowed in on the home, the consumer's home, as the place where we want to innovate and deliver tools that will help a home be a more automatically maintained place, a healthier place, a safer place, and perhaps even a more efficient place to be. And, today we vacuum, we mop, soon we'll be mowing your lawn. But where things are going is, when do we get to the point where the home, not just the robots that live in your home, but the home itself becomes part of a system that maintains itself and plays an active role in caring for and helping the people who live in that home. And I see everything that we're doing as steps along the path toward that future.
So what are the steps? So if we can summarize some of the history of Roomba, you've mentioned, and maybe you can elaborate on it, but you mentioned that the early days were really taking a robot from something that works either in the lab or something that works in the field that helps soldiers do the difficult work they do, to actually be in the hands of consumers and tens of thousands, hundreds of thousands of robots that don't break down over how much people love them over months of very extensive use. So that was the big first step. And then the second big step was the ability to sense the environment, to build a map, to localize, to be able to build a picture of the home that the human can then attach labels to in terms of, giving some semantic knowledge to the robot about its environment. Okay, so that's like two big, huge steps. Maybe you can comment on them, but also what is the next step of making a robot part of the home?
Sure. So the goal is to make a home that takes care of itself, takes care of the people in the home, and gives the user an experience of just living their life, and the home is somehow doing the right thing, turning on and off lights when you leave, cleaning up the environment. And we went from robots that were great in the lab, but were both too expensive and not sufficiently capable to ever do an acceptable job of anything other than being a toy or a curio in your home, to something that was both affordable and sufficiently effective to drive, be above threshold and drive purchase intent. Now we've disrupted the entire vacuuming industry. The number one selling vacuums, for example, in the US are Roombas. So not robot vacuums, but vacuums. And that's really crazy and weird. And
we need to pause on. I mean, that's incredible. That's it's incredible that a robot is the number one selling thing that does something.
Yep.
Something as essential as vacuuming.
Yep. So we're
congratulations.
Thank you. It's kind of fun to say, but just because this was a crazy idea that just started, in a room here, we're like, do you think we can do this? Well, hey, let's give it a try. But now the robots are starting to understand their environment. And if you think about the next step, there's two dimensions. I've been working so hard since the beginning of iRobot to make robots are autonomous, that they're smart enough and understand their task enough that they can just go do it without human involvement. Now what I'm really excited and working on is how do I make them less autonomous? Meaning that the robot is supposed to be your partner, not this automaton that just goes and does what a robot does. And so that if you tell it, hey, I just dropped some flour by the fridge in the kitchen, can you deal with it? Wouldn't it be awesome if the right thing just happened based on that utterance? And to some extent, that's less autonomous because it's actually listening to you, understanding the context and intent of the sentence, mapping it against its understanding of the home it lives in, and knowing what to do. And so that's an area of research. It's an area where we're starting to roll out features. You can now tell your robot to clean up the kitchen, and it knows what the kitchen is and can do that. And that's sort of 1.0 of where we're going. The other cool thing is that we're starting to know where stuff is. And why is that important? Well, robots are supposed to have arms, right? Data had an arm. Rosie had an arm.
Yeah.
Robbie the robot had an arm. I mean, robots
Sure.
are, they are physical things that move around in an environment, and they're supposed to do work.
Yeah.
And if you think about it, if a robot doesn't know where anything is, why should it have an arm? But with this new dawn of home understanding that we're starting to go enjoy, I know where the kitchen is. I might in the future know where the refrigerator is. I might, if I had an arm, be able to find the handle, open it, and even get myself a beer. Obviously, that's one of the true dreams of robotics, is to have robots bringing us a beer while we watch television. But, I think that new category of tasks where physical manipulation, robot arms, is just a potpourri of new opportunity and excitement.
And you see humans as a crucial part of that. So you kind of mentioned that, and I personally find that a really compelling idea. I think full autonomy can only take us so far, especially in the home. So you see humans as helping the robot understand or give deeper meaning to the spatial information.
Right. It's a partnership. The robot is supposed to operate according to descriptors that you would use to describe your own home. The robot is supposed to, in lieu of better direction, kind of go about its routine, which ought to be basically right and lead to a home maintained in a way that it's learned you like, but also be perpetually ready to take direction that would activate a different set of behaviors or actions to meet a current need to the extent it could actually perform that task. Visual system.
So on that point, well, let me ask, do you hope there's an iRobot robot in every home in the world one day?
I expect there to be at least one iRobot robot in every home. We've sold 25 million robots. So we're in about 10% of US homes, which is a great start. But I think that when we think about the numbers of things that robots can do, today I can vacuum your floor, mop your floor, cut your lawn, or soon we'll be able to cut your lawn. But there are more things that we could do in the home. And I hope that we continue using the techniques I described around exploiting computer vision and low-cost manufacturing, that we'll be able to create these solutions at affordable price points.
So let me ask on that front. Yeah, I think of human consciousness or consciousness in general as this magic superpower that allows us to deeply experience the world. And just as you're saying, I don't think that superpower has to take the exact flavor as humans have. That's my love for robots. I would love to add the ability to robots that can experience the world and other humans deeply. I'm humbled by the fact that idea does not necessarily need to look anything like how humans experience the world. But there's a dance of human to robot connection, the same way human to dog or human to cat connection. That there's a magic there to that interaction, and I'm not sure how to create that magic, but it's a worthy effort. I also love, just exactly as you said, on the question of consciousness or engineering consciousness. The fun thing about this problem is it seems obvious to me that 100 years from now, no matter what we do today, people, if we're still here, will laugh at how silly our notions were. So it's almost impossible for me to imagine that we will truly solve this problem fully in my lifetime. and more than that, everything we'll do will be silly 100 years from now. But it's still a word that makes it fun to me, because it's you have the full freedom to not even be right. Just to try is freedom. And that's how I
get
see.
Me that T-shirt, please. I love that.
So, human robot interaction is fascinating because it's like watching dancing. I've been dancing tango recently, and just there is no goal. The goal is to create something magical, and whether consciousness or emotion or elegance of movement, all of those things aid in the creation of the magic. And it's it's an art form to explore how to make that, how to create that in a way that's compelling.
Yeah, I love the line in Scent of a Woman with Al Pacino where he's speaking about the tango, and he said, it's just freedom that if you get tangled up, you just keep tangoing on.
And I think I'm a comedian. Like, I'm obsessed with what makes us human, and our human nature, and the nasty side of human nature tends to be where I've, ended up exploring over and over again. And I was just mostly fascinated by people's reaction. So it's my job to get the biggest reaction from a group of strangers, the loudest possible reaction. And I just had this instinct, just when I started building her, and people going, and scream, and people scream. And I would bring her out on stage and people would scream. And to me, that was the next level of entertainment. Getting a laugh, I've done that. I know how to do that. I think comedians were always trying to figure out what the next level is, and comedy's evolving so much. And, Jordan Peele had just done, these genius comedy horror movies, which feel like the next level of comedy to me. And this sort of funny horror of a robot was fascinating to me. But I think the thing that I got the most obsessed with was people being freaked out and scared of her. And I started digging around with pathogen avoidance and the idea that we've essentially evolved to be repelled by anything that looks human but is off a little bit. Anything that could be sick or diseased or dead essentially is our reptilian brain's way to get us to not try to have sex with it, basically. So I got really fascinated by how freaked out and scared. I would see grown men get upset. Get that thing away from me. Like, I don't like people would get angry. And it was like, that what this is, but the sort of amygdala getting activated by something that to me is just a fun toy said a lot about our history as a species and what got us into trouble thousands of years ago.
So it's the deep down stuff that's in our genetics, but also are people freaked out by the fact that there's a robot? So it's not just the appearance, but there's an artificial human.
Anything people, I think, and I'm just also fascinated by the blind spots humans have. So the idea that you're afraid of that. How many robots have killed people? How many humans have died at the hands of other humans?
Yeah.
Millions?
A few more. Yeah.
Hundreds of millions?
Yeah.
Yet we're scared of that? Yeah. And we'll go to the grocery store and be around a bunch of humans who statistically the chances are much higher that you're going to get killed by a human. So I'm just fascinated by, without judgment, how irrational we are as a species.
The worry is the exponential. So it's, you can say the same thing about nuclear weapons before we dropped on Hiroshima and Nagasaki. So the worry that people have is the exponential growth. So, so it's like, it's fun and games right now, but, overnight, especially if a robot provides value to society, we'll put one in every home, and then all of a sudden lose track of the actual large-scale impact it has on society, and then all of a sudden we'll gain greater and greater control to where we'll all be, affect our political system and then affect our decisions.
Didn't robots already ruin our political system? Didn't that just already happen?
Which ones? Oh, Russia hacking.
No offense. But hasn't that already happened? That was like an algorithm of negative things being clicked on more.
We'd like to tell stories and we'd like to demonize certain people. I think nobody understands our current political system or discourse on Twitter, the Twitter mobs. Nobody has a sense, not Twitter, not Facebook, the people running it. Nobody understands the impact of these algorithms. They're trying their best. Yeah. Despite what people think, they're not like a bunch of lefties trying to make sure that Hillary Clinton gets elected. It's more that it's an incredibly complex system that we don't, and that's the worry. It's so complex and moves so fast that nobody will be able to stop it once it happens.
And let me ask a question. This is a very savage question.
Yeah.
Which is this just the next stage of evolution as humans? Some people will die. Yes. That's always happened, This is just taking emotion out of it? Is this basically the next stage of survival of the fittest?
Yeah. You have to think of organisms. What is it mean to be a living organism? Like, is a smartphone part of your living organism? Or
we're in relationships with our phones.
Yeah.
But we have sex through them, with them. What's the difference between with them and through them?
But it also expands your cognitive abilities, expands your memory, knowledge, and so on. So you're a much smarter person because you have a smartphone in your hand.
But as soon as it's out of my hand, we've got big problems because we've become sort of so morphed with them.
Well, there's a symbiotic relationship. And that's what so Elon Musk, the Neuralink, is working on, trying to
increase the bandwidth of communication between computers and your brain.
Mm-hmm.
And so further and further expand our ability as human beings to sort of leverage machines. And maybe that's the future, the next evolutionary step. It could be also that, yes, we'll give birth, just like we give birth to human children right now, we'll give birth to AI and they'll replace us. I think it's a really interesting possibility.
I'm going to play devil's advocate. I just think that the fear of robots is wildly classist because, I mean, Facebook, like it's easy for us to say they're taking their data. Okay, a lot of people that get employment off of Facebook, they are able to get income off of Facebook. They don't care if you take their phone numbers and their emails and their data as long as it's free. They don't want to have to pay $5 a month for Facebook. Facebook is a wildly democratic thing. Forget about the election and all that kind of stuff. You know, a lot of, you know, technology making people's lives easier. I find that most elite people are more scared than lower income people. So, and women for the most part. So the idea of something that's stronger than us and that might eventually kill us, like women are used to that. Like that's not, I see a lot of like really rich men being like, the robots are going to kill us. We're like, what's another thing that's going to kill us? You know, I tend to see like, oh, something can walk me to my car at night. Like something can help me cook dinner, something, you know, for, you know, people in underprivileged countries who can't afford eye surgery, like in a robot, can we send a robot to underprivileged, you know, places to do surgery where they can't? I work with this organization called Operation Smile where they do cleft palate surgeries. And there's a lot of places that can't do a very simple surgery because they can't afford doctors and medical care and such. So I just see, and this can be completely naive and should be completely wrong, but I feel like a lot of people are going like, the robots are going to destroy us. Humans, we're destroying ourselves. We're self-destructing. Robots, to me, are the only hope to clean up all the messes that we've created. Even when we go try to clean up pollution in the ocean, we make it worse because of the oil that the tankers use. Like, it's like, to me, robots are the only solution. You know, firefighters are heroes, but they're limited in how many times they can run into a fire, you know? So there's just something interesting to me. I'm not hearing a lot of like lower income, more vulnerable populations talking about robots.
Maybe you can speak to it a little bit more. There's an idea, I think you've expressed it. I've heard actually a few female writers and roboticists I've talked to express this idea that exactly what you just said, which is, it just seems that being afraid of existential threats of artificial intelligence is a male issue.
Yeah.
And I wonder what that is. If it because men haven't, in certain positions, like you said, it's also a classist issue. They haven't been humbled by life, and so you always look for the biggest problems to take on around you. It's
a champagne problem to be afraid of robots. Most people like don't have health insurance. They're afraid they're not going to be able to feed their kids. They can't afford a tutor for their kids. Like, I mean, I just think of, you know, the way I grew up, and I had a mother who, you know, worked 2 jobs, had kids. We couldn't afford an SAT tutor, you know, like the idea of a robot coming in, being able to tutor your kids, being able to provide childcare for your kids, you know, being able to come in with cameras for eyes and make sure, you know, surveillance, you know, I'm very pro surveillance because, you know, I've had security problems and I've been, you know, we're generally in a little more danger than you guys are. So I think that robots are a little less scary to us because we can see them maybe as like free assistance, help, and protection. And then there's sort of another element for me personally, which is maybe more of a female problem. I don't know. I'm just going to make a generalization. Happy to be wrong. But, you know, the emotional sort of component of robots and what they can provide in terms of, you know, I think there's a lot of people that don't have microphones that I just recently kind of stumbled upon in doing all my research on the sex robots for my stand-up special, which is there's a lot of very shy people that aren't good at dating. There's a lot of people who are scared of human beings who, you know, have personality disorders or grew up in alcoholic homes or struggle with addiction or whatever it is, where a robot can solve an emotional problem. And so we're largely having this conversation about like rich guys that are emotionally healthy and how scared of robots they are. We're forgetting about like a huge part of the population who maybe isn't as charming and effervescent and solvent as, you know, people like you and Elon Musk, who these robots could solve very real problems in their life, emotional or financial.
Well, that's in general a really interesting idea that most people in the world don't have a voice. It's you've talked about it, sort of even the people on Twitter who are driving the conversation. You said comments. People who leave comments represent a very tiny percent of the population, and they're the ones we tend to think they speak for the population, but it's very possible on many topics they don't at all.
And look, I'm sure there's got to be some kind of legal, sort of structure in place for when the robots happen. You know way more about this than I do, but for me to just go, the robots are bad, that's a wild generalization that I feel like is really inhumane in some way. Just after the research I've done, like you're going to tell me that a man whose wife died suddenly and he feels guilty moving on with a human woman or can't get over the grief, he can't have a sex robot in his own house? Why not? Who cares? Why do you care?
Well, there's an interesting aspect of human nature. So, we tend to, as a civilization, to create a group that's the other in all kinds of ways.
Right.
And so you work with animals too. You're especially sensitive to the suffering of animals. Let me kind of ask, do you think we'll abuse robots in the future? Do you think some of the darker aspects of human nature will come out?
I think some people will, but if we design them properly, the people that do it, we can put it on a record and we can put them in jail. We can find sociopaths more easily, But
why is that a sociopathic thing to harm a robot?
I think, look, I don't know enough about the consciousness and stuff as you do. I guess it would have to be when they're conscious, but it is, the part of the brain that is, responsible for compassion, the frontal lobe or whatever. Like people that abuse animals also abuse humans and commit other kinds of crimes. Like it's all the same part of the brain. No one abuses animals and then is like awesome to women and children and awesome to underprivileged, minorities. Like it's all, so, we've been working really hard to put a database together of all the people that have abused animals. So when they commit another crime, you go, okay, this is, it's all the same stuff. And I think people probably think I'm nuts for a lot of the animal work I do, but because when animal abuse is present, another crime is always present, but the animal abuse is the most socially acceptable. You can kick a dog and there's nothing people can do, but then what they're doing behind closed doors, you can't see. So there's always something else going on, which is why I never feel compunction about it. But I do think we'll start seeing the same thing with robots. Yes. The person that kicks I felt compassion when the kicking the dog robot really pissed me off. I know that they're just trying to get the stability right and all that, but I do think there will come a time where that will be a great way to be able to figure out if somebody has antisocial behavior stuff.
So there's two components to this to bear out. So one is the voice and the talking and so on, and then there's the visual appearance. So on the topic of gender and genderless, in your experience, what has been the value of the physical appearance? So what has it added much to the depth of the interaction?
I mean, mine's kind of an extenuating circumstance because she is supposed to look exactly like me. I mean, I spent 6 months getting my face molded and having, the idea was I was exploring the concept of can robots replace us? Because that's the big fear, but also the big dream in a lot of ways. And I wanted to dig into that area because, for a lot of people, it's like, they're going to take our jobs and they're going to replace us. Legitimate fear. But then a lot of women I know are like, I would love for a robot to replace me every now and then so it can go to baby showers for me and it can pick up my kids at school and it can cook dinner and whatever. So I just think that was an interesting place to explore. So her looking like me was a big part of it. Now her looking like me just adds an unnecessary level of insecurity because I got her a year ago and she already looks younger than me. So that's a weird problem. Yeah. But I think that her looking human was the idea. And I think that where we are now, please correct me if I'm wrong, a human robot resembling an actual human is going to feel more realistic than some generic face.
Well, you're saying that robots that have some familiarity, like look similar to somebody that you actually know, you be able to form a deeper connection with? That was the question?
So on some level,
That's an open question. I don't. It's an interesting,
or the opposite. Because then you know me and you're like, well, I know this isn't real because you're right here. So maybe it does the opposite.
We have a very keen eye for human faces, and they're able to detect strangeness, especially that when it has to do with people whose faces we've seen a lot of. So I tend to be a bigger fan of moving away completely from faces.
Of recognizable faces?
No, just human faces at all.
In general, because I think that's where things get dicey. And one thing I will say is I think my robot is more realistic than other robots, not necessarily because you have seen me and then you see her and you go, oh, they're so similar, but also because human faces are flawed and asymmetrical. Yeah. And sometimes we forget when we're making things that are supposed to look human, we make them too symmetrical. And that's what makes them stop looking human. So because they molded my asymmetrical face, she just, even if someone didn't know who I was, I think she'd look more realistic than most generic ones that didn't have some kind of flaws.
Got it.
You know, because they start looking creepy when they're too symmetrical because human beings aren't.
Yeah, the flaws is what it means to be human, so visually as well. But I'm just a fan of the idea of letting humans use a little bit more imagination. So just hearing the voice is enough for us humans to then start imagining the visual appearance that goes along with that voice. And you don't necessarily need to work too hard on creating the actual visual appearance. So there's some value to that. When you step into this territory of actually building a robot that looks like Bear Claw, it's such a long road of facial expressions, of sort of making everything smiling, winking, rolling the eyes, all that kind of stuff. It gets really, really tricky.
It gets tricky.
Do you think robots of the future, ones with human level intelligence, will be female, male, genderless, or another gender we have not yet created as a society?
You're the expert at this.
Well, I'm going to ask you.
You know the answer.
I'm going to ask you questions that maybe nobody knows the answer to, and then I just want you to hypothesize as a imaginative author, director, comedian. And
can we just be very clear that you know a ton about this and I know nothing about this, but I have thought a lot about what I think robots can fix in our society. And I mean, I'm a comedian. It's my job to study human nature, to make jokes about human nature, and to sometimes play devil's advocate. And I just see such a tremendous negativity around robots, or at least the idea of robots, that it was like, oh, I'm just going to take the opposite side for fun, for jokes. And then I was like, oh no, I really agree in this devil's advocate argument. So please correct me when I'm wrong about this stuff.
So first of all, there's no right and wrong, because we're all, I think most of the people working on robotics are really not actually even thinking about some of the big picture things that you've been exploring. In fact, your robot, what's her name, by the way?
Bear Claw.
We'll go with Bear Claw. What's the genesis of that name, by the way? What?
Bear Claw was, I don't even remember the joke because I black out after I shoot specials, but I was writing something about like the pet names that men call women, like Cupcake, Sweetie, Honey, you know, like we're always named after desserts or something. And I was just writing a joke about if you want to call us a dessert, at least pick like a cool dessert, you know, like Bear Claw, like something cool. Yeah. So I ended up calling her Bear Claw.
Stuck. So do you think future robots of greater and greater intelligence would like to make them female, male? Would we like to assign them gender? Or would we like to move away from gender and say something more ambiguous?
I think it depends on their purpose. You know, I feel like if it's a sex robot, people prefer certain genders, you know? And I also, you know, when I went down and explored the robot factory, I was asking about the type of people that bought sex robots. And I was very surprised at the answer because, of course, the stereotype was it's going to be a bunch of perverts. It ended up being a lot of people that were handicapped, a lot of people with erectile dysfunction, and a lot of people that were exploring their sexuality. A lot of people that thought they were gay but weren't sure, but didn't want to take the risk of trying on someone that could reject them and being embarrassed, or they were closeted, or in a city where maybe that's, you know, taboo and stigmatized, you know. So I think that a gendered sex robot, that would serve an important purpose for someone trying to explore their sexuality. Am I into men? Let me try on this thing first. Am I into women? Let me try on this thing first. So I think gendered robots would be important for that. But I think genderless robots, in terms of emotional support robots, babysitters, I'm fine for a genderless babysitter with my husband in the house. You know, there are places that I think that genderless makes a lot of sense, but obviously not in the sex area.
What do you mean with your husband in the house? What does that have to do with the gender of the robot?
Right. I mean, I don't have a husband, but hypothetically speaking, I think every woman's worst nightmare is like the hot babysitter. You know what I mean? So I think that there is a time and place, I think, for genderless, you know, teachers, doctors, all that kind of, it would be very awkward if the first robotic doctor was a guy or the first robotic nurse is a woman. You know, it's sort of, that stuff is so loaded. I think that genderless could just take the unnecessary drama out of it and possibility to sexualize them or be triggered by any of that. I have never seen such compassion from a lot of people in my life toward any human, animal, child as I have a lot of people in the way they interact with the robot. Because I think there's something of I mean, I was on the robot owners chat boards for a good 8 months. And the main emotional benefit is she's never going to cheat on you. Oh, wow. She's never going to hurt you. She's never going to lie to you. She doesn't judge you. You know, I think that robots help people. And this is part of the work I do with animals. Like I do equine therapy and train dogs and stuff because there is this safe space to be authentic. You're with this being that doesn't care what you do for a living, doesn't care how much money you have, doesn't care who you're dating, doesn't care what you look like, doesn't care if you have cellulite, whatever. You feel safe to be able to truly, you know, be present without being defensive and worrying about eye contact and being triggered by, you know, needing to be perfect and fear of judgment and all that. And robots really can't judge you yet, but they can't judge you. And I think it really puts people at their at ease and at their most authentic.
Do you think you can have a deep connection with a robot that's not judging, or do you think you can really have a relationship with a robot or a human being that's a safe space, or is it tension, mystery, danger necessary for a deep connection?
I'm going to speak for myself and say that I grew up in an alcoholic home. I identify as a codependent. I've talked about this stuff before, but for me, it's very hard to be in a relationship with a human being without feeling like I need to perform in some way or deliver in some way. And I don't know if that's just the people I've been in a relationship with or me or my brokenness, but I do think this is going to sound really negative and pessimistic, but I do think a lot of our relationships are projection and a lot of our relationships are performance. And I don't think I really understood that until I worked with horses, and most communication with human is nonverbal, right? I can say like, I love you, but you don't think I love you, right? Whereas with animals, it's very direct. It's all physical. It's all energy. I feel like that with robots too. It feels very, how I say something doesn't matter. My inflection doesn't really matter. And you thinking that my tone is disrespectful, like you're not filtering it through all of the bad relationships you've been in. You're not filtering it through the way your mom talked to you. You're not getting triggered. You know, I find that for the most part, people don't always receive things the way that you intend them to or the way intended. And that makes relationships really.
Let me ask you a completely ridiculous question, but it's a fascinating one for me from an engineering and a scientific perspective. When I look at a sport, really any problem, one way to ask how difficult is this problem is to see how can I build a machine that competes with a human being at that problem. You can look at chess, you can look at soccer, RoboCup, and then you can look at grappling. There's something about when you start to think, how would I build an AI system, a robot that defeats somebody like a Gordon Ryan, where it forces you to really think about formalizing this art as an engineering discipline in the same way you do, but you still have some art injected in there. There's no space for art when you actually have to build the system.
That's not a ridiculous question. That's a damn interesting question.
Let's put aside, like I mentioned with the Boston Dynamics Spot robots, what people don't realize is the amount of power they can deliver is huge. So let's take that weapon aside. just the amount of force you're able to deliver.
Yeah. I'm glad you're specifying that. So essentially, your question is, okay, can a talented group of engineers create a robot which could defeat Gordon Ryan? On the face of it, as you just pointed out, that's the easiest project in the world. Just create a robot that carries a 9mm automatic and shoot him 5 times in the chest. Okay, that's it. Gordon Ryan's done. So that's not the interesting question. The interesting question, and if I understand you correctly, is if we had the ability to create a robot whose physical powers were identical to Gordon Ryan, not inferior and not superior, what would it take to create a mind inside that robot that would beat Gordon Ryan in the majority of matches?
Yeah. And there's 2 ways to build AI systems. This is true for autonomous driving, for example, which has been quite contested recently. So one is one way to describe it is you have a giant set of rules. It's like this tree of rules where you apply a different condition. When there's a pattern you see, you apply a rule, and they're hard-coded in. You basically get like a John Donahue type of character who tries to hard code into the system all the moves you should do in every single case. Of course, you can't actually do that fully, so you're going to be taking shortcuts, what are called heuristics, just basic kind of generalizations, and apply your own expertise as an expert of, in this case, grappling, to see how that can be encoded as a rule. Now, the other approach, Elon Musk and Tesla are taking this approach, which is called machine learning, which is create a basic framework of the kind of things you should be observing and what are the metrics of success, and then just observe and see which things lead to success, more success, and which lead to less success. And there's a delta. You like when you see a thing. First of all, the way machine learning works is you see a position or you see a situation, and then you predict how good that is, and then you watch how it actually turns out. And if it's worse or better, you adjust your expectations.
Yes, that's
through that process, you can learn quite a lot. The challenge is, and this might be a very true challenge in grappling, is in driving, you can't crash. So there's a physical world. In chess, for example, where this approach has been exceptionally successful, you can work in simulation. So you can have AI system that, for example, as in the case with AlphaZero by DeepMind, Google's DeepMind, it can play itself in simulation millions of times, billions of times.
Correct. Yeah.
It's difficult to know if it's possible to do that in simulation for anything that involves human movement, like grappling. So that's my sense is, if we first look at the hard encoding, if you were to try to describe Gordon Ryan to a machine, how many rules are in there, do you think?
Yeah. First off, let me tell you, that's one of the most fascinating questions I've ever been asked. And I'm tremendously happy to answer this. How about what we do is, this is a massive question you've asked. There's a huge amount of ways this could get very interesting and very confusing. Let's set some ground rules for the discussion. Lex alluded to the idea of man versus machine in chess. Okay, and I think that's a really good place for us to start the discussion. I'm going to just tell people about a little bit the history of man versus chess to give you guys some background on this. In 1968, there was a party in which a highly ranked, not a world champion, but a highly ranked chess player, I think his name was Levy, and he met a computer engineer at a party, and they had a lighthearted bet that in a 10-year time frame, a human chess player would be defeated by a computer. Now, you got to remember, 1968, computing power was very, very low. The computers that got America to the moon were were actually pretty damn primitive. Your iPhone would kick all of their asses. So computational power was very, very low in those days. So interestingly, the chess player fully believed that no computer could beat him in the 10-year time frame, and the computer engineer was very optimistic that he was wrong, and that in fact 10 years the computer would win. 10 years later, they had a competition, and the human won decisively, in fact. So computational power simply hadn't risen to that level yet. Through the 1980s, computational power increased, but not sufficient to get to championship level. There were computer programs in the 1980s which were competitive with good, solid chess players, but not world beaters. Understand right from the start that there's a fundamental problem here. The number of options that the two players in a chessboard can run through is astronomically high. There are 64 squares on a chessboard. The number of possible options that could work or could play out on a chessboard, and this is a truly shocking thing for you to think about, the number of possible options is higher than the number of atoms in the known universe. Think about that for a second in terms of complexity, okay? The number of atoms on this table is massive, okay? That is an unbelievably large number. Then we're talking about a situation where if a computer had to go through all the options at the onset of a match, they would have to run numbers greater than the number of atoms in the known universe. The number of galaxies and the number of in our universe is vast. Okay, it's measured in the billions. Like the number of atoms, that's just a number so mind-blowing it's impossible. Okay, so no computer is ever going to be able to work with those kinds of numbers. Okay, I don't even know if future generations of quantum computers could work with those kind of numbers. So that's the fundamental problem. Okay, the number of options in a chess match is just so astronomically large that no computer could ever figure out all the available options and make decisions in a given time frame. So that's the fundamental problem. So as Lex correctly pointed out, the way you get around this is by the use of heuristics. These are rules of thumb, which give general guidelines to action. So, for example, in jiu-jitsu, I could give you a general rule of thumb. Don't turn your back on your opponent. Okay, that's a solid piece of advice. There are obviously some exceptions to that rule, but it's a good, solid piece of advice to give a beginner. The moment you give that heuristic rule, you rule out a lot of options. Okay, you've already told someone, don't turn your back on someone. So a lot of possibilities have just been turned away right there. So you've cut the number of options in half right there just by giving one heuristic rule. Okay, if you were decent at chess, not great, but decent, and you knew enough to give, say, 10 heuristic rules, you could chop that initially vast number of options down by a vast amount. And now you're starting to get to a point where if a computer had sufficient computational power, it could start getting through the number of options in that acceptable time frame. So that's the general pattern of the development. Now, things started getting very interesting in the mid-1990s with IBM's computer Deep Blue. There was a great chess champion of the late 1980s and early through the 1990s called Garry Kasparov, who had been more or less undefeated for a decade. In 1996, he took on IBM's computer Deep Blue.
Just to correct the record, he was undefeated. I apologize, Russian. Got to make sure.
They get very nationalistic about their chess. Be careful of these guys. Deep Blue lost the first confrontation, I believe, in 1996. It was competitive, but it lost. Then in 1997, Deep Blue won. And it wasn't a complete walkover. Kasparov, I believe, won one of the matches. But they did Deep Blue unequivocally won the confrontation. And it was seen as like this watershed moment where a computer beat the best human chess player on the planet, and that was it. There's no coming back from that.
I think it would be remembered as one of the biggest moments in computing history. is really when the first time a machine beat a human at a thing that humans really care about in the domain of intellectual pursuits.
Yeah, no, it was a powerful moment. Now, not only was that a powerful moment, but things started getting truly interesting from that moment forward, because then you started having different areas of development. The general way in which the progress is made from those early starts in 1968 all the way through to Deep Blue's victory was of the use of heuristic rules that brought down the number of potential options to a manageable level. As computer power increased, then it could make faster and faster and wiser decisions and make them at a rate which no human, even the best human, could keep up with. So that was the general way in which the debate went. But things got more interesting after this with the advent of computers that, as you pointed out, make use of so-called machine learning. There were a company put out a program, AlphaZero, which can look at the basic rule structures of chess and then ultimately play itself in trial games and make trial and error assessment of what are good and bad strategies, so that with no human intervention, a computer could start doing remarkable things. Not only did this company create AlphaZero, and there were some other ones too, that they fought not only in chess, but in the much more complex Asian game of Go, which has far more potential options than chess does by a very significant margin.
Yes.
These machine learning programs not only easily defeat any human in chess, but in Go as well. And what's truly remarkable is they weren't just beating them. When AlphaZero took on a rival chess program, which by itself was already superior to any human, it only required 4 hours, starting from learning the rules of chess to figuring out how to beat the second most powerful chess program in the world. That's insane. That's literally like taking a human, telling them the rules of chess, they play some games with themselves for 4 hours, and they go out and beat Garry Kasparov. This is, to me, this is a truly exciting development, far beyond even what Deep Blue did.
I like how you said exciting, not terrifying.
Yeah.
Because I agree with you on the exciting.
Yeah. Now, things also get exciting in a different direction. There is another possibility which few people foresaw after the Deep Blue episode. This is where a new form of chess started to emerge, sometimes called cyborg chess or centaur chess, where humans of moderate chess level playing ability, not world champions, just decent but not great, I guess you might say like purple belts in jiu-jitsu, allied themselves with computers. So the humans and computers worked as a cyborg team. The humans supplied the heuristic insight. The computers supplied the computational power. And fascinatingly, they proved to be superior to both the best humans and the best chess programs. The united force of human insight with heuristics, with computers' ability to go through numbers in far more rapid form than any human could ever hope to do, proved to be one of the strongest combinations and enabled that pairing of human and computer to overwhelm both the best single human and the best single computer. That adds a whole new level of fascination to this topic. So to wind things up here, we've got this fascinating initial question from Lex, the idea of could there be a computer inside a robot which doesn't have any special physical properties? This is mind versus mind, because the bodies negate each other. The robot has the same body as Gordon Ryan. This is a thought experiment. What would it take to create a mind that would defeat the mind of Gordon Ryan? based on the chess example, it would appear that this is entirely feasible at some point in the future. And in fact, I would go further and say it's actually quite likely, based on what we've seen from the example of chess. The rate of progress in AI in the last 20 years has dwarfed anything from the previous 50 years. And the rate continues to increase. We're talking now at a level where with machine learning defeating world champions in chess and Go in 4 hours, like just from starting from the rules of the sport. This is going to be difficult for humans to keep up with. Now, in humans' favor, could we take Gordon Ryan and put a chip inside his brain that created the same cyborg effect as we saw in Centaur chess and cyborg chess, and then take Gordon Ryan to a new level where suddenly his computational powers were massively increased? He still has his heuristic insight, but he has vastly augmented computational powers. That's the interesting battle. Mm-hmm. You asked a great question, Lex. Let me give you my initial push for an answer would be that if it's just Gordon Ryan versus your robot technology, in 10 years, I would say with machine learning, I say you guys win every time. But if it is cyborg Gordon Ryan, where he's part Gordon Ryan with heuristics and part machine, then now that's where I throw the question back at you, young man. What do you think? Well, I'm fascinated to hear your answer.
That's very interesting because there's a lot of different ways you can build a cyborg Gordon Ryan. So one is there's the Neuralink way, which is basically doing what you're suggesting, which is expanding the computational capabilities of Gordon Ryan's brain. Like directly being able to communicate between a computer and the brain. So you preserve most of what there is in the human body, including the nervous system and the computing system we currently have that's biological, and expanding it with the computer. There's also, on the cyborg chess front, like Magnus Carlsen, the current world champion in chess, he studies AlphaZero games. Like that, it's not a regular thing for high-level grandmasters to do.
From what I understand, almost every chess master now studies computer games for inspiration. Like that, just as great chess players from the past used to go back into old leather-bound books of previous grandmasters and study games and books. Nowadays, most people, when they want to study the most perfect games, they actually study programs like AlphaZero.
Yeah, and it's not just for inspiration; it's education. It's literally part of their training regimen. Yeah. This isn't like a fun side thing. This is the main way to get better. So there's a certain element there where even our human brains can be trained by observing the partial explorations of an AI systems in the space of grappling. That could be actually in simulation. It doesn't have to be in the physical world. It could be if we construct sufficiently good biomechanical models of human beings, machines can learn how they grapple. There's quite a bit of that already. OpenAI has the system of they're like sumo wrestlers with some basic goals of pushing each other off of a platform, and you know nothing you don't even know. So you have a basic model of a bipedal system. It doesn't even know in the beginning how to stand up. It just falls, right? So it has to learn how to get up, and they do that through self-play. They learn how to get up. They learn how to move enough to achieve the final goal, which is to push your opponent off of the thing.
Fascinating.
So they've learned that. Now, OpenAI is not, those folks are currently not that interested in the grappling world, so they kind of stop there.
Yeah.
But it's very possible in simulation to then develop ideas. In fact, this is something I should probably do, because it's pretty natural to do and easy, is ideas of control and submission and all the, you add the ability to, I don't know how to put it nicely, but to choke your opponent and to break their body parts off, which is jiu-jitsu is, add that in, and what kind of ideas it'll come up with is very fascinating. I actually don't know, until this conversation, I don't know why I never even thought about that. I've been very obsessed with just like walking and running and all those kinds of things, like evolving different strategies for when you have a bunch of, so one difficult thing for robots is when you have uneven terrain and there's uncertainty about the terrain, is how to keep walking, or when there's a bunch of things being thrown at you, all that kind of stuff. And you learn through self-play how to be able to navigate those uncertain environments when there's a lot of weird objects and all those kinds of things. There's no reason why you can't just do that with submissions and so on in simulation. That would be actually fascinating. But once, we might be surprised by the kind of strategies in simulation these AI systems will develop, and that might make a much better Gordon Ryan and much better John Donaher in asking the Dean Lister question of like, why are we not doing X? But on the actual sort of grappling event in the physical space, I've been very surprised and a little bit disappointed by how difficult it's to build a system that's able to have the body of Gordon Ryan, or a human being actually, which means it's not just the biomechanics, which is very difficult to do, but also all of the senses that are involved. Be able to perceive the world as richly, to be able to, there's something called soft robotics, which is incredibly difficult to do through touch, understand the hardness of things. We don't understand as human beings just how much we're able through touch to experience the world and to manipulate the world. Like the process of picking up a cup is very similar to the process of grappling. All the feeling that you do, all the leverage that you're applying, there's so many degrees of freedom in both in the interactive sense, in the sensing and the applying, sensing and applying. You're doing that through so much of your body that it's just going to be very difficult to build a system that's able to experience the world and act onto the world as richly as we humans can.
Yeah, if picking up a cup is a seemingly insurmountable challenge, then taking someone down, controlling them, getting past their legs, that's going to be one hell of a project.
Exactly. I mean, there could be shortcuts, but I mean, currently that's the field called robotic manipulation, which is picking up objects. Usually they have like a ball and a triangular object, and your whole task is to like pick it up and move it around. Generalizing that to the human body is harder, but perhaps not not as hard as we might think. The question is, how do you construct experiments where you can do that safely?
In chess, that's very easy.
Yeah.
But here, that's very, very problematic. I guess you could just have robot versus robot teamed up with each other, and then they learn, and then they go out to take on a human opponent.
Yes, exactly. So you have two physical robots that interact with each other.
Everything you've said so far suggests that many of the problems, these tactile elements, they're easy tasks for humans. So which becomes more powerful more quickly? Robots that are taught to think like humans, or humans that are given the computational power of computers and robots themselves? Which wins first, a cyborg Gordon Ryan or an artificial robot Gordon Ryan?
Really, really strong question, and I think by far the cyborg Gordon Ryan.
Yeah, that's what I'm thinking here. The problems you're talking about with regards to the robots, those are deep problems. Like if picking up a cup is problematic, it's going to be damn difficult. But to a human, that's a 2-year-old can do that.
You're highlighting a very important difference. Is human beings have something called common sense that we don't know how to build into computers currently. That's what picking up the cup is. It's some basic rules about the way this world works. We're able to, this is when we're children and we crawl around, we pick up. What humans don't have that machines have is incredible computational power and access to infinite knowledge. computers can do that. So if you have a Gordon Ryan with the infinite knowledge and compute power, that's just going to because we know how to do that. That's going to blow out of the water a robot.
Has there
that's
been any
trying to
update on the phenomenon of cyborg or centaur chess? There was some debate as to whether or not cyborg chess teams could stay competitive with the latest machine learning. Has there been any update on that?
I believe at this point machines dominate over the machine human pairs.
With the human pairs, when they first came out, they were good chess players, but not great chess players. Does it make any difference if you have, say, Garry Kasparov and a computer working in unison versus Joe Blow from?
No, it does make a huge difference, but both are destroyed by machines at this point.
And it's not even competitive now.
No, it's not competitive. But they also lost interest in this kind of idea. So I think there's still competitions between human machine pairs versus human machine pairs, almost like to see how the two work together. But in terms of machine versus human machine pair, machines still dominate.
Interesting.
So, and now we've retrieved back as human beings, caring mostly about human versus human competition, which is probably what the future will look like. It's very interesting to think, but like that in chess happened really quickly. It won't happen, and it wasn't so painful in chess because we care about chess, but it's not so fundamental to human society. When you started talking about cyborg Gordon Ryan's, which really beyond grappling is referring to robots operating physical space or human robot hybrids operating physical space, you're talking about our society is now full of cyborgs.
Yes,
and that transition might be very painful or transformative in a way we can't even predict. And that very much has applications, as both China and US now have legalized, is autonomous weapon systems. So use of these kinds of systems in military applications. So it used to be, there'd been a big call in the AI community to ban autonomous weapons. So the use of artificial intelligence in war, just like bioweapons are banned internationally. So you're not allowed to use bioweapons in war. And actually most people, even terrorists, have kind of agreed on this ban. It's not like there's been a quiet agreement, like we're not going to be doing this because everybody's going to get really pissed off. With autonomous weapon systems, that's not been the case. China has said that they're going to be using AI in their military, and the U.S. in 2021 just released a report saying that they're going to add increasing amounts of artificial intelligence into our military systems, into drones, into just everything that's doing any kind of both strategic and actual like bombing and defense systems.
I presume a drone army would easily defeat a human army in the near future. Like, I mean, think about, just off the top of my head, just think about the implication of kamikaze drones versus a naval fleet. I mean, kamikazes with humans in World War II did terrible damage to our Navy. Imagine swarms of mechanical kamikazes which have no fear, no remorse. I mean,
but it's very inefficient. Kamikaze is very inefficient. You want to be very like war is. It's the same discussion to jiu-jitsu, right? You want to be, you want to create an asymmetry of power, and you want to be efficient in the way you deliver that power. It actually goes back to the picking up a cup. Currently, a lot of things we do in war, like so most of the drones that you hear about, they're not autonomous. Not most, all.
They're usually piloted
remotely by humans. And humans are really good at this kind of what's necessary to deliver the most damage, targeted damage, effective as part of the largest strategy you have about bombing the area or all that kind of stuff. I don't know how difficult that is to automate. I think the biggest concern, I actually have a sense that it's very difficult to automate. the biggest concern is almost like an incompetent application of this and consequences that are not anticipated. So you have a drone army where you say, we want to target, you give it power to target a particular terrorist, and then there's some bug in the system that has for example, has a large uncertainty about the location of that terrorist, and so it decides to bomb an entire city. Almost like as a bug, a software bug. I'm much more concerned about like bad programming and software engineering than I am about like malevolent AI systems that destroy the world. So the more we rely on automation, this is the lesson of human history, the more we give to AI, to software, to robotic systems, the more we forget how to supervise and oversee some of the edge cases, all the weird ways that things go wrong. And then the more stupid software bugs can lead to huge damage, like, even like nuclear explosions, those kinds of things. If we add AI into the launch systems for nuclear weapons, for example, I think human history teaches us that software bugs is what will lead to World War III, not malevolent AI or human beings.
Interesting.
By the way, I deeply appreciate how knowledgeable you are about the history of artificial intelligence. That was awesome.
Oh, no, it's fascinating stuff. I remember reading when I was a child about, Turing tests and things like this, and visionaries from the 1950s had ideas. But to see it come this far is just fascinating to me. Okay, so what can we as jiu-jitsu players take away from this? We saw that when it comes to computers versus humans in chess tournaments, humans had something truly valuable to give to the computers. And that was heuristic rules. In every coaching program that I run, I make an endless quest to search out and find effective heuristic rules. That's the basis of a good training program. Heuristic rules and principles give vast informational content which can rapidly increase your performance on the mat, just as they rapidly increase the performance of chess computers to overcome their human adversaries. The great human weakness is computational power. Most people vastly overestimate their ability to reason and problem solve under stress. In fact, numerous psychological studies have shown that humans can balance a relatively small number of competing options in stressful decision making. But what we do have, what is the great and unique human gift, is this idea to come up and arrive at heuristic rules and principles which turn out to be very effective guides to behavior for both human behavior and artificially intelligent behavior. Make that your focus in study. Don't try to remember 10,000 different details on a move. Okay, that's human weakness, not human strength. Our strength is heuristics. Make that your focus, not endless computations over 25 details here merged with 27 details here. That's not what humans are good at. The uniquely human strength is arriving at these heuristic rules and principles which guide our behavior, which provide simplifications, which enable us to take vast amounts of information and parry it down to a few simple rules that effectively guide our behavior. Take that core insight from the discussion that Lex and I just had. It was a complex discussion. We both apologize for going a little bit overboard.
That was awesome.
Then dragging you into some details there, but take that away from it.
I love it.
It'll make you better at jiu-jitsu. Sorry, Lex.
That was a really exciting discussion, and the depths of knowledge in the dimensions of knowledge you have and interests you have is just fascinating. What are your expert opinions on the 3 laws of robotics from Isaac Asimov. That don't harm humans, obey orders, protect yourself. I mean, it's such a silly notion, but I speak to so many people these days, just regular folks, just, I don't know, my parents and so on, about robotics. And they kind of operate in that space of, imagining our future with robots and thinking, what are the ethical, how do we get that dance right? I know the 3 laws might be a silly notion, but do you think about like what universal reward functions there might be that we should enforce on the robots of the future, or is that a little too far out? And it doesn't, or is the mechanism that you just described? There shouldn't be 3 laws; it should be constantly adjusting, kind of thing.
I think it should constantly be adjusting, kind of thing. The issue with the laws is. I don't even, there are words and I have to write math and have to translate them into math. What does it mean to...
What does harm mean? What is...
obey.
It's not math.
Obey what, right? Because we just talked about how you try to say what you want, but you don't always get it right. And you want these machines to do what you want, not necessarily exactly what you literally... So you don't want them to take you literally. You want to take what you say and interpret it in context. And that's what we do with the specified rewards. We don't take them literally anymore from the designer. Not we as a community, we as, some members of my group. We and some of our collaborators like Peter Beal and Stuart Russell, we sort of say, okay, the designer specified this thing, but I'm going to interpret it not as this is the universal reward function that I shall always optimize, always and forever, but as this is good evidence about what the person wants. And I should interpret that evidence in the context of these situations that it was specified for. Because ultimately, that's what the designer thought about. That's what they had in mind. And really, them specifying a reward function that works for me in all these situations is really kind of telling me that whatever behavior that incentivizes must be good behavior with respect to the thing that I should actually be optimizing for. And so now the robot kind of has uncertainty about what it is that it should be, what its reward function is. And then there's all these additional signals we've been finding that it can kind of continually learn from and adapt its understanding of what people want. Every time the person corrects it, maybe they demonstrate, maybe they stop, hopefully not, right? One really, really crazy one is the environment itself. Like our world, you observe our world and the state of it, and it's not that you're seeing behavior and you're saying, oh, people are making decisions that are rational, blah, blah, blah. But our world is something that we've been acting with according to our preferences. Mm-hmm. So I have this example where like the robot walks into my home and my shoes are laid down on the floor kind of in a line, right? It took effort to do that. So even though the robot doesn't see me doing this, actually aligning the shoes, it should still be able to figure out that I want the shoes aligned, because there's no way for them to have magically, instantiated themselves in that way. Someone must have actually taken the time to do that. So it must be important.
So the environment actually
leaks information.
It leaks information. I mean, the environment is the way it is because humans somehow manipulated it. So you have to kind of reverse engineer the narrative that happened to create the environment as it is, and that leaks the preference information.
Yeah. And you have to be careful.
Yeah.
Right? Because people don't have the bandwidth to do everything. So just because, my house is messy doesn't mean that I want it to be messy, right? But that just because I didn't put the effort into that. I put the effort into something else. So the robot should figure out, well, that something else was more important, but it doesn't mean that, the house being messy is not. So it's a little subtle, but we really think of it, the state itself is kind of like a choice that people implicitly made about how they want their world.
When did you first fall in love with robotics?
I think it was a very gradual process. And it was somewhat accidental, actually, because I first started getting into programming when I was a kid, and then into math, and then I decided computer science was the thing I was going to do. And then in college, I got into AI. And then I applied to the Robotics Institute at Carnegie Mellon. And I was coming from this little school in Germany that nobody had heard of, but I had spent an exchange semester at Carnegie Mellon. So I had letters from Carnegie Mellon. So that was the only place, MIT said no, Berkeley said no, Stanford said no. That was the only place I got into. So I went there to the Robotics Institute. And I thought that robotics is a really cool way to actually apply the stuff that I knew and loved, like optimization. So that's how I got into robotics. I have a better story how I got into cars, which is I used to do mostly manipulation in my PhD, but now I do kind of a bit of everything application-wise, including cars. And I got into cars because I was here in Berkeley while I was a PhD student still for RSS 2014. Peter Beal organized it. And he arranged for, it was Google at the time, to give us rides in self-driving cars. And I was in a robot, and it was just making decision after decision the right call. And it was so amazing. So it was a whole different experience, right? Manipulation is so hard, you can't do anything. And there it was.
Was it the most magical robot you've ever met? So like, for me too, meeting Google's self-driving car for the first time was like a transformative moment. Like I had two moments like that and Spot Mini. I don't know if you met Spot Mini from Boston Dynamics. I felt like I fell in love or something. Like because I thought, like, I know how a Spot Mini works, right? It's just, there's nothing truly special. It's great engineering work, but the anthropomorphism that went on into my brain, like it came to life. Like it had a little arm, and it looked at me. She looked at me. I don't know. There's a magical connection there, and it made me realize, wow, robots can be so much more than things that manipulate objects. They can be things that have a human connection. Was the self-driving car the moment? Like, was there a robot that truly sort of inspired you?
I remember that experience very viscerally, riding in that car and being just wowed. I had they gave us a sticker that said I rode in a self-driving car, and it had this cute little firefly on.
Yes.
Or a logo or something.
Oh, that was like the smaller one, like the firefly.
Yeah, the really cute one. Yeah. And I put it on my laptop, and I had that for years until I finally changed my laptop out.
So, again, you kind of mentioned the Google self-driving car, but outside of that, what's like, who or what is your favorite robot, real or fictional, that like captivated your imagination throughout? I guess you kind of alluded to the Google self-driving. The Firefly was a magical moment, but is there something else?
It wasn't the Firefly in there. I think that was the Lexus, by the way. This was back then. But so good question. My favorite fictional robot is WALL-E. And I love how amazingly expressive it is. I'm a person who thinks a little bit about expressive motion kinds of things you were saying with you can do this and it's a head and it's the manipulator and what does it all mean. I like to think about that stuff. I love Pixar. I love animation. I love
WALL-E has two big eyes, I think, or no?
Yeah, it has these cameras and they move. So it goes woo, and then it's super cute. It's the way it moves is just so expressive. The timing of that motion, what it's doing with its arms and what it's doing with these lenses is amazing. And so I've really liked that from the start. And then on top of that, sometimes I share this. It's a personal story I share with people, or when I teach about AI or whatnot. My husband proposed to me by building a WALL-E, and he actuated it so it 7 degrees of freedom, including the lens thing, and it kind of came in, and he made it have like a the belly box opening thing. Nice. So it just did that, and then it spewed out this box made out of Legos that opened slowly, and then bam, right in it. It was quite quite, it set a bar.
That could be like the most impressive thing I've ever heard. Okay.
So I have a special connection to WALL-E. Long story short, I like WALL-E because I like animation and I like robots and I like, the fact that this was, we still have this robot to this day.
How hard is that problem, do you think, of the expressivity of robots? Like with the Boston Dynamics, I've never talked to those folks about this particular element. I've talked to them a lot, but it seems to be like almost an accidental side effect for them that they weren't. I don't know if they're faking it. They weren't trying to. Okay, they do say that the gripper it was not intended to be a face. I don't know if that's an honest statement, but I think they're legitimate.
It probably is.
But so do we automatically just anthropomorphize anything we can see about a robot? So like the question is, how hard is it to create a WALL-E type robot that connects so deeply with us humans? What do you think?
It's really hard, right? So it depends on what setting. So if you want to do it in this very particular narrow setting where it does only one thing and it's expressive, then you can get an animator. You can have Pixar on call come in, design some trajectories. There was Anki had a robot called Cosmo where they put in some of these animations. That part is easy, right? The hard part is doing it not via these kind of handcrafted behaviors, but doing it generally autonomously. Like I want robots. I don't work on, just to clarify, I used to work a lot on this. I don't work on that quite as much these days, but have the notion of having robots that, when they pick something up and put it in a place, they can do that with various forms of style, or you can say, well, this robot is, succeeding at this task and is confident versus it's hesitant versus, maybe it's happy or it's, disappointed about some failure that it had. Or I think that when robots move, they can communicate so much about internal states or perceived internal states that they have. And, I think that's really useful and an element that we'll want in the future, because I was reading this article about how kids are being rude to Alexa because they can be rude to it and it doesn't really get angry, right? It doesn't reply in any way. It just says the same thing. So I think there's, at least for the correct development of children. It's important that these things, you kind of react differently. I also think, you walk in your home and you have a personal robot. And if you're really pissed, presumably the robot should kind of behave slightly differently than when you're super happy and excited. But it's really hard because I don't know, the way I would think about it and the way I thought about it when it came to expressing goals or intentions for robots, what's really happening is that instead of doing robotics where you have your state and you have your action space and you have your space, the reward function that you're trying to optimize, now you kind of have to expand the notion of state to include this human internal state. What is the person actually perceiving? What do they think about the robots, something or rather? And then you have to optimize in that system. And so that means you have to understand how your motion, your actions end up sort of influencing the observer's kind of perception of you. And it's very hard to write math about that.
Right. So when you start to think about incorporating the human into the state model, apologize for the philosophical question, but how complicated are human beings, do you think? Like, can they be reduced to a kind of almost like an object that moves and maybe has some basic intents? Or is there something, do we have to model things like mood and general aggressiveness and all these kinds of human qualities, or like game theoretic qualities? Like, what's your sense?
How complicated is?
How hard is the problem of human-robot interaction?
Yeah. Should we talk about what the problem of human-robot interaction is?
Yeah, what is human-robot interaction?
And then talk about how that, yeah. So and by the way, I'm going to talk about this very particular view of human-robot interaction, right? Which is not so much on the social side or on the side of how do you have a good conversation with the robot? What should the robot's appearance be? It turns out that if you make robots taller versus shorter, this has an effect on how people act with them. So I'm not talking about that. Yeah. But I'm talking about this very kind of narrow thing, which is if you want to take a task that a robot can do in isolation, in a lab out there in the world, but in isolation. And now you're asking, what does it mean for the robot to be able to do this task for presumably what its actual end goal is, which is to help some person? Mm-hmm. That ends up changing the problem in two ways. The first way it changes the problem is that the robot is no longer the single agent acting. That you have humans who also take actions in that same space. Cars navigate around people, robots around an office, navigate around the people in that office. If I send the robot over there in the cafeteria to get me a coffee, then there's probably other people reaching for stuff in the same space. And so now you have your robot and you're in charge of the actions that the robot is taking. Then you have these people who are also making decisions and taking actions in that same space. And even if, the robot knows what it should do and all of that, just coexisting with these people, right? Kind of getting the actions to gel well, to mesh well together. That's sort of the kind of problem number one. And then there's problem number two, which goes back to this notion of, if I'm a programmer, I can specify some objective for the robot to go off and optimize. I can specify the task. But if I put the robot in your home, presumably you might have your own opinions about, well, okay, I want my house clean, but how do I want it cleaned? And how should the robot move? How close to me it should come and all of that. And so I think those are the two differences that you have. You're acting around people, and what you should be optimizing for should satisfy the preferences of that end user, not of your programmer who programmed you.
Yeah, and the preferences thing is tricky. So figuring out those preferences, be able to interactively adjust, to understand what the human is doing. So it really boils down to understand the humans in order to interact with them and in order to please them.
Right.
So why is this hard?
Why is understanding humans hard?
Yeah.
So I think there's two tasks about understanding humans that in my mind are very, very similar, but not everyone agrees. So there's the task of being able to just anticipate what people will do. We all know that cars need to do this, right? We all know that, well, if I navigate around some people, the robot has to get some notion of, okay, where is this person going to be? So that's kind of the prediction side. And then there's what you were saying, satisfying the preferences, right? So adapting to the person's preferences, knowing what to optimize for, which is more this inference side, what does this person want? What is their intent? What are their preferences? And to me, those kind of go together, because I think that at the very least, if you can look at human behavior and understand what it is that they want, then that's sort of the key enabler to being able to anticipate what they'll do in the future. Because I think that, we're not arbitrary. We make these decisions that we make. We act in the way we do because we're trying to achieve certain things. Mm-hmm. And so I think that's the relationship between them. Now, how complicated do these models need to be in order to be able to understand what people want? So we've gotten a long way in robotics with something called inverse reinforcement learning, which is the notion of someone acts, demonstrates how they want the thing done.
What is inverse reinforcement learning? You just briefly said it.
Right. So it's the problem of take human behavior and infer reward function from this. So figure out what it is that behavior is optimal with respect to. And it's a great way to think about learning human preferences in the sense of, you have a car and the person can drive it, and then you can say, well, okay, I can actually learn what the person is optimizing for. I can learn their driving style, or you can have people demonstrate how they want the house clean, and then you can say, okay, this is I'm getting the trade-offs that they're making. I'm getting the preferences that they want out of this. And so we've been successful in robotics somewhat with this, and it's based on a very simple model of human behavior. It's remarkably simple, which is that human behavior is optimal with respect to whatever it is that people want, right? So you make that assumption, and now you can kind of inverse through. That's why it's called inverse, well, really optimal control, but also inverse reinforcement learning. So this is based on utility maximization in economics, right? So back in the 40s, von Neumann Morgenstern were like, okay, people are making choices by maximizing utility, go. And then in the late 50s, we had Luce and Shepard come in and say, people are a little bit noisy and approximate in that process. So they might choose something kind of stochastically with probability proportional to how much utility something has. So there's a bit of noise in there. This has translated into robotics and something that we call Boltzmann rationality. So it's a kind of an evolution of inverse reinforcement learning that accounts for human noise. And we've had some success with that too for these tasks where it turns out people act noisily enough that you can't just do the vanilla version. You can account for noise and still infer what they seem to want based on this. Then now we're hitting tasks where that's not enough. And
what are examples of spatial tasks?
So imagine you're trying to control some robot that's fairly complicated. You're trying to control a robot arm because maybe you're a patient with a motor impairment and you have this wheelchair-mounted arm and you're trying to control it around. Or one task that we've looked at with Sergey is, and our student Sid, is a lunar lander. So I don't know if you know this Atari game. It's called Lunar Lander. It's really hard. People really suck at landing the thing. Mostly they just crash it left and right. Okay, so this is the kind of task where imagine you're trying to provide some assistance to a person operating such a robot where you want the autonomy to kick in, figure out what it is that you're trying to do and help you do it. It's really hard to do that for, say, Lunar Lander because people are all over the place. And so they seem much more noisy than really rational. That's an example of a task where these models are kind of failing us. And it's not surprising because, so we talked about the 40s, utility, late 50s, sort of noisy. Then the 70s came and behavioral economics started being a thing where people are like, no. People are not rational. People are messy and emotional and irrational and have all sorts of heuristics that might be domain specific, and they're just a mess.
It's a mess.
So what does my robot do to understand what you want? And it's very that's why it's complicated. It's for the most part we get away with pretty simple models until we don't, and then the question is, what do you do then? I had days when I wanted to, pack my bags and go home and switch jobs because it feels really daunting to make sense of human behavior enough that you can reliably understand what people want, especially as, robot capabilities will continue to get developed. You'll get these systems that are more and more capable of all sorts of things. And then you really want to make sure that you're telling them the right thing to do. What is that thing? Well, read it in human behavior.
So if I just sat here quietly and tried to understand something about you by listening to you talk, it would be harder than if I got to say something and ask you and interact and control. Can the robot help its understanding of the human by influencing the behavior by actually acting?
Yeah, absolutely. So one of the things that's been exciting to me lately is this notion that when you try to think of the robotics problem as, okay, I have a robot and it needs to optimize for whatever it is that a person wants it to optimize, as opposed to maybe what a programmer said, that problem we think of as a human-robot collaboration problem in which both agents get to act, in which the robot knows less than the human, because the human actually has access to, at least implicitly, to what it is that they want. They can't write it down, but they can talk about it. They can give all sorts of signals. They can demonstrate. But the robot doesn't need to sit there and passively observe human behavior and try to make sense of it. The robot can act too. And so there's these information gathering actions that the robot can take to sort of solicit responses that are actually informative. So for instance, this is not for the purpose of assisting people, but with kind of back to coordinating with people in cars and all of that. One thing that Dorsa did was, so we were looking at cars being able to navigate around people, and you might not know exactly the driving style of a particular individual that's next to you, but you want to change lanes in front of them.
Navigating around other humans inside cars?
Yeah, good clarification question. So if you have an autonomous car and it's trying to navigate the road around human-driven vehicles. Similar things, ideas apply to pedestrians as well, but let's just take human-driven vehicles. So now you're trying to change a lane. Well, you could be trying to infer this driving style of this person next to you. You'd like to know if they're sort of aggressive or defensive, if they're going to let you kind of go in or if they're going to not.
Right.
And it's very difficult to just, if you think that if you want to hedge your bets and say, maybe they're actually pretty aggressive, I shouldn't try this, you kind of end up driving next to them. Right? And then you don't know, because you're not actually getting the observations that you get. The way someone drives when they're next to you, and they just need to go straight, is kind of the same, regardless if they're aggressive or defensive. And so you need to enable the robot to reason about how it might actually be able to gather information by changing the actions that it's taking. And then the robot comes up with these cool things where it kind of nudges towards you and then sees if you're gonna slow down or not. And if you slow down, it sort of updates its model of you and says, oh, okay, you're more on the defensive side. So now I can actually link.
That's a fascinating dance. That's so cool that you could sort of use your own actions to gather information. That feels like a totally open, exciting new world of robotics. I mean, how many people are even thinking about that kind of thing?
A handful of us, I'd say.
Yes, it's rare because it's actually leveraging human. I mean, most roboticists I've talked to a lot of colleagues and so on are kind of, for being honest, kind of afraid of humans
because they're messy and complicated,
yeah, exactly.
Right? I understand. Going back to what we were talking about earlier, right now we're kind of in this dilemma of, okay, there are tasks that we can just assume people are approximately rational for, and we can figure out what they want. We can figure out their goals. We can figure out their driving styles, whatever. Cool. There are these tasks that we can't. So what do, right? Do we pack our bags and go home? And I've had a little bit of hope recently. And I'm kind of doubting myself because what do I know that, 50 years of behavioral economics hasn't figured out. But maybe it's not really in contradiction with the way that field is headed. But basically one thing that we've been thinking about is, instead of kind of giving up and saying people are too crazy and irrational for us to make sense of them, maybe we can give them a bit the benefit of the doubt. And maybe we can think of them as actually being relatively rational, but just under different assumptions about the world, about how the world works, about, they don't have, when we think about rationality, implicit assumption is, they're rational under all the same assumptions and constraints as the robot, right? If this is the state of the world, that's what they know. This is the transition function, that's what they know. This is the horizon, that's what they know. But maybe kind of this difference, the reason they can seem a little messy and hectic, especially to robots, is that perhaps they just make different assumptions or have different beliefs.
Yeah.
So
I mean, that's another fascinating idea, that our kind of anecdotal desire to say that humans are irrational, perhaps grounded in behavioral economics, is that we just don't understand the constraints and the rewards under which they operate. And so our goal shouldn't be to throw our hands up and say they're irrational. It's to say, let's try to understand what are the constraints
what it is that they must be assuming that makes this behavior make sense.
That's
good
brilliant.
Life lesson, right? Good life lesson.
Yeah, it's true. It's just outside of robotics. That's just good that's communicating with humans. That's just a good assume that you just don't sort of empathy, right? It's
maybe there's something you're missing, and it's it especially happens to robots because they're kind of dumb and they don't know things, and oftentimes people are sort of supra rational and that they actually know a lot of things that robots don't. Sometimes, like with the lunar lander, the robot knows much more. So it turns out that if you try to say, look, maybe people are operating this thing, but assuming a much more simplified physics model, because they don't get the complexity of this kind of craft or the robot arm with 7 degrees of freedom with these inertias and whatever. So maybe they have this intuitive physics model, which is not, this notion of intuitive physics is something that is studied actually in cognitive science, folks like Josh Tenenbaum, Tom Griffith's work on this stuff. And what we found is that you can actually try to figure out what physics model kind of best explains human actions. And then you can use that to sort of correct what it is that they're commanding the craft to do. So they might, be sending the craft somewhere, but instead of executing that action, you can sort of take a step back and say, according to their intuitive, if the world worked according to their intuitive physics model, where do they think that the craft is going? Where are they trying to send it to? And then you can use the real physics, right? The inverse of that to actually figure out what you should do so that you do that instead of where they were actually sending you in the real world. And I kid you not, it worked. People land the damn thing in, in between the two flags and all that. So it's not conclusive in any way, but I'd say it's evidence that, maybe we're kind of underestimating humans in some ways when we're giving up and saying, they're just crazy noisy.
So then you try to explicitly model the kind of worldview that they have. That's right. And it's not too. There's things in behavioral economics too that for instance have touched upon the planning horizon. So there's this idea that there's bounded rationality essentially, right. And the idea that maybe we work under computational constraints. And I think kind of our view recently has been take the Bellman update in AI and just break it in all sorts of ways by saying state, no, the person doesn't get to see the real state. Maybe they're estimating somehow. Transition function, no. Even the actual reward evaluation, maybe they're still learning about what it is that they want. Like when you watch Netflix and you have all the things and then you have to pick something. Imagine that, the AI system interpreted that choice as this is the thing you prefer to see. Like, how are you going to know? You're still trying to figure out what you like, what you don't like, etc. So I think it's important to also account for that. So it's not irrationality, per se. They're doing the right thing under the things that they know. Yeah, that's brilliant. What do you think about robot? Would you ever buy a robot for your home?
Yes. What will it do?
I'll be a companion, a friend.
Oh, yeah. I would like to start replacing friends and family with robots immediately.
Okay.
Truly. I'm not even kidding. Like, I would like to have a Thanksgiving with 4 robots. I'm dead serious.
Well,
are they into QAnon? Like, when do the robots start going crazy? That's my question is like, how long do the robots live with me before they are also a problem and I got to replace them? You know what I mean?
You're going to indoctrinate the robot.
Yeah, the robot's going to call me like my aunt does and talk about coronavirus for an hour every morning and tell me everyone in America who's died of coronavirus.
One of the things I enjoy in life is how terrified people like you, I'm a huge fan, by the way, get of robots.
Well, I'm concerned about AI, like completely getting rid of the need for human beings, because human beings, you go out in the street and you go, so few of these people are necessary. Even now you look at people and you go, they're hanging on by a thread, right? Yeah. And you can just imagine how many jobs are going to get replaced, how many industries are going to be completely remade with AI, and the pace of change worries me a little bit because we do a very bad job in this country of mitigation. When we have problems, we don't do a great job. We did not a great job with COVID, right? We don't do a good job. It's just something we don't do well. We're good in booms and busts. We're good when it's good. And we kind of know how to hey, we're bottomed out. We're like a gambling addict in this country. We know what it feels like to be outside of an OTB at 9 a.m. drinking coffee and smoking cigarettes, going, I'm going to build it back. And we know what it's like to win. But anything in between, it seems not that great. So to me, it feels like, are we going to be able to like help people that are displaced and that have their jobs taken by? I mean, do you not fear sort of a world where you have a lot of artificial intelligence replacing workers, and then what happens?
There's a lot of fears around artificial intelligence. One of them is, yes, displacement of jobs, workers. That's technology in general. That's just any kind of new innovations displace jobs. I'm less worried about that. I'm more worried about other impacts of artificial intelligence. For example, the nature of our discourse, like the effects of algorithms on the way we communicate with each other, the spread of information, what that information looks like, the creation of silos, all that kind of stuff. I think that would just make worse the effects that the displacement of jobs has. I think ultimately, I have a hope that technology creates more opportunities than it destroys.
I hope so too.
And so in that sense, AI to me is an exciting possibility, but
significant.
Yeah. So let's step back at a high level view, the impossible question of what kind of, as an overview, what kind of autonomous flying vehicles are there in general?
I think the ones that receive a lot of notoriety are obviously the military vehicles. Military vehicles are controlled by a base station, but have a lot of human supervision, but have limited autonomy, which is the ability to go from point A to point B. And even the more sophisticated vehicles can do autonomous takeoff and landing.
And those usually have wings, and they're heavy. And
usually they're wings, but there's nothing preventing us from doing this for helicopters as well. There are many military organizations that have autonomous helicopters in the same vein. And by the way, you look at autopilots in airplanes, and it's actually very similar. In fact, one interesting question we can ask is, if you look at all the air safety violations, all the crashes that occurred, would they have happened if the plane were truly autonomous? And I think you'll find that in many of the cases, because of pilot error, we make silly decisions. And so in some sense, even in air traffic, commercial air traffic, there's a lot of applications, although we only see autonomy being enabled at very high altitudes when the pilot the plane is on autopilot.
There's still a role for the human, and that kind of autonomy is you're kind of implying. I don't know what the right word is, but it's a little dumber than it could be.
Right. So in the lab, of course, we can afford to be a lot more aggressive, right. And the question we try to ask is, can we make robots that will be able to make decisions without any kind of external infrastructure?
Right.
So what does that mean? So the most common piece of infrastructure that airplanes use today is GPS. GPS is also the most brittle form of information. If you've driven in a city, try to use GPS navigation, in tall buildings, you immediately lose GPS. And so that's not a very sophisticated way of building autonomy. I think the second piece of infrastructure they rely on is communications. Again, it's very easy to jam communications. In fact, if you use Wi-Fi, you know that Wi-Fi signals drop out, cell signals drop out. So to rely on something like that is not good. The third form of infrastructure we use, and I hate to call it infrastructure, but it is that in the sense of robots, it's people. So you could rely on somebody to pilot you.
Right.
And so the question you want to ask is, if there are no pilots, if there's no communications with any base station, if there's no knowledge of position, and if there's no a priori map, a priori knowledge of what the environment looks like, a priori model of what might happen in the future, can robots navigate? So that is true autonomy.
Right. So that's true autonomy. And we're talking about, you mentioned like military application of drones.
Okay, so what else is there? You talk about agile, autonomous flying robots, aerial robots. So that's a different kind of, it's not winged, it's not big, at least it's small.
So I use the word agility mostly, or at least we're motivated to do agile robots, mostly because robots can operate and should be operating in constrained environments. And if you want to operate the way a global hawk operates, I mean, the kinds of conditions in which you operate are very, very restrictive. If you want to go inside a building, for example, for search and rescue, or to locate an active shooter, or you want to navigate under the canopy in an orchard to look at health of plants, or to count fruits, to measure the tree trunks. These are things we do, by the way.
Yeah, some cool agriculture stuff you've shown in the past. It's really awesome.
Right. So in those kinds of settings, you do need that agility. Agility does not necessarily mean you break records for the 100 meters dash. What it really means is you see the unexpected and you're able to maneuver in a safe way, and in a way that gets you the most information about the thing you're trying to do. Trajectory.
So there's a lot of excitement and progress in the field of machine learning.
Yes.
And reinforcement learning, and the neural network variant of that with deep reinforcement learning. Do you see a role of machine learning in... So a lot of the success with flying robots did not rely on machine learning, except for maybe a little bit of the perception, the computer vision side. On the control side and the planning, do you see there's a role in the future for machine learning?
So let me disagree a little bit with you. I think we never perhaps called out learning, but even this very simple idea of being able to fly through a constrained space. The first time you try it, you might get it wrong if the task is challenging. And the reason is, to get it perfectly right, you have to model everything in the environment.
Right.
And flying is notoriously hard to model. There are aerodynamic effects that we constantly discover. Even just before I was talking to you, I was talking to a student about how blades flap when they fly.
Wow.
And that ends up changing how a rotorcraft is accelerated in the angular direction.
There's these like micro flaps or something.
It's not micro flaps. So we assume that each blade is rigid, but actually it flaps a little bit.
Oh.
It bends.
Interesting, yeah.
And so the models rely on the fact, on an assumption that they're actually rigid, but that's not true. If you're flying really quickly, these effects become significant. If you're flying close to the ground, you get pushed off by the ground. Right? Something which every pilot knows when he tries to land or she tries to land. This is called a ground effect. Something very few pilots think about is what happens when you go close to a ceiling. Well, you get sucked into a ceiling. There are very few aircraft that fly close to any kind of ceiling. Likewise, when you go close to a wall, there are these wall effects. And if you've gone on a train and you pass another train that's traveling in the opposite direction, you feel the buffeting. And so these kinds of microclimates affect our UAVs significantly.
And they're impossible to model, essentially.
I wouldn't say they're impossible to model, but the level of sophistication you would need in the model and the software would be tremendous. Plus, to get everything right would be awfully tedious. So the way we do this is, over time, we figure out how to adapt to these conditions. So early on, we used a form of learning that we call iterative learning. So this idea, if you want to perform a task, there are a few things that you need to change and iterate over, a few parameters that over time you can figure out. So I could call it policy gradient reinforcement learning, but actually it was just iterative learning.
Iterative learning.
And so this was there way back. I think what's interesting is, if you look at autonomous vehicles today, learning could occur in two pieces. One is perception, understanding the world. Second is action, taking actions. Everything that I've seen that is successful is on the perception side of things. So in computer vision, we've made amazing strides in the last 10 years. So recognizing objects, actually detecting objects, classifying them, and tagging them in some sense, annotating them. This is all done through machine learning. On the action side, on the other hand, I don't know of any examples where there are fielded systems where we actually learn the right behavior.
Outside of single demonstrations successfully.
In the laboratory, this is the holy grail. Can you do end-to-end learning? Can you go from pixels to motor currents? This is really, really hard. And I think if you go forward, the right way to think about these things is data-driven approaches, learning-based approaches, in concert with model-based approaches, which is the traditional way of doing things.
Right.
So I think there's a role for each of these methodologies.
So what do you think? Do you think it's possible for robots and humans to collaborate successfully on tasks? So a lot of robotics folks that I talk to and work with, I mean, humans just add a giant mess to the picture. So it's best to remove them from consideration when solving specific tasks. It's very difficult to model. There's just a source of uncertainty. In your work with these agile flying robots, do you think there's a role for collaboration with humans, or is it best to model tasks in a way that doesn't have a human in the picture?
Well, I don't think we should ever think about robots without human in the picture. Ultimately, robots are there because we want them to solve problems for humans.
Right.
But there's no general solution to this problem. I think if you look at human interaction and how humans interact with robots, we think of these in sort of three different ways. One is the human commanding the robot. The second is the human collaborating with the robot. So, for example, we work on how a robot can actually pick up things with a human and carry things. That's like true collaboration. And third, we think about humans as bystanders. Self-driving cars, what's the human's role, and how do self-driving cars acknowledge the presence of humans? So I think all of these things are different scenarios. It depends on what kind of humans, what kind of task. And I think it's very difficult to say that there's a general theory that we all have for this. But at the same time, it's also silly to say that we should think about robots independent of humans. So to me, human-robot interaction is almost a mandatory aspect of everything we do.
Yes. So, but to which degree? So what your thoughts, if we jump to autonomous vehicles, for example, there's a big debate between what's called level 2 and level 4. So semi-autonomous and autonomous vehicles. And sort of the Tesla approach currently, at least, has a lot of collaboration between human and machine. So the human is supposed to actively supervise the operation of the robot. Part of the safety definition of how safe a robot is in that case is how effective is the human in monitoring it. Do you think that's ultimately not a good approach in sort of having a human in the picture, not as a bystander or part of the infrastructure, but really as part of what's required to make the system safe?
This is harder than it sounds.
Right.
I think, I'm sure you've driven before in highways and so on. It's really very hard to relinquish control to a machine and then take over when needed. So I think Tesla's approach is interesting because it allows you to periodically establish some kind of contact with the car. Toyota, on the other hand, is thinking about shared autonomy or collaborative autonomy as a paradigm. If I may argue, these are very, very simple ways of human-robot collaboration because the task is pretty boring. You sit in a vehicle, you go from point A to point B. I think the more interesting thing to me is, for example, search and rescue. I've got a human first responder, robot first responders. I got to do something. It's important. I have to do it in 2 minutes. The building is burning. There's been an explosion. It's collapsed. How do I do it? I think to me, those are the interesting things where it's very, very unstructured. And what's the role of the human? What's the role of the robot? Clearly, there's lots of interesting challenges, and as a field, I think we're going to make a lot of progress in this area.
Yeah, it's an exciting form of collaboration. You're right. In autonomous driving, the main enemy is just boredom of the human.
Yes.
As opposed to in rescue operations, it's literally life and death, and the collaboration enables the effective completion of the mission. So it's exciting.
In some sense, we're also doing this. You think about the human driving a car, and almost invariably, the human's trying to estimate the state of the car, they estimate the state of the environment, and so on. But what if the car were to estimate the state of the human? Mm-hmm. So, for example, I'm sure you have a smartphone, and the smartphone tries to figure out what you're doing and send you reminders, and oftentimes telling you to drive to a certain place, although you have no intention of going there, because it thinks that that's where you should be, because of some Gmail calendar entry, or something like that. And it's trying to constantly figure out who you are, what you're doing. If a car were to do that, maybe that would make the driver safer, because the car is trying to figure out, is the driver paying attention, looking at his or her eyes, looking at saccadic movements. So I think the potential is there, but from the reverse side, it's not robot modeling, but it's human modeling.
It's more on the human, right?
And I think the robots can do a very good job of modeling humans if you really think about the framework that you have a human sitting in a cockpit surrounded by sensors all staring at him, in addition to be staring outside, but also staring at him. I think there's a real synergy there.
Yeah, I love that problem, because it's a new 21st century form of psychology, actually. AI-enabled psychology. But by the way, you said UAV, unmanned aerial vehicle. But what's a good term for drones, UAVs, quadcopters? Is there a term that's being standardized?
I don't know if there is. Everybody wants to use the word drones. And I've often said this, drones to me is a pejorative word. It signifies something that's dumb, that's pre-programmed, that does one little thing, and robots are anything but drones. So I actually don't like that word, but that's what everybody uses. You could call it unpiloted.
Unpiloted.
But even unpiloted could be radio controlled, could be remotely controlled in many different ways. And I think the right word is thinking about it as an aerial robot.
You also say agile, autonomous aerial robot, right?
Yeah, so agility is an attribute, but they don't have to be.
What are the biggest open problems in robotics in your view? You said we're in the early days in some sense. What are the problems we would like to solve in robotics?
I think there are lots of problems, right? But I would phrase it in the following way. If you look at the robots we're building, they're still very much tailored towards doing specific tasks in specific settings. Mm-hmm. I think the question of how do you get them to operate in much broader settings where things can change in unstructured environments is up in the air. So, think of self-driving cars. Today, we can build a self-driving car in a parking lot. We can do level 5 autonomy in a parking lot. But can you do level 5 autonomy in the streets of Napoli in Italy or Mumbai in India? Right. No. So in some sense, when we think about robotics, we have to think about where they're functioning, what kind of environment, what kind of a task. We have no understanding of how to put both those things together.
So we're in the very early days of applying it to the physical world. And I was just in Naples, actually. And there's levels of difficulty and complexity depending on which area you're applying it to.
I think so. And we don't have a systematic way of understanding that.
Right.
Everybody says just because a computer can now beat a human at any board game, we suddenly know something about intelligence. That's not true. A computer board game is very, very structured. It is the equivalent of working in a Henry Ford factory, where parts come, you assemble, move on. It's a very, very, very structured setting. That's the easiest thing, and we know how to do that.
So you've done a lot of incredible work at the UPenn, University of Pennsylvania Grasp Lab. You're now Dean of Engineering at UPenn. What advice do you have for a new, bright-eyed undergrad interested in robotics or AI or engineering?
Well, I think there's really three things. One is, One is you have to get used to the idea that the world will not be the same in 5 years or 4 years whenever you graduate, right? Which is really hard to do. So this thing about predicting the future, every one of us needs to be trying to predict the future always. Not because you'll be any good at it, but by thinking about it, I think you sharpen your senses and you become smarter. So that's number one. Number two, and it's a corollary of the first piece, which is you really don't know what's going to be important. So this idea that I'm going to specialize in something which will allow me to go in a particular direction, it may be interesting, but it's important also to have this breadth so you have this jumping off point. I think the third thing, and this is where I think Penn excels, I mean, we teach engineering, but it's always in the context of the liberal arts. It's always in the context of society. As engineers, we cannot afford to lose sight of that. So I think that's important. But I think one thing that people underestimate when they do robotics is the importance of mathematical foundations, the importance of representations. Not everything can just be solved by looking for ROS packages on the internet or to find a deep neural network that works. I think the representation question is key, even to machine learning, where if you ever hope to achieve or get to explainable AI, somehow there need to be representations that you can understand.
So if you want to do robotics, you should also do mathematics. And you said liberal arts, a little literature. If you want to build a robot, you should be reading Dostoevsky. I agree with that.
Very good.
So Vijay, thank you so much for talking today. It was an honor.
Thank you. It was just a very exciting conversation. Thank you. Was a problem.
Do you see a time in the future where you mentioned there's agriculture applications, so there's a lot of applications of flying robots, but do you see a time in the future where there's tens of thousands or maybe hundreds of thousands of delivery drones that fill the sky, delivery flying robots?
I think there's a lot of potential for the last mile delivery. And so in crowded cities, I don't know if you go to a place like Hong Kong, just crossing the river can take half an hour, and while a drone can just do it in 5 minutes at most. I think you look at delivery of supplies to remote villages. I work with a nonprofit called We Robotics. So they work in the Peruvian Amazon, where the only highways are rivers, and to get from point A to point B may take 5 hours, while with a drone, you can get there in 30 minutes. So just delivering drugs, retrieving samples for testing vaccines, I think there's huge potential here. So I think the challenges are not technological, the challenges are economical.
A lot of people have sci-fi inspired fears of walking robots like those from Boston Dynamics. If you just look at shows on Netflix and so on, or flying robots like those you work with, how do you think about those fears? How would you alleviate those fears? Do you have inklings, echoes of those same concerns?
Anytime we develop a technology meaning to have positive impact in the world, there's always the worry that somebody could subvert those technologies and use it in an adversarial setting. And robotics is no exception, right? So I think it's very easy to weaponize robots. I think we talk about swarms. One thing I worry a lot about is, for us to get swarms to work and do something reliably, it's really hard. But suppose I have this challenge of trying to destroy something, and I have a swarm of robots. Well, only one out of the swarm needs to get to its destination. So that suddenly becomes a lot more doable. And so I worry about, this general idea of using autonomy with lots and lots of agents. I mean, having said that, look, a lot of this technology is not very mature. My favorite saying is that if somebody had to develop this technology Wouldn't you rather the good guys do it? So the good guys have a good understanding of the technology so they can figure out how this technology is being used in a bad way or could be used in a bad way and try to defend against it. So we think a lot about that. So we're doing research on how to defend against swarms, for example.
That's interesting.
There's in fact a report by the National Academies on counter UAS technologies. This is a real threat. But we're also thinking about how to defend against this and knowing how swarms work, knowing how autonomy works is, I think, very important.
So it's not just politicians. You think engineers have a role in this discussion?
Absolutely. I think the days where politicians can be agnostic to technology are gone. I think every politician needs to be literate in technology. And I often say technology is the new liberal art. Mm-hmm. Understanding how technology will change your life, I think, is important. And every human being needs to understand that.
And maybe we can elect some engineers to office as well on the other side. Simply, what does it take to make a thing with 4 motors fly, a quadcopter, one of these little flying robots? How hard is it to make it fly? How do you coordinate the 4 motors? How do you convert those motors into actual movement?
So this is an interesting question. We've been trying to do this since 2000. It is a commentary on the sensors that were available back then, the computers that were available back then. And a number of things happened between 2000 and 2007. One is the advances in computing, and so we all know about Moore's Law, but I think 2007 was a tipping point, the year of the iPhone, the year of the cloud. Lots of things happened in 2007. But going back even further, inertial measurement units as a sensor really matured. Again, lots of reasons for that. Certainly there's a lot of federal funding, particularly DARPA in the US, but they didn't anticipate this boom in IMUs. Mm-hmm. But if you look subsequently, what happened is that every car manufacturer had to put an airbag in, which meant you had to have an accelerometer on board. And so that drove down the price to performance ratio of these sensors.
I should know this. That's very interesting.
Yeah.
That's very interesting, the connection there.
And that's why research is it's very hard to predict the outcomes. Mm-hmm. And again, the federal government spent a ton of money on things that they thought were useful for resonators, but it ended up enabling these small UAVs, which is great because I could have never raised that much money and sold this project. Hey, we want to build these small UAVs. Can you actually fund the development of low cost IMUs?
So why do you need an IMU on it?
I'll come back to that. But so in 2007, 2008, we were able to build these, and then the question you're asking was a good one. How do you coordinate the motors to develop this? But over the last 10 years, everything is commoditized. A high school kid today can pick up a Raspberry Pi kit and build this. All the low-level functionality is all automated. But basically, at some level, you have to drive the motors at the right RPMs, the right velocity, in order to generate the right amount of thrust, in order to position it and orient it in a way that you need to in order to fly. The feedback that you get is from onboard sensors, and the IMU is an important part of it. The IMU tells you what the acceleration is, as well as what the angular velocity is. And those are important pieces of information. In addition to that, you need some kind of local position or velocity information. For example, when we walk, we implicitly have this information because we kind of know what our stride length is. We also are looking at images fly past our retina, if you will, and so we can estimate velocity. We also have accelerometers in our head, and we're able to integrate all these pieces of information to determine where we are as we walk. And so robots have to do something very similar. You need an IMU, you need some kind of a camera or other sensor that's measuring velocity, And then you need some kind of a global reference frame if you really want to think about doing something in a world coordinate system. And so how do you estimate your position with respect to that global reference frame? That's important as well.
So coordinating the RPMs of the four motors is what allows you to, first of all, fly and hover, and then you can change the orientation and the velocity of and so on.
Exactly.
It's just a bunch of degrees of freedom that you're playing with.
There's 6 degrees of freedom, but you only have 4 inputs, the 4 motors.
Right.
And it turns out to be a remarkably versatile configuration. You think at first, well, I only have 4 motors. How do I go sideways? But it's not too hard to say, well, if I tilt myself, I can go sideways. And then you have 4 motors pointing up. How do I rotate in place about a vertical axis? Well, you rotate them at different speeds, and that generates reaction moments, and that allows you to turn. So it's actually it's an optimal configuration from an engineer standpoint. It's very simple, very cleverly done, and very versatile.
So if you could step back to a time, so I've always known flying robots as, to me, it was natural that the quadcopter should fly. But when you first started working with it, how surprised are you that you can do so much with the 4 motors? How surprising is that you can make this thing fly, first of all, that you can make it hover, then you can add control to it?
Firstly, the 4 motor configuration is not ours. Right. It has at least 100-year history. And various people try to get quadrotors to fly without much success. As I said, we've been working on this since 2000. Our first designs were, well, this is way too complicated. Why not we try to get an omnidirectional flying robot? So some of our early designs, we had 8 rotors. And so these 8 rotors were arranged uniformly on a sphere, if you will. So you can imagine a symmetric configuration. And so you should be able to fly anywhere. But the real challenge we had is the strength to weight ratio is not enough. And of course, we didn't have the sensors and so on. So everybody knew, or at least the people who worked with rotorcrafts knew, 4 rotors will get it done. So that was not our idea. But it took a while before we could actually do the onboard sensing and the computation that was needed for the kinds of agile maneuvering that we wanted to do in our little aerial robots. And that only happened between 2007 and 2009 in our lab.
Yeah. And what is the first robot you've ever built or were a part of building?
Way back when I was in graduate school, I was part of a fairly big project that involved building a very large hexapod. This weighed close to 7,000 pounds. And it was powered by hydraulic actuation, or was actuated by hydraulics, with 18 motors, hydraulic motors, each controlled by an Intel 8085 processor and an Intel 8086 coprocessor. And so imagine this huge monster that had 18 joints, each controlled by an independent computer. And there was a 19th computer that actually did the coordination between these 18 joints. So I was part of this project, and my thesis work was, how do you coordinate the 18 legs? And in particular, the pressures in the hydraulic cylinders to get efficient locomotion.
It sounds like a giant mess. So how difficult is it to make all the motors communicate? Presumably you have to send signals hundreds of times a second, or at least...
So this was not my work, but the folks who worked on this wrote what I believe to be the first multiprocessor operating system. This was in the 80s. And you had to make sure that obviously messages got across from one joint to another. You have to remember the clock speeds on those computers were about 0.5 megahertz.
Right.
So
the 80s. So not to romanticize the notion, but how did it make you feel to see that robot move?
It was amazing. In hindsight, it looks like, well, we built this thing which really should have been much smaller. And of course, today's robots are much smaller. You look at, Boston Dynamics or Ghost Robotics, a spinoff from Penn. But back then, you were stuck with the substrate you had, the compute you had, so things were unnecessarily big. But at the same time, and this is just human psychology, somehow bigger means grander. People never have the same appreciation for nanotechnology or nano devices as they do for the space shuttle or the Boeing 747.
Yeah, you've actually done quite a good job at illustrating that small is beautiful in terms of robotics. So what biological system, because you've also drawn a lot of inspiration from those. I've seen bees and ants that you've talked about. What living creatures have you found to be most inspiring as an engineer, instructive in your work in robotics?
To me, so ants are really quite incredible creatures, right? So the individuals arguably are very simple in how they're built, and yet they're incredibly resilient as a population. And as individuals, they're incredibly robust. So, if you take an ant with 6 legs, you remove 1 leg, it still works just fine. And it moves along, and I don't know that it even realizes it's lost a leg. So that's the robustness at the individual ant level. But then you look about this instinct for self-preservation of the colonies, and they adapt in so many amazing ways. Transcending gaps by just chaining themselves together when you have a flood, being able to recruit other teammates to carry big morsels of food, and then going out in different directions looking for food, and then being able to demonstrate consensus, even though they don't communicate directly with each other the way we communicate with each other. In some sense, they also know how to do democracy, probably better than what we do.
Yeah. Somehow even democracy is emergent. It seems like all of the phenomena that we see is all emergent. It seems like there's no centralized communicator.
There is. I think a lot is made about that word, emergent, and it means lots of things to different people. But you're absolutely right. I think as an engineer, you think about what elemental behaviors, what primitives you could synthesize so that the whole looks incredibly powerful, incredibly synergistic, the whole definitely being greater than the sum of the parts. And ants are living proof of that.
So it's a really tense part of the world. It's a complicated part of the world. Israel and all around.
Yes.
So religion is at the core of that complexity. Or one of the components.
Religion is a strong motivating cause to many, many people in the Middle East. Yes.
In your view, looking back, is religion good for society?
That's a good question for robotics,
There's echoes of that question.
Equip robot with religious beliefs. Suppose we find out, or we agree that religion is good to you to keep you in line.
Yeah.
Okay, should we give the robot the metaphor of a god?
Yeah.
As a matter of fact, the robot will get it without us also. Why? But the robot will reason by metaphor. And what is the most primitive metaphor a child grows with? Mother smile, father teaching, father image, and mother image. That's God. So whether you want it or not, the robot will. Well, assuming that the robot is going to have a mother and a father, it may only have a programmer which doesn't supply warmth and discipline.
Yeah.
Well, discipline it does. Okay, so the robot will have a model of the trainer, okay? And everything that happens in the world, cosmology and so on, is going to be mapped into the programmer. That's God.
Yeah. The thing that represents the origin of everything for that robot.
That's the most primitive relationship.
So it's going to arrive there by metaphor. And so the question is if overall that metaphor has served us well as humans.
I really don't know. I think it did. But as long as you keep in mind it's only a metaphor.
So, search engine and a bit of curiosity. Question is, what form factor of robots are you most excited about for the future? Bipeds, quads, arms, humanoids, maybe something else more obscure? This is a really tough question because I really like robots. I think that love is born in software, and the hardware stuff just makes it a little more fun. So I think the things I'm really excited about, even in terms of form factors, is in the software. I think much of the exciting developments in robotics is actually in simulated worlds currently, and I think that will be true for quite a while to come. And so I think in terms of human-robot interaction, the robots that will be really exciting are the ones that live in virtual worlds, like in virtual reality or even just on a screen. So I think what we would see more and more is entities, human-like entities, or entities that allow us to anthropomorphize a consciousness, a spirit onto them living in the digital world. I think that's what I'm really excited about. And of course, slowly those entities taking a form in the physical space in terms of, I think probably the humanoid form, unfortunately, though very difficult to engineer and create a realistic and natural, fulfilling experience with, I think is still probably the most, to me, exciting form. Although I do really like Boston Dynamics Spot, the robot dog. From a kind of having a pet perspective, is a really exciting form. Again, very difficult to do stuff in the physical space. It's a huge engineering challenge that, as far as I can tell, is several orders of magnitude more difficult than the same challenge in the digital space. So I just see the digital simulated robotics advancing much quicker and having a much larger scale impact on the world, especially if we start seeing more and more virtual worlds being created. And that doesn't necessarily mean virtual reality or like augmented reality. It just means ability and mediums within which you can interact with artificial intelligence systems in the digital space. And I do see that as a form factor, which is entities in digital space having a humanoid or a semi-humanoid form, something that we can anthropomorphize, something we can connect with.
Okay, when was the leap from programming to robotics?
That happened later. That was after grad school. And actually, self-driving cars was, I think, my first real hands-on introduction to robotics. But I never really had that much hands-on experience. In school and training, I worked on applied math and physics. Then in college, I did more kind of abstract computer science. And it was after grad school that I really got involved in robotics, which was actually self-driving cars. And that was a big flip.
What grad school?
So I went to grad school in Michigan, and then I did a postdoc at Stanford, that was the postdoc where I got to play with self-driving cars.
Yeah, so we'll return the things.
Are we capable now to do a robot that is self-aware?
That's one, the legged one.
It's self-aware.
It's not self-aware. It's been listening, but it's not self-aware currently.
But do you think a human being is self-aware? Or
that's a good question. I mean, I ask this question all the time. When the robots move, there's a sense of when they turn on, something entered that robot.
Wow.
And when it turns off, something left. If they move in a certain kind of way, and if they surprise you, there's certain elements that enable us to see the magic in a living being. And some of them, I mean, we can maybe list them, but it's the ability to surprise you. It's the ability to make mistakes and learn from them visibly. There's a bunch of things that you just, I don't know, it just feels like it has the magic of what is a living being, and which is what humans have. And I try to think about how do you replicate that into a machine.
So when you turn it on enough, you feel like it dies every time and it reborn, right?
So for most machines, we don't feel that way. When we unplug things, we don't feel that way. I don't know why we don't feel that way. That's an interesting question. But I think when the robot has certain qualities, like memory, like ability to recognize you, yeah, you start to feel like you're turning off an organism. So whenever I have like the robots that recognize me and remember, this is important, that all the things we've experienced together, then it's like, holy shit, that's a living thing.
But does he remember?
It feels like a living thing.
Does he remember your robot? Does he remember things that happened before you unplugged him? Is it like he's sleeping? Like is he wake up, or is he like dead?
No, so
or
right now
we start to zero every.
No, it doesn't start at zero. It remembers everything. That's the key.
Every time you unplug. Yeah. Wow.
It's storing the memories, but the memories are basic. They're like, okay, we walked around the kitchen, and then you looked at me. I mean, the memories, it's like data. It's not like we've experienced. It's able to actually experience anything deep like we humans can. But just the fact of memory. It's like the toaster or the microwave don't give a shit about me. They don't know me. They don't know me by name. They wouldn't recognize my face as being different from Gordon's. They wouldn't know the difference. And they wouldn't remember, the microwave currently doesn't remember, the times I've been sad or happy, like what food I put into it. It doesn't remember this, when I was being a fat ass or when I was being in good shape, and all just those memories are enough to make you feel when you turn a thing off. That's like, shit. Wow. That's a living thing disappearing. Of course, that's kind of an anthropomorphism we do to each other, but that's something. It's, that makes me believe it's possible to create systems with which we can have a connection that are non-human, like similar to dogs and cats and so on. It just makes me feel, and that's what's interesting to me, because ultimately I feel like they'll help us understand ourselves and maybe practice grappling moves. Anyway, well, let me ask the advice question. Now that we're together, I've spoken to John, I spoke to George. So what's the role of simulations with drones? You've done quite a bit of work there. How promising, just the very thing you said just now, how promising is the possibility of training and developing a safe flying robot in simulation and then deploying it and having that work pretty well in the real world?
I think that, a lot of people, when they hear simulation, they will focus on training immediately. But I think one thing that you said, which was interesting, it's developing. I think simulation environments could be key and great for development. And that's not new. Like, for example, there's people in the automotive industry have been using dynamic simulation for like decades now. And it's pretty standard that, you would build and you would simulate. If you want to build an embedded controller, you plug that kind of embedded computer into another computer, that other computer would simulate dynamic, and so on. And I think, fast forward these things, you can create pretty crazy simulation environments. Like, for instance, one of the things that has happened recently and that, we can do now is that we can simulate cameras a lot better than we used to simulate them. We were able to simulate them before. And that's, I think we just hit the elbow on that kind of improvement. I would imagine that with improvements in hardware especially, and with improvements in machine learning, I think that we would get to a point where we can simulate cameras very, very well.
Simulate cameras means simulate how a real camera would see the real world. Therefore, you can explore the limitations of that. You can train perception algorithms on that in simulation, all that kind of stuff.
Exactly. So, it has been easier to simulate what we would call interoceptive sensors, like internal sensors. So, for example, inertial sensing has been easy to simulate. It has also been easy to simulate dynamics, like physics that are governed by ordinary differential equations. I mean, like how a car goes around, maybe how it rolls on the road, how it interacts with the road, or even an aircraft flying around, like the physics of that. What has been really hard has been to simulate exteroceptive sensors that kind of like look out from the vehicle. And that's a new thing that's coming like laser rangefinders are a little bit easier. Cameras, radars are a little bit tougher. I think once we nail that down, the next challenge, I think, in simulation will be to simulate human behavior. That's also extremely hard. Even when you imagine like how a human-driven car would act around, even that is hard. But imagine trying to simulate, you know, a model of a human just doing a bunch of gestures and so on, and you know, it's actually simulated. It's not captured like with motion capture, but it is simulated. That's very hard. In fact, today I get involved a lot with like sort of this kind of very high-end rendering projects. And I have like this test that I pass it to my friends or my mom. You know, I send like 2 photos, 2 kind of pictures, and I say, rendered, which one is rendered, which one is real. And it's pretty hard to distinguish, except I realize, except when we put humans in there. It's possible that our brains are trained in a way that we recognize humans extremely well. But we don't so much recognize the built environments, because built environments sort of came after, per se, we evolved into sort of being humans, but humans were always there. Same thing happens, for example, you look at like monkeys and you can't distinguish one from another, but they sort of do. And it's very possible that they look at humans, it's kind of pretty hard to distinguish one from another, but we do. And so our eyes are pretty well trained to look at humans and understand if something is off, we will get it. We may not be able to pinpoint it. So in my typical friend test or mom test, what would happen is that we'd put like a human walking in a thing, and they say, you know, this is not right. Something is off in this video. I don't know what, but I can tell you it's the human. I can take the human and I can show you like inside of a building or like an apartment, and it will look like, if we had time to render it, it will look great. And this should be no surprise. A lot of movies that people are watching, it's all computer generated. You know, even nowadays, even you watch a drama movie and like there's nothing going on action wise, but it turns out it's kind of like cheaper, I guess, to render the background. And so they would.
But how do we get there? How do we get a human would pass the mom/friend test, a simulation of a human walking? So do you think that's something we can creep up to by just doing kind of a comparison learning, where you have humans annotate what's more realistic and not, just by watching? Like, what's the path? Because it seems totally mysterious how we,
I think you're right,
simulate human behavior.
It's hard because a lot of the other things that I mentioned to you, including simulating cameras, right? It is the thing there is that, you know, we know the physics, we know how it works, like in the real world, and we can write some rules and we can do that. Like, for example, simulating cameras, there's this thing called ray tracing. I mean, you literally just kind of imagine, it's very similar to, it's not exactly the same, but it's very similar to tracing photon by photon. They're going around, bouncing on things and coming to your eye. But human behavior, developing a dynamic, like a model of that is mathematical, so that you can put it into a processor that would go through that, that's going to be hard. And so what else do you got? You can collect data, right? And you can try to match the data. Or another thing that you can do is that, you know, you can show the friend test. You know, you can say this or that and this or that, and that will be labeling. Anything that requires human labeling, ultimately we're limited by the number of humans that, you know, we have available at our disposal and the things that they can do. You know, they have to do a lot of other things than also labeling this data. So that modeling human behavior part is I think we're going to realize it's very tough. And I think that also affects, you know, our development of autonomous vehicles. I see that in self-driving as well. Like, you want to use, so you're building self-driving, you know, at the first time, like right after Urban Challenge, I think everybody focused on localization, mapping and localization. You know, SLAM algorithms came in, Google was just doing that. And so building these HD maps, basically that's about knowing where you are. And then 5 years later, in 2012, 2013, came the kind of quote-unquote AI revolution, and that started telling us where everybody else is. But we're still missing what everybody else is going to do next. And so you want to know where you are, you want to know what everybody else is, hopefully you know what you're going to do next, and then you want to predict what other people are going to do. And that last bit has been a real challenge.
What do you think is the role your own of the ego vehicle, the robot you, the robotic you, in controlling
and having some control of how the future unrolls, of what's going to happen in the future. That seems to be a little bit ignored in trying to predict the future, is how you yourself can affect that future by being either aggressive or less aggressive or signaling in some kind of way. Sort of this kind of game theoretic dance seems to be ignored for the moment.
It's totally ignored. I mean, it's quite interesting actually, like how we interact with things versus we interact with humans. Like, so if you see a vehicle that's completely empty and it's trying to do something, all of a sudden it becomes a thing. So you interact with this table. And so you can throw your backpack, or you can kick it, put your feet on it and things like that. But when it's a human, there's all kinds of ways of interacting with a human. So if, like you and I are face to face, we're very civil, we talk and we understand each other for the most part. We'll see. You just got started. So you never know what's going to happen. But the thing is that, like, for example, you and I might interact through YouTube comments, and, the conversation may go at a totally different angle. And so I think people kind of abusing these autonomous vehicles is a real issue in some sense. And so when you're an ego vehicle, you're trying to, coordinate your way, make your way. It's actually kind of harder than being a human. It's like, it's you not only need to be as smart as kind of humans are, but you're a thing. So they're going to abuse you a little bit. So you need to make sure that you can get around and do something. So I in general believe in that sort of game theoretic aspects. I've actually personally have done, quite a few papers, both on that kind of game theory and also like this kind of understanding people's social value orientation, for example. Some people are aggressive, some people not so much. And a robot could understand that by just looking at how people drive. And as they kind of come and approach, you can actually understand, like, if someone is going to be aggressive or not as a robot, and you can make certain decisions.
Well, in terms of predicting what they're going to do, the hard question is, you as a robot, should you be aggressive or not when faced with an aggressive robot? Right now, it seems like aggressive is a very dangerous thing to do because it's costly from a societal perspective, how you're perceived. People are not very accepting of aggressive robots in modern society.
I think that's accurate. So that it really is. And so I'm not entirely sure like how to go about, but I know for a fact that how these robots interact with other people in there is going to be, and that interaction is always going to be there. I mean, you could be interacting with other vehicles or other just people kind of like walking around. And like I said, the moment there's like nobody in the seat, it's like an empty thing just rolling off the street. It becomes like no different than like any other thing that's not human. And so people, and maybe abuse is the wrong word, but people maybe rightfully even they feel like, this is a human present environment. It's designed for humans to be, and they want to own it. And then, the robots, they would need to understand it, and they would need to respond in a certain way. And I think that, this actually opens up like quite a few interesting societal questions for us as we deploy, like we talk, robots at large scale. So what would happen when we try to deploy robots at large scale, I think, is that we can design systems in a way that they're very efficient, or we can design them that they're very sustainable. But ultimately, the sustainability efficiency trade-offs, like they're going to be right in there. And we're going to have to make some choices. Like we're not going to be able to just kind of put it aside. So for example, we can be very aggressive and we can reduce transportation delays, increase capacity of transportation. Or, we can be a lot nicer and allow other people to kind of quote unquote own the environment and live in a nice place. And then efficiency will drop. So when you think about it, I think sustainability gets attached to energy consumption or environmental impact immediately. And those are there. But like livability is another sustainability impact. So you create an environment that people want to live in. And if robots are going around being aggressive, you don't want to live in that environment, maybe. However, you should note that if you're not being aggressive, then you're probably taking up some delays in transportation and this and that. So you're always balancing that. And I think this choice has always been there in transportation, but I think the more autonomy comes in, the more explicit the choice becomes.
Yeah, and when it becomes explicit, then we can start to optimize it, and then we'll get to ask the very difficult societal questions of what do we value more, efficiency or sustainability. It's kind of interesting.
I think that will happen. I think we're going to have to I think that the interesting thing about like the whole autonomous vehicles question, I think, is also kind of, I think a lot of times, we have focused on technology development like hundreds of years, and the products somehow followed, and then we got to make these choices and things like that. But this is a good time that we even think about autonomous taxi type of deployments and the systems that would evolve from there. And you realize the business models are different, the impact on architecture is different, urban planning. You get into like regulations, and then you get into like these issues that you didn't think about before, but like sustainability and ethics is like right in the middle of it. I mean, even testing autonomous vehicles, like think about it. You're testing autonomous vehicles in human present environments. I mean, the risk may be very small, but still, it's a strictly greater than zero risk that you're putting people into. And so then you have that innovation, risk trade-off that you're in that somewhere. And we understand that pretty well now is that if we don't test, at least the development will be slower. I mean, it doesn't mean that we're not going to be able to develop. I think it's going to be pretty hard, actually. Maybe we can, maybe we don't, I don't know. But the thing is that those kinds of trade-offs we already are making. And as these systems become more ubiquitous, I think those trade-offs will just really hit.
What is the most beautiful idea you've come across in robotics? Whether a simple equation, an experiment, a demo, a simulation, piece of software, what just gives you pause?
That's an interesting question. I have done a lot of work myself in decision making, so I've been interested in that area. So, in robotics, you have somehow the field has split into like, there's people who would work on like perception, how robots perceive the environment, then how do you actually make like decisions, and there's people also like how do you interact with robots. There's a whole bunch of different fields. And I have admittedly worked a lot on the more control and decision making than the others. And I think that, the one equation that has always kind of baffled me is Bellman's equation. And so it's this person who have realized like way back, more than half a century ago, on like, how do you actually sit down, and if you have several variables that you're kind of jointly trying to determine, how do you determine that? And there's one beautiful equation that, like today people do reinforcement learning, we still use it. And it's baffling to me because it both kind of tells you the simplicity, because it's a single equation that anyone can write down. You can teach it in the first course on decision making. At the same time, it tells you how computationally, how hard the problem is. I feel like a lot of the things that I've done at MIT for research has been kind of just this fight against computational efficiency. Things like, how can we get it faster, to the point where we now got to like, let's just redesign this chip. Like maybe that's the way. But I think it talks about how computationally hard certain problems can be by nowadays what people call curse of dimensionality. And so as the number of variables kind of grow, the number of decisions you can make grows rapidly. Like if you have, 100 variables, each one of them take 10 values, all possible assignments is more than the number of atoms in the universe. It's just crazy. And that kind of thinking is just embodied in that one equation that I really like.
And the beautiful balance between it being theoretically optimal and somehow, practically speaking, given the curse of dimensionality, nevertheless, in practice, works among, despite all those challenges, which is quite incredible.
Which is quite incredible. So, I would say that it's kind of like quite baffling, actually, in a lot of fields that we think about how little we know, and so I think here too, we know that in the worst case, things are pretty hard, but, in practice, generally things work. So it's kind of baffling in decision making, how little we know. Just like how little we know about the beginning of time, how little we know about, our own future. like if you actually go into like from Bellman's equation all the way down, I mean, there's also how little we know about like mathematics. I mean, we don't even know if the axioms are like consistent. It's just crazy.
Yeah. I think a good lesson there, just like as you said, we tend to focus on the worst case or the boundaries of everything we're studying. And then the average case seems to somehow work out. If you think about life in general, we mess it up a bunch, we freak out about a bunch of the traumatic stuff, but in the end, it seems to work out okay.
Yeah, that seems like a good metaphor.
Sertac, thank you so much for being a friend, a colleague, a mentor. I really appreciate it. It's an honor to talk to you.
Likewise. Thank you, Lex.
Thanks for listening to this conversation with Sertac Karaman, and thank you to our presenting sponsor, Cash App. Please consider supporting the podcast by downloading Cash App and using code LEXPODCAST. If you enjoy this podcast, subscribe on YouTube, review it with 5 stars on Apple Podcasts, support it on Patreon, or simply connect with me on Twitter at Lex Fridman. And now, let me leave you with some words from HAL 9000 from the movie 2001: A Space Odyssey. I'm putting myself to the fullest possible use, which is all I think that any conscious entity can ever hope to do. Thank you for listening, and hope to see you next time. I work on autonomous vehicles. I'm a roboticist. I love robots. And I think you have a fascination with snakes, both natural and artificial robots.
Absolutely.
I share your fascination. I mean, their movement is beautiful, adaptable. The adaptability is fascinating. There are, I looked it up, 2,900 species of snakes in the world.
Wow.
375 venomous. Some are tiny, some are huge. Saw that there's one that's 25 feet in some cases. So what's the most interesting thing that you connect with in terms of snakes, both natural and artificial? What was the connection with robotics, AI, and this particular form of a robot?
Well, it actually came out of my work in the 80s on computer animation, where I started doing things like cloth simulation and other kind of soft body simulation. And you'd sort of drop it and it would bounce, and then it would just sort of stop moving. And I thought, well, what if you animate the spring lengths and simulate muscles? And the simplest object I could do that for was an earthworm. So I actually did a paper in 1988 called The Motion Dynamics of Snakes and Worms. And I read the physiology literature on both how snakes and worms move, and then did some of the early computer animation examples of that. And
so your interest in robotics
came out of simulation and graphics. When I moved from Alias to Apple, we actually did a movie called Her Majesty's Secret Serpent, which is about a secret agent snake that parachutes in and captures a film canister from a satellite, which tells you how old-fashioned we were thinking back then. Sort of classic 50s or 60s Bond movie kind of thing. And at the same time, I'd always made radio-controlled ships when I was a child, and from scratch. And I thought, well, how hard can it be to build a real one? And so then started what turned out to be like a 15-year obsession with trying to build better snake robots. And the first one that I built just sort of slithered sideways, but didn't actually go forward. Then I added wheels. And building things in real life makes you honest about the friction. The thing that appeals to me is I love creating the illusion of life, which is what drove me to animation. And if you have a robot with enough degrees of coordinated freedom that move in a kind of biological way, then it starts to cross the uncanny valley into seeming like a creature rather than a thing. And I certainly got that with the early snakes. By S3, I had it able to sidewind as well as go directly forward. My wife-to-be suggested that it would be the ring bearer at our wedding, so it actually went down the aisle carrying the rings, and got in the local paper for that, which was really fun. And this was all done as a hobby. And then at the time, the onboard compute was incredibly limited. It was sort of...
Yeah, so you should explain that. These snakes, the whole idea is that you're trying to run it autonomously. So
onboard power, onboard, right. And so the very first one, I actually built the controller from discrete logic, because I used to do LSI, circuits and things when I was a teenager. And then the second and third one, the 8-bit microprocessors were available with like a whole 256 bytes of RAM, which you could just about squeeze in. So they were radio controlled rather than autonomous. and really were more about the physicality and coordinated motion. I've occasionally taken a sidestep into, if only I could make it cheaply enough, it would make a great toy, which has been a lesson in how clockwork is its own magical realm that you venture into and learn things about backlash and other things you don't take into account as a computer scientist, which is why what seemed like a good idea doesn't work. So it's quite humbling. And then more recently, I've been building S9, which is a much better engineered version of S3, where the motors wore out and it doesn't work anymore, and you can't buy replacements, which is sad given that it was such a meaningful one. S5 was about twice as long and looked much more biologically inspired. Unlike the typical roboticist, I taper my snakes. There are good mechanical reasons to do that, but it also makes them look more biological, although it means every segment's unique rather than a repetition, which is why most engineers don't do it. It actually saves weight and leverage and everything. And that one is currently on display at the International Spy Museum in Washington, D.C. Not that it's done any spying. It was on YouTube and it got its own conspiracy theory where people thought that it wasn't real because I work at Adobe, it must be fake graphics. And people would write to me, tell me it's real. And, they say the background doesn't move. And it's like, it's on a tripod, So that one, but you can see the real thing. So it really is true. And then the latest one is the first one where I could put a Raspberry Pi, which leads to all sorts of terrible jokes about Pythons and things. But
yeah.
But this one can have onboard compute. And then where my hobby work and my work are converging is you can now add vision accelerator chips, which can evaluate neural nets and do object recognition and everything. So both for the snakes and more recently for the spider that I've been working on, having, desktop level compute is now opening up a whole world of true autonomy with onboard compute, onboard batteries, and still having that sort of biomimetic quality that that appeals to children in particular. They are really drawn to them, and adults think they look creepy, but children actually think they look charming. I gave a series of lectures at Girls Who Code to encourage people to take an interest in technology. And at the moment, I'd say they're still more expensive than the value that they add, which is why they're a great hobby for me, but they're not really a great product. It makes me think about doing that very early thing I did at Alias with changing the muscle rest lengths. If I could do that with a real artificial muscle material, then the next snake ideally would use that rather than motors and gearboxes and everything. It would be lighter, much stronger, and more continuous and smooth. So I like to say being in research is a license to be curious, and I have the same feeling with my hobby. It forced me to read biology and be curious about things that otherwise would have just been, a National Geographic special. Suddenly I'm thinking, how does that snake move? Can I copy it? I look at the trails that sidewinding snakes leave in sand and see if my snake robots would do the same thing.
So out of something inanimate, I like why you put it, try to bring life into it and beauty.
Absolutely. And then ultimately give it a personality, which is where the intelligent agent research will converge with the vision and voice synthesis to give it a sense of having not necessarily human level intelligence. I think the Turing test is such a high bar, it's a little bit self-defeating, but having one that you can have a meaningful conversation with, especially if you have a reasonably good sense of what you can say. So not trying to have it so a stranger could walk up and have one, but so as a pet owner or a robot pet owner, you could know what it thinks about and what it can reason about.
Or sometimes just meaningful interaction. If you have the kind of interaction you have with a dog, sometimes you might have a conversation, but it's usually one way.
Absolutely.
And nevertheless, it feels like a meaningful connection.
And one of the things that I'm trying to do in the sample audio that we'll play you is beginning to get towards the point where the reasoning system can explain why it knows something or why it thinks something. And that, again, creates the sense that it really does know what it's talking about, but also for debugging. As you get more and more elaborate behavior, it's like, why did you decide to do that? How do you know that? I think the robots really are my muse for helping me think about the future of AI and what to invent next.
So even at Adobe, that's mostly operating in the digital world.
Correct.
Do you see a future where Adobe even expands into the more physical world, perhaps? So bringing life not into animations, but bringing life into physical objects, with whether it's, well,
I'd have to say at the moment it's a twinkle in my eye. I think the more likely thing is that we will bring virtual objects into the physical world through augmented reality. And many of the ideas that might take 5 years to build a robot to do, you can do in a few weeks with digital assets. So I think when really intelligent robots finally become commonplace, they won't be that surprising, because we'll have been living with those personalities in the virtual sphere for a long time. And then they'll just say, oh, it's, Siri with legs, or Alexa on hoofs or something. So I can see that world coming. And for now, it's still an adventure, and we don't know quite what the experience will be like. And it's really exciting to sort of see all of these different strands of my career converge.
Yeah, in interesting ways. And it is definitely a fun adventure. In your book, Ethics in the Real World, amazing book. People should check it out. Very easy read. 82 brief essays on things that matter. One of the essays asks, should robots have rights? You've written about this, so let me ask, should robots have rights?
If we ever develop robots capable of consciousness, capable of having their own internal perspective on what's happening to them, so that their lives can go well or badly for them, then robots should have rights. Until that happens, they shouldn't.
So is consciousness essentially a prerequisite to suffering? So everything that possesses consciousness is capable of suffering, put another way. And if so, what is consciousness?
I certainly think that consciousness is a prerequisite for suffering. You can't suffer if you're not conscious. But is it true that every being that is conscious will suffer, or has to be capable of suffering? I suppose you could imagine a kind of consciousness, especially if we can construct it artificially, that's capable of experiencing pleasure, but just automatically cuts out the consciousness when they're suffering. Sort of like, instant anesthesia as soon as something is going to cause you suffering. So that's possible, but doesn't exist as far as we know on this planet yet. You asked what is consciousness. Philosophers often talk about it as there being a subject of experiences. So you and I and everybody listening to this is a subject of experience. There is a conscious subject who is taking things in, responding to it in various ways, feeling good about it, feeling bad about it. And that's different from the kinds of artificial intelligence we have now. I take out my phone, I ask Google directions to where I'm going, Google gives me the directions, and I choose to take a different way. Google doesn't care. It's not like I'm offending Google or anything like that. There is no subject of experiences there. And I think that's the indication that Google, the AI we have now, is not conscious, or at least that level of AI is not conscious. And that's the way to think about it. Now, it may be difficult to tell, of course, whether a certain AI is or isn't conscious. It may mimic consciousness, and we can't tell if it's only mimicking it or if it's the real thing. But that's what we're looking for. Is there a subject of experience, a perspective on the world from which things can go well or badly from that perspective?
So our idea of what suffering looks like comes from just watching ourselves when we're in pain, sort of,
or when we're experiencing pleasure. It's not only
pleasure and pain.
Only, yes.
Yes. So, and then you could push back on this, but I would say that's how we kind of build an intuition about animals, is we can infer the similarities between humans and animals, and so infer that they're suffering or not based on certain things, and they're conscious or not. So what if robots you mentioned Google Maps. And I've done this experiment, so I work in robotics, just for my own self. I have several Roomba robots, and I play with different speech interaction, voice-based interaction. And if the Roomba or the robot or Google Maps shows any signs of pain, like screaming or moaning or being displeased by something you've done, that, in my mind, I can't help but immediately upgrade it. And even when I myself programmed it in, just having another entity that's now, for the moment, disjoint from me, showing signs of pain, makes me feel like it is conscious. Like I immediately, then I immediately realize that it's not, obviously, but that feeling is there. So sort of, I guess, what do you think about a world where Google Maps and Roombas are pretending to be conscious, and we, descendants of apes, are not smart enough to realize they're not, or whatever, or that is conscious, they appear to be conscious, and so you then have to give them rights. The reason I'm asking that is that kind of capability may be closer than we realize.
Yes, that kind of capability may be closer, but I don't think it follows that we have to give them rights. I suppose the argument for saying that in those circumstances we should give them rights is that if we don't, we'll harden ourselves against other beings who are not robots and who really do suffer. That's a possibility that, if we get used to looking at a being suffering and saying, no, we don't have to do anything about that, that being doesn't have any rights, maybe we'll feel the same about animals, for instance. And interestingly, among philosophers and thinkers who denied that we have any direct duties to animals, and this includes people like Thomas Aquinas and Immanuel Kant, they did say, yes, but still it's better not to be cruel to them, not because of the suffering we're inflicting on the animals, but because if we are, we may develop a cruel disposition, right, and this will be bad for humans, because we're more likely to be cruel to other humans, and that would be wrong. But
you don't accept that kind of...
I don't accept that as the basis of the argument for why we shouldn't be cruel to animals. I think the basis of the argument for why we shouldn't be cruel to animals is just that we're inflicting suffering on them, and the suffering is a bad thing. But possibly I might accept some sort of parallel of that argument as a reason why you shouldn't be cruel to these robots that mimic the symptoms of pain if it's going to be harder for us to distinguish.
I would venture to say, I'd like to disagree with you and with most people, I think. At the risk of sounding crazy, I would like to say that if that Roomba is dedicated to faking the consciousness and the suffering, I think it will be impossible for us. I would like to apply the same argument as with animals to robots, that they deserve rights in that sense. Now, we might outlaw the addition of those kinds of features into Roombas, but once you do, I think I'm quite surprised by the upgrade in consciousness that the display of suffering creates. It's a totally open world, but I'd like to just sort of the difference between animals and other humans is that in the robot case, we've added it in ourselves. Therefore, we can say something about how real it is. But I would like to say that the display of it is what makes it real. And there's I'm not a philosopher, I'm not making that argument, but I at least like to add that as a possibility. And I've been surprised by it, is all I'm trying to sort of articulate right. Poorly, I suppose.
So there is a philosophical view has been held about humans, which is rather like what you're talking about, and that's behaviorism. So behaviorism was employed both in psychology, people like B.F. Skinner was a famous behaviorist, but in psychology it was more a kind of what is it that makes this science? Well, you need to have behavior because that's what you can observe. You can't observe consciousness. But in philosophy, the view is defended by people like Gilbert Ryle, who was a professor of philosophy at Oxford, wrote a book called The Concept of Mind, in which, in this kind of phase, this is in the 40s of linguistic philosophy, he said, well, the meaning of a term is its use, and we use terms like so-and-so is in pain when we see somebody writhing or screaming or trying to escape some stimulus. And that's the meaning of the term. So that's what it is to be in pain. And you point to the behavior. Norman Malcolm, who was another philosopher in the school from Cornell, had the view that, so what is it to dream? After all, we can't see other people's dreams. Well, when people wake up and say, I've just had a dream of, here I was undressed walking down the main street or whatever it is you've dreamt, that's what it is to have a dream. It's to basically to wake up and recall something. So you could apply this to what you're talking about and say, so what it is to be in pain is to exhibit these symptoms of pain behavior, and therefore these robots are in pain. That's what the word means. But nowadays, not many people think that Ryle's kind of philosophical behaviorism is really very plausible. So I think they would say the same about your view.
So, yes, and I just spoke with Noam Chomsky, who basically was part of dismantling the behaviorist movement. Yeah. And I'm with that 100% for studying human behavior, but I am one of the few people in the world who has made Roombas scream in pain. And I just don't know what to do with that empirical evidence, because it's hard. Sort of philosophically, I agree. But the only reason I philosophically agree in that case is because I was the programmer. But if somebody else was a programmer, I'm not sure I would be able to interpret that well. So it's I think it's a new world that I was just curious what your thoughts are. For now, you feel that the display of what we can kind of intellectuals say is a fake display of suffering is not suffering.
That's right. That would be my view. But that's consistent, of course, with the idea that it's part of our nature to respond to this display if it's reasonably authentically done. And therefore, it's understandable that people would feel this. And maybe, as I said, it's even a good thing that they do feel it, and you wouldn't want to harden yourself against it, because then you might harden yourself against beings who are really suffering.
But there's this line, so you said once artificial general intelligence system, a human level intelligence system, become conscious. I guess if I could just linger on it. Now, I've wrote really dumb programs that just say things that I told them to say, but how do you know when a system like Alexa, which is sufficiently complex that you can't introspect of how it works, starts giving you signs of consciousness through natural language, that there's a feeling there's another entity there that's self-aware, that has a fear of death, a mortality, that has awareness of itself that we kind of associate with other living creatures. I guess I'm sort of trying to do this slippery slope from the very naive thing where I started into something where it's sufficiently a black box to where it's starting to feel like it's conscious. Where's that threshold where you would start getting uncomfortable with the idea of robots suffering, do you think?
I don't know enough about the programming that would go into this really to answer this question. But I presume that somebody who does know more about this could look at the program and see whether we can explain the behaviors in a parsimonious way that doesn't require us to suggest that some sort of consciousness has emerged. Or alternatively, whether you're in a situation where you say, I don't know how this is happening. The program does generate a kind of artificial general intelligence which is autonomous, starts to do things itself and is autonomous of the basic programming that set it up. And so it's quite possible that actually we have achieved consciousness in a system of artificial intelligence.
Sort of the approach that I work with, most of the community is really excited about now, is with learning methods, so machine learning. and the learning methods are unfortunately not capable of revealing, which is why somebody like Noam Chomsky criticizes them. You've created powerful systems that are able to do certain things without understanding the theory, the physics, the science of how it works. And so it's possible if those are the kinds of methods that succeed, we won't be able to know exactly, sort of try to reduce, try to find whether this thing is conscious or not, this thing is intelligent or not. It's simply giving, when we talk to it, it displays wit and humor and cleverness and emotion and fear. And then we won't be able to say where in the billions of neurons in this artificial neural network is the fear coming from. Mm-hmm. So in that case, that's a really interesting place where we do now start to return to behaviorism and say,
yeah, that is an interesting issue. I would say that if we have serious doubts and think it might be conscious, then we ought to try to give it the benefit of the doubt. Just as I would say with animals, I think we can be highly confident that vertebrates are conscious, but when we get down, and some invertebrates like the octopus, but with insects, it's much harder to be confident of that. I think we should give them the benefit of the doubt where we can, which means, I think it would be wrong to torture an insect, but this doesn't necessarily mean it's wrong to slap a mosquito that's about to bite you and stop you getting to sleep. So I think you try to achieve some balance in these circumstances of uncertainty.
So why is it so hard at a high level to build a robotics company, a robotics company that lives for a long time? So if you look at, so I thought Cosmo for sure would live for a very long time. That to me was exceptionally successful vision and idea and implementation. iRobot is an example of a company that has pivoted in all the right ways to survive and arguably thrive by focusing on having have a driver that constantly provides profit, which is the vacuum cleaner. And of course, there's like Amazon. What they're doing is they're almost like taking risks so they can afford it because they have other sources of revenue, right? But outside of those examples, most robotics companies fail.
Yeah.
Why do they fail? Why is it so hard to run a robotics company?
iRobot's impressive because they found a really, really great fit of where the technology could satisfy a really clear use case and need. And they did it well, and they didn't try to overshoot from a cost to benefit standpoint. Robotics is hard because it tends to be more expensive. It combines way more technologies than a lot of other types of companies do. If I were to say one thing that is maybe the biggest risk in a robotics company failing is that it can be either a technology in search of an application, or they try to bite off a kind of an offering that has a mismatch in kind of price to function. And just the mass market appeal isn't there. And consumer products are just hard. It's just, after all the years in it, definitely kind of feel a lot of the battle scars because you have, you not only do you have to hit the function, but you have to educate and explain, get awareness up, deal with different types of consumers. There's a reason why a lot of technologies sometimes start in the enterprise space and then kind of continue forward in the consumer space. Even you see AR starting to kind of make that shift with HoloLens and so forth in some ways. Consumers and price points that they're willing to kind of be attracted in a mass market way. And I don't mean 10,000 enthusiasts bought it, but I mean 2 million, 10 million, 50 million, mass market kind of interest, have bought it. That bar is very, very high. And typically robotics is novel enough and non-standardized enough to where it pushes on price points so much that you can easily get out of range where the capabilities in today's technology or just the function that was picked just doesn't line up. And so that product market fit is very important.
So the space of killer apps or rather super compelling apps is much smaller because it's easy to get outside the price range.
Yeah, and
for most consumers.
And it's not constant, right? Like, and that's why like we picked off entertainment, because the quality was just so low in physical entertainment that we felt we could leapfrog that and still create like a really compelling offering at a price point that was defensible. And we like that proved out to be true. And over time, that same opportunity opens up in healthcare, in home applications, and commercial applications, and kind of broader, more generalized interface. But there's missing pieces in order for that to happen, and all of those have to be present for it to line up. And we see these sort of trends in technology where kind of technologies that start in one place evolve and kind of grow to another. Some things start in gaming, some things start in space or aerospace, and then kind of move into the consumer market. And sometimes it's just a timing thing, right? Where how many stabs at what became the iPhone were there over the 20 years before that just weren't quite ready in the function relative to the kind of price point and complexity.
And sometimes it's a small detail of the implementation that makes all the difference, which is design is so important.
Something, like the new generation UX, right?
Yeah.
It's and that's it's tough, and oftentimes all of them have to be there, and it has to be like a perfect storm. And but yeah, history repeats itself in a lot of ways in a lot of these trends, which is exciting.
Let me ask you, like I said, you went to the mecca of robotics, which is CMU, Carnegie Mellon University. You got a PhD there. So maybe by way of advice and maybe by way of story and memories, what does it take to get a PhD in robotics at CMU? And maybe you can throw in there some advice for people who are thinking about doing work in artificial intelligence and robotics and are thinking about whether to get a PhD.
It's funny, I actually I was at CMU for undergrad as well and didn't know anything about robotics coming in, and was doing, electrical computer engineering, computer science, and really got more and more into kind of AI, and then fell in love with autonomous driving. And at that point, like that was just by a big margin, like such a incredible, like central spot of investment in that area. And so what I would say is that like robotics, like for all the progress that's happened, is still a really young field. There's a huge amount of opportunity. Now that opportunity shifted where something like autonomous driving has moved from being very research and academics driven to being commercial driven, where you see the investments happening in commercial. Now there's other areas that are much younger, and you see like kind of grasping and manipulation making kind of the same sort of journey that like autonomy made, and there's other areas as well. What I would say is the space moves very quickly. Anything you do a PhD in, like it is in most areas, will evolve and change as technology changes and constraints change and hardware changes and the world changes. And so the beautiful thing about robotics is that it's super broad. It's not a narrow space at all, and it can be a million different things in a million different industries. And so it's a great opportunity to come in and get a broad foundation on AI, machine learning, computer vision, systems, hardware, sensors, all these separate things. You do need to like go deep and find something that you're like really, really passionate about. Obviously, like just like any PhD, this is like a 5-6 year kind of endeavor. And you have to love it enough to go super deep to learn all the things necessary to be super deeply functioning in that area and then contribute to it in a way that hasn't been done before. And in robotics, that probably means more breadth, because robotics is rarely kind of like one particular kind of narrow technology. And it means being able to collaborate with teams where like one of the coolest aspects of like the experience that I like kind of cherish in our PhD is that we actually had a pretty large AV project that for that time was like a pretty serious initiative where you got to like partner with a larger team, and you had the experts in perception and the experts in planning and the staff and the mechanical engineers.
For the DARPA challenge.
So I was working on a project called UPI back then, which was basically the off-road version of the DARPA challenge. It was a DARPA funded project for basically like a large off-road vehicle that you would like drop and then give it a waypoint 10 kilometers away, and it would have to navigate a completely unstructured
in an off-road environment.
Yeah. So like forests, ditches, rocks, vegetation. And so it was like a really, really interesting kind of a hard problem where like wheels would be up to my shoulders. It's like gigantic, right?
Yeah, by the way, AV for people stands for autonomous vehicles.
Autonomous vehicles, yeah. Sorry. And so what I think is like the beauty of robotics, but also kind of like the expectation is that there's spaces in computer science where you can be very, very narrow and deep. Robotics, one of the necessity, but also the beauty of it is that it forces you to be excited about that breadth and that partnership across different disciplines that enable it. But that also opens up so many more doors where you can go and you can do robotics in almost any category, where robotics isn't really an industry. It's like AI, right? It's like the application of physical automation to to all these other worlds. And so you can do robotic surgery, you can do vehicles, you can do factory automation, you can do healthcare, or you can do leverage the AI around the sensing to think about static sensors and scene understanding. So I think that's got to be the expectation and the excitement, and it breeds people that are probably a little bit more collaborative and more excited about working in teams.
If I could briefly comment on the fact that the robotics people I've met in my life from CMU, at MIT, they're really happy people.
Yeah.
Because I think it's the collaborative thing. Yeah. I think you're
not sitting in the fourth basement.
Yes, exactly. When you're doing machine learning purely software, it's very tempting to just disappear into your own hole and never collaborate. And that breeds a little bit more of the silo mentality of I have a problem. It's almost negative to talk to somebody else or something like that. But robotics folks are just very collaborative, very friendly, and there's also an energy of you get to confront the physics of reality often, which is humbling and also exciting. So it's humbling when it fails and exciting when it finally works.
It's like a purity to the passion. And you got to remember that right now, robotics and AI is just all the rage, and autonomous vehicles and all this. 15 years ago and 20 years ago, it wasn't that deeply lucrative. People that went into robotics, they did it because they were thought it was just the coolest thing in the world to make physical things intelligent in the real world. And so there's a raw passion where they went into it for the right reasons and so forth. And so it's really great space. And that organizational challenge, by the way, when you think about the challenges in AV, we talk a lot about the technical challenges. The organizational challenge is through the roof, where you think about what it takes to build an AV system, and you have companies that are now thousands of people, and you look at other really hard technical problems like an operating system. It's pretty well established. You kind of know that there's the file system, there's virtual memory, there's this, there's that, there's caching, and there's a really reasonably well established modularity and APIs and so forth. And so you can kind of scale it in an efficient fashion. That doesn't exist anywhere near to that level of maturity in autonomous driving right now. And tech stacks are being reinvented, organizational structures are being reinvented. You have problems like pedestrians that are not isolated problems. They're part sensing, part behavior prediction, part planning, part evaluation. And one of the biggest challenges is actually, how do you solve these problems where the mental capacity of a human is starting to get strained on how do you organize it and think about it, where you have this multi-dimensional matrix that needs to all work together. And so that makes it kind of cool as well, because it's not solved at all from, what does it take to actually scale this, right? Mm-hmm. And then you look at other gigantic challenges that have, that have been successful and are way more mature. There's a stability to it. And maybe the autonomous vehicle space will get there, but right now, just as many technical challenges as there are organizational challenges. And how do you solve these problems that touch on so many different areas and efficiently tackle them while maintaining progress among all these constraints while scaling?
By way of advice, what advice would you give to somebody thinking about doing a robotics startup? You mentioned Cosmo, somebody that wanted to carry the Cosmo flag forward, the Anki flag forward. Looking back at your experience, looking forward at a future that will obviously have such robots, what advice would you give to that person?
Yeah. It was the greatest experience ever. And it's there are things you learn navigating a startup that you'll never like. It was very hard to encounter that in like a typical kind of work environment, and it's just it's wonderful. You got to be ready for it. It's not as like the glamour of a startup. There's just brutal emotional swings up and down, and so having co-founders actually helps a ton. Like I could not imagine doing it solo, but having at least somebody where on your darkest days you can kind of like really openly just like have that conversation and lean onto somebody that's in the thick of it with you helps a lot. I would say,
what was the nature of darkest days and the emotional swings? Is it worried about the funding? Is it worried about whether any of your ideas are any good or ever were good? Is it like the self-doubt? Is it like facing new challenges that have nothing to do with the technology, like organizational, human resources, that kind of stuff?
You come from a world in school where you feel that you put in a lot of effort and you'll get the right result, and input translates proportional to output, and you need to solve this set or do whatever, and you just kind of get it done. Now, PhD tests that a little bit, but at the end of the day, you put in the effort, you tend to like kind of come out with your enough results to you kind of get a PhD. In the startup space, like you could talk to 50 investors and they just don't see your vision, and it doesn't matter how hard you kind of tried and pitched. You could work incredibly hard and you have a manufacturing defect, and if you don't fix it, you're out of business. You need to raise money by a certain date, and you got to have this milestone in order to like have a good pitch, and you do it. You have to have this talent, and you just don't have it inside the company, or you have to get 200 people or however many people kind of like along with you and kind of buy in the journey. You're like disagreeing with an investor, and they're your investor. So it's just like, it's like there's no walking away from it. Right. So, and it tends to be like those things where you just kind of get clobbered in so many different ways that like things end up being harder than you expect. And it's like such a gauntlet, but you learn so much in the process. And there's a lot of people that actually end up rooting for you and helping you like from the outside, and you get great mentors, and you like find fantastic people that step up in the company, and you have this like magical period where everybody's like, it's life or death for the company, but like you're all fighting for the same thing, and it's the most satisfying kind of journey ever. The things that make it easier and that I would recommend is like be really, really thoughtful about the application. Like there's a saying of like kind of team and execution and market, and like kind of how important are each of those. And oftentimes the market wins, and you come at it thinking that if you're smart enough and you work hard enough and you're like have the right talented team and so forth, like you'll always kind of find a way through. And it's surprising how much dynamics are driven by the industry you're in and the timing of you entering that industry. And so just Waymo's a great example of it. I don't know if there'll ever be another company or suite of companies that has raised and continues to spend so much money at such an early phase of revenue generation and productization. From a P&L standpoint, like it's a anomaly, like by any measure of any industry that's ever existed, except for maybe the U.S. space program, But it's like a multiple $1 trillion opportunities, which is so unusual to find that size of a market, that just the progress that shows the de-risking of it, you could apply whatever discounts you want off of that $1 trillion market, and it still justifies the investment that is happening, because like being successful in that space makes all the investment feel trivial. Now, by the same consequence, like the size of the market, the size of the target audience, the ability to capture that market share, how hard that's going to be, who the incumbents, like that's probably one of the lessons I appreciate like more than anything else, where like those things really, really do matter. And oftentimes can dominate the quality of the team or execution, because if you miss the timing or you do it in the wrong space, or you run into like the institutional kind of headwinds of a particular environment, like let's say you have the greatest idea in the world, but you barrel into healthcare, but it takes 10 years to innovate in healthcare because of a lot of challenges, right? Like there's fundamental laws of physics that you have to think about. And so the combination of like Anca and Waymo kind of drives that point home for me, where you can do a ton if you have the right market, the right opportunity, the right way to explain it, and you show the progress in the right sequence. It actually can really significantly change the course of your journey in startup.
How much of it is understanding the market, and how much of it is creating a new market? So how do you think about like space robotics is really interesting. You said exactly right. The space of applications is small.
Yeah.
Relative to the cost involved. So how much is like truly revolutionary thinking about like what is the application, and then but so like creating something that didn't really exist. Like this is pretty obvious to me. The whole space of home robotics, just everything that Cosmo did. I guess you could talk to it as a toy and people will understand it, but Cosmo is much more than a toy.
Yeah.
And I don't think people fully understand the value of that. You have to create it, and the product will communicate it. Like just like the iPhone, nobody understood the value of no keyboard and a thing that can do web browsing. I don't think they understood the value of that until you create it.
Yeah. Having a foot in the door and an entry point still helps, because at the end of the day, like an iPhone replaced your phone, and so it had a fundamental purpose, and then there's all these things that it did better, right?
That's true.
And so then you could do ABC on top of it, and then like you even remember the early commercials where it's always like one application of what it could do, and then you get a phone call, right? So that was intentionally sending a message, something familiar, but then like you can send a text message, you can listen to music, you can surf the web, right? And so autonomous driving obviously anchors on that as well. You don't have to explain to somebody the functionality of an autonomous truck, right? Like there's nuances around it, but the functionality makes sense. In the home, you have a fundamental advantage. Like we always thought about this because it was so painful to explain to people what our products did and how to communicate that super cleanly, especially when something was so experiential. And so you compare like Anki to Nest. Nest had some beautiful products where they started scaling and like actually found like really great success, and they had like really clean and beautiful marketing messaging because they anchored on reinventing existing categories where it was a smart thermostat, right? And and so you kind of are able to take what's familiar, anchor that understanding, and then explain what's better about it.
That's funny. You're right. Cosmo is like totally new thing. Like what is this thing?
Is we struggled. We spent a lot of money on marketing. We had a hard we actually had far greater efficiency on Cosmo than anything else, because we found a way to capture the emotion in some little shorts to kind of lean into the personality in our marketing, and it became viral. Where like we had these kind of videos that would like go and get like hundreds of thousands of views and like kind of like get spread and sometimes millions of views. And so, but it was like really, really hard. And so finding a way to kind of like anchor on something that's familiar, but then grow into something that's not, is an advantage. But then again, like you don't have like there's successes otherwise. Like Alexa never had a comp, right? You could argue that that's very novel and very new. And there's a lot of other examples that kind of created kind of a category out of like Kiva Systems. I mean, they like came in and they like enterprise is a little easier because if you can it's less susceptible to this, because if you can argue a clear value proposition, it's a more logical conversation that you can have with customers. It's a little bit less emotional and kind of subjective, but
in the home you have to
so like a home robot, it's like, what does that mean?
Yeah.
And so then you really have to be crisp about the value proposition and what like really makes it worth it. Like, and we, by the way, went to that same order. We almost hit a wall coming out of 2013 where we were so big on explaining why our stuff was so high tech and all the kind of like great technology in it and how cool it is and so forth, to having to make a super hard pivot on why is it fun and why does the random kind of family of four need this, right? Like, so it's learnings, but that's the challenge. And I think like robotics tends to sometimes fall into the new category problem, but then you got to be really crisp about why it needs to exist.
Well, I think some of robotics, depending on the category, depending on the application, is a little bit of a marketing challenge. And I mean it's the kind of marketing that Waymo's doing, that Tesla is doing, is like showing off incredible engineering, incredible technology, but convincing, like you said, a family of four that this is transformative for your life. This is fun. This is
they don't care
easy.
how much tech is in your thing.
Yeah, they don't. They really don't care.
Like they need to know why they want it. So,
and some of that is just marketing.
Yeah, and that's why like Roomba, like yes, they didn't go and have this like huge, ramp into like the entirety of like kind of AI robotics and so forth. But like they built a really great business in the vacuum cleaner world, and like everybody understands what a vacuum cleaner is. Most people are annoyed by doing it, and now you have one that like kind of does it itself. Various degrees of quality, but that is so compelling that like it's easy to understand, and like and they had a very kind of, and I think they have like 15% of the vacuum cleaner market, so it's like pretty successful, right? I think we need more of those types of thoughtful stepping stones in robotics, but the opportunities are becoming bigger because hardware's cheaper, compute's cheaper, cloud's cheaper, and AI is better. So there's a lot of opportunity.
If we zoom out from specifically startups, and
pretty fascinating.
Well, let me ask you about the humanoid form. What do you think about the Tesla bot and humanoid robotics in general? So obviously, to me, autonomous driving, Waymo and the other companies working in the space, that seems to be a great place to invest in potential revolutionary application of robotics. Application. What's the role of humanoid robotics? Do you think Tesla bot is ridiculous? Do you think it's super promising? Do you think it's interesting, full of mystery, nobody knows? What do you think about this thing?
Yeah. I think today humanoid form robotics is research. There's very few situations where you actually need a humanoid form to solve a problem. If you think about it, right, like wheels are more efficient than legs. There's joints and degrees of freedom beyond a certain point, just add a lot of complexity and cost, right? So if you're doing a humanoid robot, oftentimes it's in the pursuit of a humanoid robot, not in the pursuit of an application for the time being. Yes. Especially when you have like kind of the gaps in interface and, kind of AI that we kind of talk about today. So anything Elon does, I'm interested in following. So there's an element of that where
no matter how crazy
it is, I just like, I'll pay attention and I'm curious to see what comes out of it. So it's like, you can't ever, ignore it, but it's definitely far afield from their kind of core business, obviously. And
what was interesting to me is I've disagreed with Elon a lot about this. Is to me the compelling aspect of the humanoid form, and a lot of kind of robots, Cosmo for example, is the human-robot interaction part. Yeah. From Elon Musk's perspective, the Tesla bot has nothing to do with the human. It's a form that's effective for the factory because the factory is designed for humans. But to me, the reason you might want to argue for the humanoid form is because at a party, it's a nice way to fit into the party. The humanoid form has a compelling notion to it in the same way that Cosmo is compelling. Mm-hmm. I would argue, if we were arguing about this, that it's cheaper to build a Cosmo like that form. But if you wanted to make an argument, which I have with Jim Keller about, you could actually make a humanoid robot for pretty cheap. It's possible. And then the question is, all right, if you're using an application where it can be flawed, it can have a personality and be flawed in the same way that Cosmo is, then maybe it's interesting for integration to human society. Mm-hmm. That's to me is an interesting application of a humanoid form, because humans are drawn, like I mentioned to you, legged robots. Yeah. We're drawn to legs and limbs and body language and all that kind of stuff. And even a face, even if you don't have the facial features, which you might not want to have for to reduce the creepiness factor, all that kind of stuff. But that to me, the humanoid form is compelling. But in terms of that being the right form for the factory environment, I'm not so sure.
Yeah, for the factory environment, like right off the bat, what are you optimizing for? Is it strength? Is it mobility? Is it versatility? Right? Like that changes completely the look and feel of the robot that you create. And almost certainly the human form is over-designed for some dimensions and constrained for some dimensions. And so like what are you grasping? Is it big? Is it little? Right? So you would customize it and make it customizable for the different needs if that was the optimization, right? And then, for the other one, I could totally be wrong. I still feel that the closer you try to get to a human, the more you're subject to the biases of what a human should be, and you lose flexibility to shift away from your weaknesses and towards your strengths. And that changes over time, but there's ways to make really approachable and natural interfaces for robotic kind of characters and kind of deployments in these applications that do not at all look like a human directly, but that actually creates way more flexibility and capability and role and forgiveness and interface and everything else.
Yeah, it's interesting, but I'm still confused by the magic I see in legged robots.
Yeah, so there is a magic. So I'm absolutely amazed at it from a technical curiosity standpoint, and like the magic that like the Boston Dynamics team can do from from walking and jumping and so forth. Now, like there's been a long journey to try to find an application for that sort of technology, but wow, that's incredible technology, right?
Yes.
So then you kind of go towards, okay, are you working back from a goal of what you're trying to solve, or are you working forward from a technology and then looking for a solution? And I think that's where it's a kind of a bidirectional search oftentimes, but the two have to meet. And that's where humanoid robots is kind of close to that, in that like it is a decision about a form factor and a technology that it forces that doesn't have a clear justification on why that's the killer app for, from the other end.
But I think the core fascinating idea with the Tesla bot is the one that's carried by Waymo as well, is when you're solving the general robotics problem of perception control, where there's the very clear applications of driving. It's as you get better and better at it, when you have like the Waymo driver, the whole world starts to look like a robotics problem. So it's very interesting. For now, your
detection, classification, segmentation, tracking, planning, like it's carried. Yeah.
So there's no reason. I mean, I'm not speaking for Waymo here, but moving goods. There's no reason Transformer like this thing couldn't take the goods up an elevator. Like that. Like slowly expand what it means to move goods and expand more and more of the world into a robotics problem.
Well, that's right. And you start to like think of it as an end-to-end robotics problem, from like loading from everything.
Yes.
And even like the truck itself, today's generation is integrating into today's understanding of what a vehicle is, right? A Pacifica, Jaguar, the Freightliners from Daimler, there's nothing that stops us from like down the road, after like starting to get to scale, to like expand these partnerships to really rethink what would the next generation of a truck look like, that is actually optimized for autonomy, not for today's world. And maybe that means a very different type of trailer. Maybe that there's a lot of things you could rethink on that front, which is on its own very, very exciting.
Who is your favorite robot in science fiction, books or movies?
WALL-E and R2-D2, where they were able to convey such an incredible degree of intent, emotion, and kind of character attachment without having any language whatsoever, and just purely through the richness of emotional interaction. So those are fantastic. And then the Terminator series, just like really pretty wide range, right? But I kind of love this dynamic where you have this like incredible Terminator itself that Arnold played, but and then he was kind of like the inferior like previous generation version that was like totally outmatched in terms of kind of specs by the new one, but still kind of like held his own. And so it was kind of interesting where you realize how many levels there are on the spectrum, from human to kind of potentials in AI and robotics to futures. And so that movie really, as much as it was like kind of a dark world in a way, was actually quite fascinating, gets the imagination going.
Well, from an engineering perspective, both the movies you mentioned, WALL-E and Terminator, the first one is probably achievable. Humanoid robot, maybe not with like the realism in terms of skin and so on, but that humanoid form, we have that humanoid form. It seems like a compelling form. Maybe the challenge is it's super expensive to build, but you can imagine, maybe not a machine of war, but you can imagine Terminator-type robots walking around. And then the same, obviously, with WALL-E. You've basically, so for people who don't know, you created the company Anki that created a small robot with a big personality called Cosmo that it does exactly what WALL-E does, which is somehow with very few basic visual tools is able to communicate a depth of emotion. And that's fascinating. But then again, the humanoid form is super compelling. So like Cosmo is very distant from a humanoid form. And then the Terminator has a humanoid form, and you can imagine both of those actually being in our society.
It's true. And it's interesting because it was very intentional to go really far away from human form when you think about a character like Cosmo or like WALL-E, where you can completely rethink the constraints you put on that character, what tools you leverage, and then how you actually create a personality and a level of intelligence interactivity that actually matches the constraints that you're under, whether it's mechanical or sensors or AI of the day. This is why I almost was always very surprised by how much energy people put towards trying to replicate human form in a robot, because you actually take on some pretty significant kind of constraints and downsides when you do that. The first of which is obviously the cost, where it's just the articulation of a human body is just so like magical in both the precision as well as the dimensionality, that to replicate that even in its reasonably close form takes like a giant amount of joints and actuators and motion and sensors and encoders and so forth. But then you're almost like setting an expectation that the closer you try to get to human form, the more you expect the strengths to match, and that's not the way AI works. Is there's places where you're way stronger and there's places where you're weaker, and by moving away from human form, you can actually change the rules and embrace your strengths and bypass your weaknesses.
And at the same time, the human form like has way too many degrees of freedom to play with. It's kind of counterintuitive, just as you're saying, but when you have fewer constraints, it's almost harder to master the communication of emotion. Like you see this with cartoons, like stick figures. You can communicate quite a lot with just very minimal, like 2 dots for eyes and a line for a smile. I think like you can almost communicate arbitrary levels of emotion with just 2 dots and a line.
Yeah.
And like that's enough. And if you focus on just that, you can communicate the full range. And then you like if you do that, then you can focus on the actual magic of human and dot line interaction versus all the engineering mess.
That's right. Like dimensionality, voice, all these sort of things, they actually become a crutch where you get lost in a search space almost. And so some of the best animators that we've worked with, they almost like study when they come up, kind of in building their expertise by forcing these projects where all you have is like a ball that can like kind of jump and manipulate itself, or like really, really like aggressive constraints where you're forced to kind of extract the deepest level of emotion. And so in a lot of ways, when we thought about Cosmo, it's like, you're right. Like if we had to like describe it in like one small phrase, it was bringing a Pixar character to life in the real world. It's what we were going for. And in a lot of ways, what was interesting is that with like WALL-E, which we studied incredibly deeply, and in fact, some of our team were, kind of had worked previously at Pixar and on that project. They intentionally constrained WALL-E as well, even though in an animated film you could do whatever you wanted to, because it forced you to like really saturate the smaller amount of dimensions. But you sometimes end up getting a far more beautiful output because you're pushing at the extremes of this emotional space in a way that you just wouldn't, because you get lost in the surface area if you have like something that is just infinitely articulate.
You mentioned aliens, very important topic. Do you actually think about this? There's been an increased interest, and there's been increased UFO sightings and encounters, all that kind of stuff. The U.S. government at least releasing data, releasing videos of pilot observations and from airplanes of UFOs. Do you think about this kind of stuff? Because you mentioned in the following context, you mentioned like our humans will get our shit together when the aliens eventually come.
Yeah.
What do you make of all the sightings? Is that something you think about?
I thought about it a lot when I was younger. And I made my conclusions, and yeah, I don't think that there's a possibility that there aren't aliens. I would think it would be impossible for there not to be aliens. I feel like this is pretty good real estate. So,
yeah,
you'd probably want it, but we already might be. Well, I don't even think might. I mean, it's probably quite likely that we are to some degree aliens. I mean, all life is probably to some degree alien.
I like the real estate, so the resources, but we're also kind of interesting.
Yeah.
Whatever this ant colony of living organisms that we've created, it's kind of interesting to study. I tend to believe that the alien civilizations that are going to reach us or have reached us are far more intelligent, just orders of magnitude more intelligent than us. And so it's going to be very difficult both ways, actually, for us to understand them and for them to dumb themselves down enough to understand us.
Yeah, probably.
So they might even just miss our existence altogether, just because I tend to believe, I don't know what you think, that we're not that special in terms of all the life forms in the universe. There's a lot of cool stuff out there, and
has to be.
But to us, we're special.
Yeah, well, that's all that matters, right?
Yeah. Even the human species is the most special to us humans. There could be much more special species here on Earth they were just totally oblivious to, like trees on a scale of thousands of years. Maybe they're like, they're onto something.
Lex, I think that so much of what makes a person special is what they pass on, your kids. But I think that you are quite special because you're part of this thing that's potentially giving birth to the next thing.
The robots.
The robots.
I should say, the funny thing is, while talking to Devon during this podcast, I had a doorbell ring, had to go downstairs, and there was a big box, menacing box with a new legged robot. So the hilarity of you saying that is because that robot is actually going to likely be the main robot that I show to the world in the coming months, because that's the highest compute level in that robot. So I've been playing a lot with legged robots, the 4 legs, so like a dog. I like all robots, but there's something about when a robot has legs, it's able to communicate, it's able to connect with humans in some kind of deep way, in the way a dog can. Just show affection. Something about like step, 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 and then the robot realizes you're here, and then it steps and then notices you in the way the dog does and raises its head. It makes me feel noticed and heard in the same way I do when a dog notices me. That excitement, that stupid excitement of like, yes, fellow living organism. And what excites me about legged robots is that, holy shit, it's possible to engineer this. It's possible to create that feeling. And I wonder where that can go. There's a lot of negative possible trajectories, but I have a sense that there's positive ones too.
You
Add
think
more
that
love
they'll
to the
take
world.
us with them?
Yeah, I think so, because there's this fear of robots that they become super intelligent and run away from us humans, and basically become so intelligent, and then they almost just not giving a damn will destroy us. But I think in order for robots to become intelligent, they have to integrate themselves with society. So they by the very nature of how they become intelligent, have to bring us along. So it's not that there'll be this separate thing. They have to, like, we'll have robots in the home. They'll be interacting with us. You have human kids, and you have a bunch of robots. You have robot friends. You have human friends, and the robots make your human-to-human relationships much more meaningful and richer. They bring more love to the world, but it's integrated. It's not like they'll be developing smarter and smarter as like sentient beings by themselves. I think that's very difficult to do. You have to be doing that together with humans, and so we'll come for the ride. There's technical things, like we might merge like cyborgs more and more.
Well, we already saw our cyborgs, right?
With the phones and so on, but more and more. So with Elon and Neuralink, deeper integration of robots and AI into increasing the bandwidth at which they can communicate.
Right.
So if we do implants in the brain, I think, again, a lot of people are really nervous about this, as am I, but I think there's a lot of trajectories that are positive there. And that to me is exciting. And also, I just don't think it's possible to stop this development. So we should steer it.
Yeah. Yeah.
For good.
Did you, I mean, you must have watched the movie Terminator, right?
Yeah, of course. I love Terminator.
Yeah.
I love Schwarzenegger.
My favorite movie of all time. Yeah. Yeah. I mean, that's the big fear, right?
Yeah. What's the conclusion with Terminator? Isn't ultimately humanity wins?
I think they're at like Terminator 8 now.
Yeah.
I don't know.
Yeah. So there, and it's interesting, actually, I was going to bring this up as you were talking about it, but both China and the United States, I actually don't know where Canada is on this, but they both have agreed that they're not going to put limits on autonomous weapon system development.
They're not going to.
They're not going to. So because China said we're not going to, and now U.S. officially announced that we can't.
Well, you can't. It's like, you never could, right? As soon as it exists and it's better, people will use it.
Well, but there's been a global ban on bioweapons. So you were able to come to an agreement there that we're not going to use biological weapons in war. So it's a lot of people are really upset that in the case of AI driven weapons, the world said, nope, that's okay. And so now you have this potential for greater and greater automation in drones, for example, and picking bombing locations.
Yeah.
And so the area at which they attack. And so you get some of that stuff that you mentioned that drew you to the military is that teamwork between humans, that decision making. So there's strategy, but built into that team is a deep humanity. Like,
yeah,
even when there's an enemy, there's lines that you are aware of what is ethical and what is not, what is just and what is not. And it's so easy for a machine to miss all of that, plow through it, and do deeply inhumane acts, commit atrocities. That's something that worries a lot of people.
Yeah.
Because an AI-based war is just it's terrifying, especially with cybersecurity, which is becoming more and more of an issue, which is hacking.
Yeah,
sort of people that look a lot like me being the warriors of the future.
Yeah,
which is meaning people behind a keyboard versus versus the traditional warriors.
Probably inevitable.
And terrifying.
It is. But I think if you believe that it's possible, it's certainly going to happen. Like at some point, it's just when, right? When does it happen? Anyway.
So that, I mean, to me, I'm ultimately optimistic about the future. And to me, I'm excited about the world with AI. I'm even excited about the metaverse and all these kinds of things, living more and more in the digital space, in the virtual reality. I think, so part of me that grew up in the non-internet world, non-computer world, it says, oh, kids these days with their video games, there's part of me that's like that. But I think when technology at its best can bring out the best of humanity. And so I think virtual reality, all of these things over time, we'll figure out how to fix it to bring out the humanity. Social networks, the first generation social networks, now Facebook, Twitter, and so on, they have so many problems. They're bringing out the worst in people. But I think we're learning from that. And I think the next generation of social networks will be better and better and better. And so I'm optimistic. But of course, one reason we may have not seen aliens yet, obviously, like in a way that's obvious, is because once you get clever and smart and have all this cool technology, you destroy yourself. And we sure as humans are pretty close to that.
Yeah, there might be that limit that is hard to get right.
I'm hoping we get all our aggression between nations out through arm wrestling competition.
Right?
Just all of that.
Oh my God. Wouldn't that be great if it was that simple? Yeah.
Do you know if there's another over-the-top type movie to be made?
Oh yeah. There's always stuff in the works. There's actually there's a tournament called Over the Top in Australia that's a couple months away. I think they're doing it all the over the top scene, but there are arm wrestling movies that are being made right now. Actually, there's a documentary that's filming me for this whole Yvonne thing, but Yeah, we're probably due for another big one. Yeah.
But you're also, just with your YouTube channel, you're doing a lot for the sport. That's really cool to see. Just being genuine, but just being like, looking not like you're looking today, but just like, just a beard.
Yeah.
Just like sleepy, you know, and just putting yourself out there completely as you are. That's a beautiful thing.
The best thing about the sport is it brings people together. That's it.
Yeah. The community, the folks I got to interact with, just so awesome, so excited, so full of kindness. I'm definitely going to find the club here and start working on my arm wrestling game. Devon, this is such a huge honor that you would spend your valuable time. You would come down to Austin. You would hang out with me and do this conversation.
Super cool to talk to you, Lex. Yeah.
As I mentioned, in case people I'm sure will tell me. So I hang out with Joe Rogan all the time. He's a friend. I told him that he should talk to Devon. He's going through some stuff currently, but I'm sure I hope the conversation between you, Devon, and Joe happens eventually. That would be epic as well, because he's
he loves fighting.
He loves fighting. He loves wrestling. He loves strength. And I think all of those are so perfectly encapsulated in the sport of arm wrestling. So thank you so much for talking today, brother.
Thanks so much, Lex.
Thanks for listening to this conversation with Devon Larratt. To support this podcast, please check out our sponsors in the description. And now, let me leave you with some words from Miyamoto Musashi. The only reason a warrior is alive is to fight. And the only reason a warrior fights is to win. Thank you for listening, and hope to see you next time.
And maybe even more broadly, and looping back to something we said earlier, I don't know that getting humans off this planet and, spreading like bacteria is what we're supposed to be doing in the first place. So maybe we can go, but should we? And I'm probably an unusual person for thinking that in my industry, because humans want to explore. But I almost wonder, are we putting unnecessary obstacles, like we're very finicky biological things, in the way of some more robotic or, more silicon-based exploration? Do we need to colonize and spread? I'm not sure.
We're just not competent yet to talk about these kinds of absolutes.
Yeah, so I agree with you that a lot of technologists sort of lack this basic respect, understanding, and love for humanity. There's a separation there. The thing I'd like to push back against, it's not that you disagree, but I believe you can create technologies, and you can create a new kind of technologist, engineer, that does build systems that respect humanity, not just respect, but admire humanity, that have empathy for common humans, have compassion. It's not impossible.
I mean, no. I think, I think musical instruments are a great example of that. Musical instruments are technologies that help people connect in fantastic ways. And that's a great example. My invention or design during the pandemic period was this thing called Together Mode, where people see themselves seated sort of in a classroom or a theater instead of in squares. And it allows them to semi-consciously perform to each other as if they have proper eye contact, as if they're paying attention to each other non-verbally. And weirdly, that turns out to work. And so it promotes empathy, so far as I can tell. I hope it is of some use to somebody. The AI idea isn't really new. I would say it was born with Adam Smith's Invisible Hand, with this idea that we build this algorithmic thing, and it gets a bit beyond us, and then we think it must be smarter than us. And the thing about the invisible hand is absolutely everybody has some line they draw where they say, no, we're going to take control of this thing. They might have different lines, they might care about different things, but everybody ultimately became a Keynesian because it just didn't work. It really wasn't that smart. It was sometimes smart and sometimes it failed, And so if you really, people who really, really, really want to believe in the invisible hand is infinitely smart, screw up their economies terribly. You have to recognize the economy as a subservient tool. Everybody does when it's to their advantage. They might not when it's not to their advantage. That's kind of an interesting game that happens. But the thing is, it's just like that with our algorithms. You can have a sort of a Chicago economic philosophy about your computer and say, no, my things come alive. It's smarter than anything.
I think that there is a deep loneliness within all of us. This is what we seek. We seek love from each other. I think AI can help us connect deeper. Like this is what you criticize social media for. I think there's much better ways of doing social media that doesn't lead to manipulation, but instead leads to deeper connection between humans, leads to you becoming a better human being. And what that requires is some agency on the part of AI to be almost like a therapist. I mean, a companion. It's not telling you what's right. It's not guiding you as if it's an all-knowing thing. It's just another companion that you can leave at any time. You have complete transparency and control over. There's a lot of mechanisms that you can have that are counter to how current social media operates, that I think is subservient to humans, or deeply respects human beings and is empathetic to their experience and all those kinds of things. I think it's possible to create AI systems like that. And I think that's a technical discussion of whether they need to have something that looks like more like AI versus algorithms, something that has an identity, something that has a personality, all those kinds of things.
And it's not the ones that destroy us, but somebody that you can have as a friend.
Oh,
you can have deep connections with, that kind of passing the Turing test and beyond. Those kinds of ideas. Have you dreamt of those?
Oh, yes.
Those possibilities.
In a book I wrote with Ed Feigenbaum, there's a little story called The Geriatric Robot. And how I came up with the geriatric robot is a story in itself. But here's what the geriatric robot does. It doesn't just clean you up and feed you and wheel you out into the sun. Its great advantages, it listens. It says, tell me again about the great coup of 73. Yeah. Tell me again about how awful or how wonderful your grandchildren are, and so on and so forth. And it isn't hanging around to inherit your money. It isn't hanging around because it can't get any other job. This is its job, and so on and so forth. Yeah. Well, I would love something like that.
Yeah, I mean, for me, that deeply excites me. So I think there's a lot of us.
Lex, you got to know, it was a joke. I dreamed it up because I needed to talk to college students and I needed to give them some idea of what AI might be. And they were rolling in the aisles as I elaborated and elaborated and elaborated. When it went into the book, they took my hide off in the New York Review of Books. This is just what we have thought about these people in AI. They're inhuman. Oh, come on, get over it.
Don't you think that's a good thing for the world, that AI could potentially?
Moi, I do, absolutely. And furthermore, I want, I'm pushing 80 now. By the time I need help like that, I also want it to roll itself in a corner and shut the fuck up.
Let me linger on that point. Do you really, though?
Yeah, I do. Here's why.
Don't you want it to push back a little bit?
A little. But I have watched my friends go through the whole issue around having help in the house. And some of them have been very lucky and had fabulous help. And some of them have had people in the house who want to keep the television going on all day, who want to talk on their phones all day. No.
So basically,
just roll yourself in the corner and shut up.
Unfortunately, us humans, when we're assistants, we care. We're still, even when we're assisting others, we care about ourselves more.
Of course.
And so you create more frustration. And in a robot, AI assistant can really optimize the experience for you. I was just speaking to the point. You actually bring up a very, very, very good point. But I was speaking to the fact that us humans are a little complicated. That we don't necessarily want a perfect servant. I don't. Maybe you disagree with that, but there's I think there's a push and pull with humans.
Mm-hmm.
A little tension, a little mystery that. Of course, that's really difficult for AI to get right. But I do sense, especially in today with social media, that people are getting more and more lonely, even young folks, and sometimes especially young folks. That loneliness, there's a longing for connection, and AI can help alleviate some of that loneliness. Just somebody who listens, like in person. That
so to speak.
So to speak. Yeah, so to speak. Yeah, that to me is really exciting. But so if we look at that level of intelligence, which is exceptionally difficult to achieve, actually, as the singularity or whatever, that's the human level bar. That people have dreamt of that too. Turing dreamt of it. He had a timeline. How have your own timeline evolved on past?
I don't even think about it.
You don't even think?
No. Just this field has been so full of surprises for me.
That you just take it in and see the fundamental basic
that's
science.
Great. Yeah, I just can't. Maybe that's because I've been around the field long enough to think, don't go that way. Herb Simon was terrible about making these predictions of when this and that would happen.
Right.
And he was a sensible guy.
Yeah. And his quotes are often used, right, as a
bludgeon, yeah.